Learning Linux is a necessity for anyone looking to be a database administrator, a systems administrator, or even in some cases a data scientist. Beyond all that, even if you're not looking to join any of those careers, it's a great skill to have just as a general computer and tech enthusiast. Additionally, if you're looking to get into programming, learning Linux and Bash scripting is a great first step, right? It can really help you along that journey. So, my name is Ryan Nigro, and I bring to you the course Linux Essentials. This course is going to be partnered with Eduonics. Let's jump right in. Right? Answer the question that's probably on everyone's mind, right? Why Linux? Why are we even talking about this? Well, the first reason it's a very powerful tool, right? In just a couple of days, maybe a couple of hours here, right? You're going to learn ways to automate processes that you previously would have done manually and would have taken you significantly more time. You also find out ways to interact with your computer and perform actions on your computer that would have taken you much longer that you can now do in a fraction of the time as well. Right? So Linux is very powerful. It will allow us to script. It will allow us to navigate and to interact with the computer in a way that we didn't think was previously possible. Additionally, it's also great for beginners. Right? When it comes to learning Linux, it isn't quite as intimidating as the Windows command line. It isn't quite as intimidating as learning C++ or let's say Java right off the bat. Right? So we're going to have actually a pretty good transition, right? A very nice slope when it comes to learning this tool. Right? Linux does quite a bit for beginners, and there's a lot of documentation on it. Right? And last but not least, it's also a free tool. Right? Linux is a free operating system. Bash scripting, there's tons of resources out there for it. Right? So that's just cherry on top. Sections that we'll be covering throughout this course. Right? Section 1, we're just going to give an introduction to Linux. I'll be teaching commands such as ls, cat, cd, right? And if you don't know those yet, that's totally fine. That's why we're doing the course. But just to put it in a nutshell, right, I'm going to give you an introduction to Linux that will allow you to navigate through your machine and interact with your machine strictly from the command line, right? A lot of us are used to using the graphic user interface. If we want to spin up a program, we double click it, right? But I'm going to teach you actually ways to get around that, and then also how to automate those processes so that you don't have to do the tedious tasks anymore. After that, we're going to talk about data in Linux, right? What does it look like? Where is it stored? Where do we see the processes for our machine when it's running? Where do we see how much storage we have left, right? We're going to answer a lot of those questions. After that, we'll talk about basic networking in Linux. You may have had previous experience with networking, right? But we're going to talk about in Linux, how do I find my IP address? What does that mean? How do I see all the network interfaces? We're going to dive really deep into the weeds of different commands that we can use to actually figure out and configure network settings. Section 4, this is when we talk about security and file permissions. How do we secure our data? Right, we talked previously in Section 2 about data in Linux. Now, how do we take it and make sure that only the people who should have access to it can? Right, and what does that access mean? Can someone read the contents, or can they also edit it? Can someone delete it? Right? These are the questions that we'll be answering in that section. And then last but not least, we'll be going into advanced Unix commands. This is when we'll really start utilizing the ability to pipe information from one command to the next. We'll start taking all of the things that we've learned in the first 4 sections and really putting them together to create some powerful scripts here. To go into more depth, for section 1, our introduction to Linux, we're going to go over Linux's setup and installation. For this course, we're going to be setting up Linux in what is called a VM or a virtual machine, right? The best way to think about a virtual machine, although we will dive into this in more depth later, is it is going to be another computer that is running on your system's hardware, right? Imagine you took your computer, whether it's a laptop or a desktop, and you used it to power up 2 separate machines, right? 2 different computers with 2 different file systems and 2 different ways to interact, right? So that's how we'll be setting up for section 1. We will then go into various ways to interact with the command line, such as cd, right, to navigate throughout. We'll also talk about how to list directories and files. We'll talk about searching and extracting data, and then basic commands and scripts. For section 2, we'll be going over where is data stored, right, in our Linux system. We'll talk about various types of information and how to interact with them on the system itself. Right, so the key knowledge areas here will be talking about processes, memory addresses, system messaging, and logging. Then we go into section 3. This is going to be basic networking in Linux. Here we'll give some information about the internet, right? The general internet and how it works, networking, routers, how to query DNS client configuration information, right, and more. After that, we go into security and file permissions. We'll talk about how to protect files, what do file permissions even mean, right? And how do we set them? In section 5, we're going to start to go from taking multiple steps to do commands, right? And putting it all into one line, into more complex Unix commands, what we call one-liners. Additionally, we're also going to start to modify the shell environment and start exporting and modifying the environment variables as well. Last but not least, thank you for tuning in. I'll see you in the next video. Hello and welcome to section 1. So in this video, we're going to talk you all through the setup, right? How to set your hypervisor up, as well as the actual virtual machine within your hypervisor. We're going to go over some of the basics of Linux, right? So file navigation, file creation, deletion, right? All of the things that we need to be proficient in our Linux command line systems here. Additionally, we'll talk about basic scripts, right? How to write it in our command line, as well as how to write them in text editors and potentially automate that in the future. And then lastly, we'll talk about how to find files, right? How to use the find command, search within those files, as well as some other small details such as exit statuses, input-output redirection, and piping, right? So stay tuned for all of that, but I'm excited to start up this first section with you all. All right, welcome back. So, as we spoke about before, I'm going to be showing you all how to download VMware Workstation Player for Windows in this video. I'll also be showing you how to download Ubuntu and upload it onto VMware Workstation. As I said before, the way to think about those two devices, or right, those two different tools, is VM Workstation Player, or VMware Workstation Player rather, is the DVD player, and Ubuntu, right, is the DVD we're playing, right? So to show you what I mean, when I open up the program that I will be showing you how to download in just a second, we can see that I have a couple of options here, right? VMware Workstation Player, right? This is what holds my library of what we call VMs. As you can see, I have different operating systems. I have an Ubuntu machine, right, that I've dedicated a specific amount of RAM to. I have a Hadoop machine, a Kali machine, an MX Linux machine, right? And basically what we're looking at right now is a library of different operating systems that I have uploaded to VMware. Right? A good way to think about this is it's similar to Audible, right? Audible, right, is your overall library. It's the tool you use to play audio books, right? In that same way, VMware Workstation Player, right, is our equivalent to Audible, right? And these different operating systems are basically the book equivalent, right? As I said before, right, when it comes to virtual machines, right, these are going to be miniature computers that we're running on our hardware, right? This is going to share hardware with my Windows machine, right, that we see in the background here. And I'll show you a little bit later on what I mean by that. But first, let's download VMware Workstation Player. So I'm going to type into Google VMware Workstation Player. And as I said before, this video is for Windows. Right? There is also the video up for Mac. So if that suits your operating system, feel free to click on that as well. I'm going to type in Windows. I'm going to click the first link, right? And when we get there, we're going to see download VMware Workstation Player. It's going to say contact us. We don't want to contact them. So I'm just going to scroll down a little bit, just go straight to download. Right, and we see here two options, one for Windows, one for Linux. As I said before, there is another video up that is specifically for Mac. The process is a little bit different because you're technically using a different version of VMware. We're not going to be using Workstation for Mac. We're actually going to use Fusion, right? And both will work perfectly fine. I just want to show for the setup those different steps. I'm going to hit download, right? And as you see here in the bottom left corner, we're going to see that download start. Now, for most of us, when we hit download, right, our default download location is going to be to our actual downloads folder, right, as you can see right here. I'm going to cancel this one, right, because I've already downloaded that program, right, but you all, of course, would let that go to fruition. So we see right in my downloads folder, I see VMware Player Full 16.2.1. That's the version number of the program we just downloaded. I'm going to double click that. I'm going to hit yes for do I want to allow this app to make changes, right? Those changes are going to be, it's going to download. Now we're just going to wait a couple moments and it should pop up the installer, right? And that installer is what we're going to use to configure our program here. Right. Now we see this setup wizard. I'm going to hit next. I'm going to accept the terms in the license agreement. I'm going to hit next one more time. For this pane, I'm going to leave the defaults, right? I don't want the enhanced keyboard driver, right? It's not necessary for this course. And then also, I want to make sure that VMware Workstation Console Tools is included in my system path. So I'm going to hit next. This one is up to personal preference, right? Join the VMware Customer Experience Improvement Program. I'm going to uncheck that. What that just means is whenever you run into problems with your VMware Workstation Player program, it'll send it to VMware so that they can analyze it and improve the program. You can leave this checked or unchecked. I typically leave it as unchecked just so I don't have any more information leaving than I need. I'm going to leave the top one checked. This is just going to give us updates whenever we start up our machine, which I am a fan of. I'm going to hit next. This is another personal preference one, right? Do you want to create a shortcut on your desktop? Do you want to create a shortcut on your start menu program? I'm going to leave both checked, right? I want both of those things. For those who are unfamiliar with the start menu programs folder, what it really means is if you leave this checked in, I'll be able to go to the search option here. I'll be able to type in VMware, right? And I will see my program pop up, right? And I'll hit next one more time. Last but not least, for you all, it will say install. For me, it says upgrade because I already have the program. You should hit install. It'll take a couple moments, and then you are good to go. So let me quit out of this and show you what will happen, right? What you will get out of this. So once you are done installing, you will be able to type into your search bar here, VMware Workstation, right? Or just VMware, and it'll pop up. You'll also be able to access this on your desktop, assuming you left that check mark, right, for your desktop icon. When you open it up, your program is going to be empty, right, because you will not have any virtual machines. Mine, of course, has a couple because I've been using this program for quite some time now, right? So this is step one, right? This is the first thing we have to download. Step two, the second thing we have to download is going to be the actual VM, the actual virtual machine that we will use this program to run. I'm going to open up another tab in Google. I'm going to look up Ubuntu, download, and hit enter. Right, and we're going to go once again to the first option on Google, download Ubuntu desktop. Right, 20.04.4.3, right, this looks perfect. I'm going to download it, right, and it will pop up in the bottom left corner once the download starts, right, and we see that. This download's going to take a little bit longer, right, I'm going to cancel this one as well because I already have it, right, this download's going to take a little bit longer, probably around, depending on your connection, 5 to 10 minutes. So once Ubuntu has downloaded, what we can now do is we can go to VMware Workstation Player, right? I'm going to open this up. We can hit create a new virtual machine, installer disk image, right? We're going to hit browse, and you're going to need to navigate to Ubuntu 20.0.04.3, right? The ISO image that you have downloaded before. And I'm going to double click that. Next up, we're going to hit next. Put your full name in. I'm going to put in Ryan. Username, I'm going to put Ryan as well. Password, I'm going to type my password in. Right, yours will obviously be different depending on what your preferred password is. Right, just make sure those two match. We're going to hit next again. Virtual machine name, you could just name this Ubuntu, right? The default works as well, right? This is going to be arbitrary, just whatever allows you to recognize this machine and differentiate it from other machines that we'll be adding. I'm going to hit next one more time. So the next thing it asks us is for disk capacity. This is asking what or the amount of storage you will need for your VM. For the purposes of this course, 20 gigabytes will be perfectly fine. We're not going to be downloading major programs. We're not going to be downloading videos, right? So this amount of storage is actually pretty good. And keep in mind that you need this amount of storage on your host machine to be available. Next up, it's going to ask, do I want to store the virtual disk as a single file or split it up into multiple files? Right? The reason we split it up into multiple is it's actually going to make it easier if you ever need to move your VM from your host machine that you're using right now to a future machine, or if you're backing it up, right? So split virtual disk is the best way to go here. Customizing hardware, do not worry too much about this, right? We can always customize our hardware after the fact, right? The only thing that you cannot customize, right, or is a bit of a pain to actually modify after the fact is going to be this maximum disk size here. So I'm going to hit finish, right? And I also left it checked to run the VM once it's done. And it's going to go through this setup process. My Ubuntu machine just finished installing. I now see Ryan listed. And as I mentioned before, when I hit this, right, when I make this smaller and then enter full screen, now we can see the entire screen is now covered, right, now that the installation is done. I'm going to hit the account I made before, type in my my password, And I will now be logged into our Ubuntu machine. Just a little quick synopsis. We have Firefox here. We also have our file structure right here. And this file structure is going to be a little bit different from Windows, but really not all that much. It's going to be similar in the sense that we see documents and downloads and music, right? So a lot of similar folder names, right? Other than that, last but not least, the only other thing I'd like to introduce is by hitting the bottom left corner, right, this little icons tab, we can go up to the search bar, hit terminal, and we can open up our terminal. Just to close out, in order to shut this machine down, you could do it one of two ways. You could either hit the power button up here, hit power off, like that, or you could just quit out of this by Xing out on the box here. Right? You see that little X mark, right? You could hit power off as well, right? So two different options, and both will do the same thing. Right? Just keep in mind, as soon as you turn it off, your VMware Workstation Player window will close as well. So thank you all for tuning in. In the next video, we're going to be talking about some more commands, right? And start teaching you how to work with the terminal. Hello and welcome. So in the last video, I showed you all how to download VMware Fusion as well as the Ubuntu VM in Windows. For this video, I want to walk you all how to do it in Mac OS, just in case that is your OS of choice. So step one, look up VMware Fusion. We're actually going to be using a different version of VMware. They have a completely different VMware version set up for Mac specifically. You're going to scroll down, go to Run Windows and More on Mac VMware Fusion. This is going to bring you to a page where it prompts you to buy, but we're allowed to get our own personal license for free. Now, when we click on that, register to get our key now, one thing you're going to have to do, right, is once you click on license and download, you're going to be prompted to log in, create an account, right, in order to get this download running. So once you log in and create an account, down here, that download will populate. So of course, I will not demo that part, right? That should be pretty straightforward there. Feel free to let me know if you all have any challenges in this particular piece. Once VMware is running for you all, what you should be able to do now, right, is type in VMware Fusion, right, and open up the app. Right, what it will look like is you'll have in this top bar, right, this little library app. You'll also be able to basically pop up it from your applications folder like you normally can with most of your other Mac OS applications, right? And the way we boot up our Ubuntu machine, right, is first we have to download it, right? And then we'll add it to this library, similar to the Windows process. So step one here, right, I'm gonna go back a couple steps, is looking up Ubuntu download, scrolling down, getting past the ads, right? Clicking download Ubuntu desktop, clicking on download next to Ubuntu 20.04.3 LTS. And then last but not least, our download is going to start in the bottom left corner here. You can see the one that I downloaded previously. This download will take you all probably around 20 to 30 minutes, depending on your network connection, right? But feel free to pause the video, wait those 20 to 30 minutes out, and then come back when you're ready. For those who are ready to move forward, what you can now do is you could open up the library, right, for VMware Fusion up in this top bar here. I have my icon. You can hit create new virtual machine. And I'm just going to drag this from my second monitor over, and you'll be shown this window right here. All you have to do is double click install from disk or image. We have an ISO image that we'll be installing from. So I'm going to double click here. I'm going to hit use another disk or disk image, and I'm going to find my ISO that I have just downloaded right here and double click that. Once that is booted up, right, I see right here, Ubuntu 20.04.3 ISO. I'm going to hit continue. Display name, account name, all looks good. I'm going to add my password as well. Hit continue. And then last but not least, I'm going to hit finish. Right? You can customize these settings. I would say that these default settings are usually pretty spot on. The difference between this machine and the Windows machine, Windows requires us to be a little bit pickier with the settings, whereas this looks pretty good. If you're having performance issues, what I will say is you can increase the amount of memory you're using, depending on how strong your actual hardware is for the machine you all are using. For most Macs, though, I think 4 GB should be sufficient, right, in 2 CPUs. Right, hit finish, save. This is going to save it to your virtual machines folder, which it creates for you. And you'll see right away, this machine will boot up. So fairly simple process. Honestly, in a lot of ways, this process is much simpler than it is for Windows. The only thing that's a little bit trickier is downloading VMware Fusion itself, because you have that added step of creating an account before you can do it. But right here, you're going to see some installations, right? And if you get this far, that means you are successful. Right, so if you got this far, then you are good to go. Your machine is properly set up. It's going to do a couple more installation steps. It's really just configuring just a couple more settings, but you're ready to go and to continue with the course. So I'll see you all in the next video. Hello and welcome. So today I'm going to be giving us an introduction to the Linux command line, right? And in a nutshell, what we're going to talk about is we're going to go over general command syntax, how to navigate in the command line, how to create and delete files, and then last but not least, how to move and copy those files. First up, let me actually delete this and start from the beginning. What I'm going to do is in the bottom left corner of my Windows machine, I'm going to hit the search bar and I'm going to type in VMware, right? This is how I boot up my application. For you all, it may be on your desktop. You may do it the same way, right? Whichever way you open it usually is the best way to do it here. Next up, I'm going to double click on my Ubuntu box. I currently have it open. I'm going to actually close it out real quick and start it up from scratch, right? But you all should only see one machine, right? Because in the last video, we only booted up one machine. For you, I'm going to have a couple, or right, as you see here, I have a couple. We're going to choose the one machine we have, our Ubuntu box. It's going to load for a little bit. It's going to take a moment. One thing to note here is it's important to remember the password that you first generated the box with, right? When it came to downloading that ISO file from the previous video, uploading it to VMware and running our VM, it's important for us to remember the password that we configured this account with, right? We see this Ryan account, and Ryan is actually the username here, and I will put my password in. Perfect. Next up, I'm going to hit this icon to make this full screen, make this a little bit bigger for us. All right, so now we are in the Ubuntu desktop. Now you might notice a difference between your left bar and my left bar, right? My left bar actually has the terminal here. I'm going to remove this and show you how to get it there, how to get it added to your favorites list. Well, first up, you could click in this bottom left corner. In the search bar, you could type in terminal, and then you can right click and hit add to favorites, right? And this will add it to the quick start bar that you see to the left here. So I'm going to click escape, and we see it now in this quick start bar. I'm now going to open up my terminal. I'm going to snap it all the way to the right. I'm going to hit Control Shift plus to make the font a little bit bigger for you all to see. And we have now opened up our terminal, right? And to teach you all the first command, what we can do is we can use a command called ls, right? It stands for list, or more specifically, list segments. And all it's going to do is it's going to list the contents of the directory we're currently in. And I'll explain in a moment what I mean there. Let's just see what it looks like. All right, so I'm typing in ls, I'm going to hit enter. And I see desktop, downloads, pictures, templates, documents, right? A bunch of different folders right here. Now to explain what this means in the context of how we usually use computers, right? You're probably used to using computers by going to this icon right here, right? This file explorer, clicking on it, and then double clicking through all these different directories, right? To navigate around. We're going to do the same thing today, but only using the command line, right? We're not going to use the graphic user interface for it, right? So you see how we have this documents folder here, and we can double click into it, and then we can read this text file. We're going to do the same exact thing in our command line, right? So what I'm going to do, right, is as you can see here when I did ls, I see all of the same contents as I do on the left. That means that I'm in the same directory on the screen to the right as I am to the screen to the left. And I'm going to use a command called cd, or change directory, to go into it. So remember, if I just went into my documents directory on the left here using what we call the graphic user interface, or the GUI, what's the name of the directory that I should type into the right side here in order to get that to that same location? Right? You probably guessed it, right? Documents. Now, if you're wondering how I auto-completed there, I actually just hit the tab key after typing a couple letters in. That's something that's going to save us a lot of time, hassle when it comes to spelling, right? So just keep that in mind, right? But I'll type it out all the way just for the sake of keeping things well-paced. So to talk about what we're doing here, right? Before I did ls, and in the current directory I was in, we saw all of these contents. Now I'm using the command cd, which stands for change directory. I'm going to change directory and go into, as we see on the left here, my documents directory. I'm going to hit enter. Now I want you all to pause the video, right? And I want you all to guess what's going to happen when I enter ls again and hit the enter key, right? What's going to show? All right, so take a moment to pause the video. Well, welcome back, right? If you guess that you're going to see the readme.txt file like we do on the screen to the left, you're absolutely correct. I'm going to hit ls, and as we see readme.txt. Now, in order to read this document how we normally do, right, we're used to double clicking it and then it popping up here, right, the text. But we don't have that option in the command line. There's nothing to click here. So instead, I'm going to use the command cat, C-A-T, right? Cat, like a house cat. And then I'm going to type in the file I want to read, right? I'm going to put this readme.txt file in. So I'm going to type in read and hit tab to autocomplete and then hit enter, right? And as you see, the contents we're reading on the left are exactly the same as the contents we're reading on the right. Now, let's say I don't want this file anymore. I actually want to remove the file, right? I want to get rid of this readme.txt. I don't need it anymore. I want to clear up some space. What we can use is the rm command, right? So I'm going to type in rm, type in readme.txt, and I'm going to hit enter. And now I don't know if you all noticed, right? Feel free to rewind to see what just happened. But on my screen to the left, that file just disappeared, right? So using only my command line, I just deleted the file entirely, right? So using this rm command, which stands for remove. So we have just taught you all 4 commands. ls, which is list the contents of the current directory we're in. We learned cd, which is change directories. We learned cat, which is read file contents. And then last but not least, we learned rm, which stands for remove. Let's recreate the file we just deleted, right? I'm going to use a command called touch. I'm going to type in touch, and I'm going to type in readme.txt. What the touch command does is it actually is going to create a file with the name readme.txt. The only thing is that file is empty, right? So when I hit enter, pay very close attention to the screen on the left here. Right, as you see, readme.txt has now come back. I'm going to type in cat readme.txt. I want you all to guess, when I hit enter, what is this going to read? What is this going to print out? Right, take a moment to guess that. Right, when I type in cat readme.txt, what's going to happen? Okay, got your guesses? Let's see. When I hit enter, nothing happens. Why is that? Let's check on using the computer the way we usually do. Let's open it. It's because it's a blank file, right? We removed the file with text, and then we recreated an empty file with no text, right? So, touch, new command, right? Keep that in mind. As you're probably noticing, when it comes to command syntax, this is what we're seeing. We see the name of the command, and then what we call an argument, right? The argument is what we are referring to. When I say remove, right, remove is the command. RM is the command. The argument is what I am referring to when I say RM, right? If I just said RM, like let's say I just typed in RM and hit enter, it's going to say missing operand or missing, basically argument. And the reason for that is it doesn't know what to remove. We need to specify it. However, if I type in rm readme.txt, it knows, okay, I'm running this command on this argument, right? And once again, check to the left, we see that file disappear. It's the same thing with touch. If I just type in touch and hit enter, it's going to say missing operand. In order for me to create an empty file, I actually need to name it, right? So I'm going to do touch. I'm going to name this empty file.txt and recreate that on the left here. So I want you all to take a moment. I want you all to practice creating files, deleting files, and then I'm going to show us one more thing in just a second. So please take a moment to pause the screen. The goal is for you to create and delete a file in your documents folder, right? So try to navigate solely using your command line, right? Get into your documents folder and to do that. Thank you for tuning in. I will see you all in the next video. Hello and welcome back. So in the last video, I gave you the task of trying to create and delete a file in our documents directory. If you've not had a chance to do that, please pause the video now and attempt that. right? As a quick reminder, the two commands you're going to need to use are going to be touch and rm, right, to do the creation and deletion process there. So please pause the video, and once you get that done, we will segue into the next part of the video here. All right. Now that we had a moment to do that, let's talk about maybe some common issues we ran into. It may have been the case, I'm going to clear my screen by typing clear and hitting enter. It may have been the case that you all went into the wrong directory. Let's say I cd into desktop, right? And I hit enter, right? And I hit ls, right? Desktop is empty. There's nothing in here. How do I get out of my desktop directory? Well, what I could do is I could use a saved keyword that Linux understands. I could do change directory, and instead of giving a name of the directory I want to change to, right, I can give double dots, right? What exactly does this mean? Basically, the first dot stands for, if I just put one dot, it stands for this current directory, which is my desktop directory. Double dot stands for the parent directory, right? So if you ever need to go one directory back, right, you would do cd ... to switch back to that parent directory. When I hit enter and ls again, right, we can see I'm now in the previous directory I just came from. To explain in a little bit more depth what I mean by this, right, when you switch directories and use cd, you can only switch to directories that are available to you given where you are, right? So when I did ls before, I see that desktop, documents, downloads, pictures, I could cd to all of these different directories. However, if there was another directory that was a couple layers deeper, I wouldn't be able to directly switch into that, right? So that's just something to keep mindful of, is that when it comes to directory navigation, you have to go step by step, right? And let me show you this, and feel free to not follow all these commands, right? I'm just going to check, or I'm just going to create a directory real quick to demonstrate my point. Let's do make directory. I'm going to do new dir. Okay. So what did I do? I made a directory. It's in my downloads folder, so I'm going to do ls. I just made a directory in my downloads folder called new dir. I'm going to try to cd to that. I'm going to try to change directories to new dir. When I hit enter, it's going to say no such file or directory. Why does it say that, right? I know new dir exists. Why is it telling me this? Well, it's telling me this because of the directory I'm currently in, right? I'm currently in a directory that doesn't see new dir. I actually have to go one layer deeper. So what I need to do instead, since I know new dir is in the downloads folder, I'm going to do cd, downloads, hit tab, and then new dir, right? In order for me to get into that directory, since it's one layer deeper, I need to specify this path here, right? I have to give the computer, right, a way to find what I'm actually specifying, what I'm looking for. Now when I hit enter, keep note, right, I now see, and you can tell by this blue extension to our tilde, I now see I'm in the downloads new directory folder. To go back, I want us to guess, how do I go back to just the downloads folder? I don't want to be a new dir, right? Take a moment to pause and to guess. All right, if you guessed by doing cd ... you are correct, right? We can now see I have backspaced out of the new dir and back into the downloads. Let's do cd ... one more time. And as you see, I am back to our starting point. All right. Last thing I want to show us all for today is I'm going to show us how to print our working directory, how to copy files, and how to move files. So what I could do here, right, is if I do pwd, this stands for print working directory. If you're ever lost and you're not sure which directory you're in, you can do pwd and it will tell you, right? So right now, as we see, we are in the home Ryan directory, right? Let's so we're in the home, right, Ryan directory. Let's go to documents. What I'm going to do is I'm going to switch directories now. I'm going to go cd, let's go to desktop, and I'm going to do pwd again, right? Now we can see I'm in the home Ryan desktop directory. So keep in mind, pwd is going to give us an indication of where we currently are in our system, right? It's a little bit harder for us to keep track of where we are because we don't have a graphic user interface with our terminal, right? So just keep that in mind, that this is a good way to work with that. Let me see, can I make this? Let's go back one. All right. Next up, two more commands, and we'll call it a wrap on this video. I'm going to do clear, right? Type in clear and hit enter to clear my screen. You could all do the same. I'm going to make a new file once again. I'm going to do touch new file .txt. I'm now going to show you a command to copy new file, right? If I wanted to make an exact copy of this new file, what I could do is I could use the cp command. I name the file that I want to copy, and then I'm going to name where I'm sending it to. So the cp command is going to take in 2 arguments, unlike some of our other commands. It's taking in the file I want to copy and what I want to name the copied file, right? And I'm going to hit enter. Now if we go, let's look to desktop here, right? As you can see here, I now have 2 files in my desktop, right? If I type in ls to list the documents, I now have 2 files, and that means that it is successful, right? The cp command. This will also copy the contents of the files as well, so just keep that in mind. All right, last but not least, let's talk about the mv command, right? How do I rename files? Well, it's, as I just spoiled it, with the command called mv, right? Typically, this file is used for either moving files or renaming files, right? It can be used for both. So like, let's say I have new file here, right? And I want to move this to, let's say I want to move it to my documents folder. What I could do, or excuse me, let's make a new directory. I'm gonna make a new directory. Let's do instead of documents, let's just call it files. All right. So I just made a new directory. We'll go into more depth with mkdir, what exactly we're doing there. So do not feel afraid yet. My goal now is I'm going to move both of my files into this files directory, right, for good file organization. So what I'm going to do is I'm going to type in the mv command. This stands for move, right? And this can be used to either rename files or just move them. And I'm going to do new file.txt, and I'm going to move that into my files directory, right? So I have mv, the file I want to move, where I want to move it. Now, what I get to do is I could actually change the name of this file. I'm going to name this old file.txt. So with this mv command, I'm actually doing 2 things. I'm moving the file and I'm also renaming it. And let's hit enter and observe what happens. As you see on the left here, my new file, it just disappeared, right? Where'd it go? Let's double click into here, right? It now has moved into that and has been renamed as old file, right? And if I type ls, as we see, it has disappeared here as well, right? We just see files, copied file. All right, I want you all to take a moment. If I wanted to move the copied file into this files, what would the syntax for that be? Take a moment to pause the video, write that down, and to think about that. All right, well, if you guessed mv copied file.txt and then just putting in files, you are correct. If I hit enter, as you see, the file has disappeared and both files now are in this new files directory. Before we close out the video, one thing I want us to notice, the name of copied file.txt did not change. That's because I did not specify a new name at the end here. All right, well, that is it for this video. Thank you for tuning in. Hopefully you've learned something about file navigation, file creation, file deletion, and then also copying and moving files. Right. I will tune in with you for the next video. Welcome back. So in the previous video, I showed you all how to create an empty file. I'm going to show you now how to create a non-empty file in a couple different ways, right? How do we fill this file with text? First off, let me close out. We don't need the graphic user interface anymore. We're going to use strictly the terminal now. So let me make this bigger. What we can do, so I'm going to do ls, right? I'm going to see where I currently am. I'm going to go over to my documents folder to do this work. So cd documents, and I'm going to ls there. And I see there's an empty file. As we said before, right, in order to read files, we could use the cat command. So I'm going to do cat empty file, right? And we should see that there's nothing in it. What I'm going to show you all now is how to create a file with text in it. And there's a couple ways to do it. The first way is to use a text editor. So what I could do is I could use Nano or Vim or Emacs if you have that downloaded. We're really just going to focus on Nano and Vim for the purposes of this course. And I could use what is called a text editor. The best way to think of it, if you're familiar with Windows, is it's like Microsoft Word. If you're familiar with Mac, it's very similar to Pages, right? It's just going to be a little bit weirder on the UI or the user interface here. So all I have to do to use this text editor is type in nano and then the name of the file. I'm going to name this text file.txt and hit enter. All right, now as you see, my terminal has changed, right? It looks a little bit different. Instead of being in my terminal, I'm actually now in what we call a text editor, right? So I could say, hello, this is Ryan. This file is not empty, right? Now you might be wondering, now how do I actually save this, right? I'm used to Microsoft Word where I hit File and Save and it does all that work for me. But how do I do that here? Well, if you look in the bottom left corner here, right, we can actually see some options, right? We see the exit option, we see the write option. And just to give you a little bit of a hint here, when it comes to computers, specifically, terminals, when they say write, what they really mean is save. This caret next to the O here is actually standing for control. So in order to save, I'm going to do control O. It's going to say write name to, or file name to write to, text file.txt. I'm going to confirm that and hit enter. And I've now saved my file, right? By doing control O, I'm going to do that again and hitting enter. The contents that I just typed out are now saved. Now to exit out, I want you all to take a guess. What do I have to do? Right, look in this bottom bar. What do I have to do? Well, if you guessed control X, you were correct. Do control X. And I've quit out. Now let's read the text file we just created. I'm going to do cat text file.txt. And once again, if you're wondering how am I typing this so fast, I'm not. I'm just hitting tab as soon as I put in the first couple letters and letting the terminal autocomplete for me here. Hit enter. Right, we see right here, this is the text I just put in. Let's use a different text editor. I just used nano, right, and we gave the file name. Let's use vim, and this file name is going to be text file2.txt. I'm going to hit enter. Right, once again, that command is vim text file2.txt. Now, for our version of Ubuntu, right, this is actually not going to be native. It's not going to be downloaded by default, but that's okay, right? We actually see some commands here telling us how to download, right? And we're going to use the apt command quite a bit when it comes to getting these tools, right? So I'm actually going to just copy and paste this command for now. We'll go into this later on, but to go into depth of what this command is doing, sudo stands for super user do. The best way to think about it is if you ever needed administrator privileges on your Windows machine to allow a download, right? This is the same concept here for Linux, right? We're downloading a program, and because of that, we need to do it as a super user, right? So sudo stands for super user do. Apt, this is the command we're going to use to actually install. Install is the keyword we're giving, and then vim lastly is the program. I'm going to hit enter. Now, I actually have to type in my password because when I use super user do or the sudo command, it wants to make sure that I actually have permission to do this. And as we see, it is now downloading. You'll be hit with this prompt, Y or N. I'm just going to type uppercase Y and hit yes. I'm going to let that run for a minute or two. Should be relatively quick. So if you let this spin up, right, congratulations, you have now downloaded your first command using the sudo apt command, right? Or we use both sudo and apt. So now let me clear my screen. Instead of rewriting the vim command I did before, I'm actually just going to hit the up arrow key, right? Show you a little shortcut. I'm going to hit the up arrow, right? You can see the up and down arrow key to go back to that vim command I just had. And I'm going to do vim textfile2.txt again. I'm going to see if I still get an error. Oh, sorry, I accidentally added that slash at the end. If you're wondering how I quit out of that, I just did Control C. Now, when I hit enter, right, we're now in the vim text editor. You might be wondering, well, like, I don't see those helpful commands at the bottom. What do I do here? So this text editor is much less user-friendly, right? So be cautious of that. In order for us to quit out of this editor, we actually have to hit the escape key, shift colon, right? You can see the colon actually generate here, and then the Q key if we wanted to escape out. And then lastly, enter. Right? It's much less beginner-friendly, to be quite frank, when it comes to vim. I'm going to reopen this file, and let's add some text. Another thing you're noticing, if you try to write hello, right? I don't know if you actually heard it actually didn't start typing until I accidentally hit a key, right? Let me show you this again. Oop. Let's do that. Oop. Q, right? I don't know if you all notice, but when I hit keys, right, I'm hitting like A, S, D, F, right? It's actually giving me an error. It didn't seem like it was typing at first until it changed it to what's called insert mode down here. To explain what that means, and I'm going to clear out this file one more time. In order for us to actually text in this Vim editor, what we need to do is we have to hit the I key to put the editor into what they call insert mode. Once we're in insert mode, I can freely type now. I can do hello, how are you? I am Ryan. Similar to Nano, we need to use a specific command in order to save out of this. However, for Vim, it's much different. First, I need to hit the escape key. This is going to stop insert mode, so I'm going to hit escape. I'm then going to hit the shift key, the colon key, right? We see this colon, and then WQ. All right. Using what we know about Nano, what do we think the W stands for if I'm trying to save and quit out of this program? What does the W stand for? Give me a guess. All right. Well, if you guessed right, you are correct, or you are right. Right? So, WQ, right, stands for write and then quit. Now I'm going to hit enter. And this now means if I do ls, we have all three text files here. This is the one I created in Nano. This is the one created in Vim. This is the one I created with Touch. That is empty. So let's cat text file 2.txt. Hello, how are you? I'm Ryan. Once again, let's go back into Vim, right? Because it's confusing. I'm gonna write over this command. I want you all to go back into the Vim file that you just created. Try to change this. Instead of saying, hello, how are you? I'm Ryan. Let's delete all this. I'm going to hit the I key for insert mode. I'm going to delete all this and put in, this is my first file. Once again, pause the video. Try to save and quit without my assistance. I'm going to give you all a second to do so. Okay, welcome back. The way to do it, right, is with the escape key to escape insert mode, shift colon WQ. If I just put a Q, I'd quit without saving. The W stands for write or save, and then the Q stands for quit. If I just wanted to save, I could just put the W here, and that will save it for me, right? But I want to do both, WQ. And now if I cat this file, text file 2.txt, you'll see the contents are now different. All right, well, that was modifying files with text editors. The very last thing I want to show is there's actually another way to create files. There's a command called echo that we can use, and it will actually output, basically output text into a file. Right, so let's show that. I'm going to do Control L to clear my screen. You could also just type in the word clear and hit enter. This next command is called echo. And what echo does is whatever I put after echo, let's do echo, I'm going to do quotations, hello, will print out to my screen. However, if I do not redirect this output anywhere, this doesn't save, right? I'm just screaming into this empty cave, hello, right? And it's not actually going anywhere. It's not being saved or anything, right? However, what we can do is we can modify this command a little bit. So I put echo, I gave it the argument hello, which meant to scream into the void, hello. But what I could do here is I could use a greater than sign and let's put echo text.txt. Right. To explain what I'm doing, I'm using the command echo. I'm putting in the argument hello, right? So this is the actual text. And I'm redirecting this output, right? The output of this command into a file called echo text.txt, right? The best way to think of it, do you see how the alligator mouth is pointing to, right? Like it's almost like an arrow pointing at echo text.txt. It's taking the content from the command on the left and it's cramming it into the file that we just specified on the right. So if I hit enter and I do cat echo text.txt, I want you all to take a guess. What are we going to see here? All right. If you guessed hello, you are correct. Hello to you. So echo, we have two ways to use it, right? Or we have a lot of ways to use it, but two ways that I'm showing right now. The first way is to use it and just scream into a cave, right? If you echo in a forest and no one's around to hear it, did you really echo, right? So that's the first way to use it. The second way is to redirect that output, right? So this is what output means, to redirect this output and to throw it into this echo text.txt file. Now if I have ls, we now see I have 4 files. Once again, I made this file, this empty file with touch, right? The command made for making empty files. I made this with nano. I'm actually going to rename this text file. Right, feel free to pause and rename this on your own. I'm going to do nano file.txt, name text file 2. I'm going to rename this to vim file.txt so it's a bit more clear. Control L. So I have 4 files that we just created. I have the file we made with nano, the one we made with vim, the one we made with touch, and lastly, the one we made with echo. So that's how to create files, how to cram stuff in it, right? How to create files that are not just empty, right, but also have contents in it. So in the next video, I'm going to be showing you how, with this skill, we'll actually be able to write our first couple scripts, right, and be able to take it from there. So thank you all for tuning in. I will talk to you all in the next video. Hello and welcome back. So today we're going to talk you all through some basic scripting. Right? Why do we need to learn scripting? Well, there's going to be tedious tasks that you're going to want to automate. Right? And if you're a systems administrator, there's going to be tedious tasks that you'll need to automate. Right? It's just not feasible for someone to be around 24/7. In order to automate those tasks, you have to understand how to do what's called bash scripting. So for this video, we're going to show you how to do it just in the command line and one-liners, right? But for the following video, we're actually going to use some previous knowledge we now have on text editors from the video before, and we're going to write scripts using those text editors, right? So let's jump in. First up, I'm going to open up my terminal. I'm going to make it full screen, and I'm going to hit Control-Shift+++ to make the screen a little bit more readable. Okay. So this is how we're going to structure the lesson for today, or structure this portion of learning. I'm going to write a very complicated command. You all are going to guess what it does, and then we're going to reverse engineer it. So for our first script, I'm going to do for. Let's do count in 100, semicolon, do echo, $count, semicolon, done. All right. So before I run this command, right, or run this script, I want you all to guess what it's about to do. Right? So a couple of hints here, right? What do we think this does? We know what echo does, right? But it has $count. What does that mean, right? I want us to try to think about these things. So I'll give it a second. Feel free to pause the video and to write down what you think will happen. All right. Well, if you guess that it's going to print out the numbers 1 through 100 in order, you are correct, right? If we scroll up, we could see that one by one, this, what we call for loop, printed the number 1, and then the number 2, and then the number 3, and 4, and 5, and so on, right? All the way up until 100. Now, before we reverse engineer this string, I'm going to hit the up arrow key to get my command back. What do you all think would happen if I change the 100 to 300, and let's say the 1 to, let's do 97? Right, what do you all think would happen here? What's it going to print out? So take a moment to guess. All right, let's hit enter. Let's see what happens. Okay, it looks like it printed up to 300, but where did it start? Let me scroll all the way up. All right. Well, if you guessed that the starting number that it would print is 97 and the ending number is 300, then you are correct. So to reverse engineer, to break this down a bit, let's jump over to to a tool I like to use called Excalidraw. So we can see I took the command that we ran before. Let's change this just 1 to 100 so it's exactly the same. So we took that command that I used before and we broke it down into 3 separate sections. So just to give you some background, right, this type of script, it's called a for loop, right? And basically what it's going to do is we're going to specify how many times it needs to do something. It's going to do that thing that amount of times. And once it's done, it's going to exit the loop. It's going to end. Right? There's really 3 main sections for this for loop. Right? The first section, let's make this large text. How many times we are doing the command, right? So this first section, it's responsible for specifying how many times we're doing the command, right? As you all saw before, we could find that out by looking at this, right? We see our range here is 1 dot dot dot, or excuse me, just dot dot, 1 dot dot 100, which means that this is going to occur 100 times, or at least within that range of 1 to 100, counting 1 inclusively. So this is how many times we do the command. The other thing it does, right, and this is going to be the trickier part to grasp, is it's setting a variable, right? What do I mean by setting a variable? Well, this count right here, this count keyword, is actually special. What's going to happen is the first time this for loop runs, right? Keep in mind this loop is running 100 times. The first time this for loop runs, this count is going to be equal to 1. The second time this for loop runs, count is going to be equal to 2, right? And this is going to happen all the way up to 100, right? Keep this in mind because this is important for section number 2, right? Which we are about to explain now. Right, so section 1, as I just said, it's talking about how many times we are going to do the command, and it's also setting up a variable. Keep in mind here that this name here is arbitrary. I could change the name to, I could have done incrementer, counter, right? I could have done pineapple. It would have done all the same things. It actually wouldn't have changed the way this would have worked. The only thing we have to ensure is that the variable over here matches when we call it over here. Right? And that's actually going to perfectly segue us into explaining section number 2 and what that does in this command. So, section number 2 here, right? What is this doing? Well, instead of using this for keyword, right? Keep in mind we have a couple keywords that we have to start each of these with. Let me see. Can I change? We're going to put this around the keywords. Okay, so we have the for keyword and we have the do keyword, right? So this do keyword, what is it doing, right? Well, what it's doing is it's saying what command we want to run, right? And then we're running echo count. So before we said how many times we're doing something, this is us specifying what that thing is, right? So what we're doing is we're echoing, right? So this is, the do keyword starts this section, right? In this situation, we are echoing the count variable, right? So keep in mind, as I said before, count, the first time this loop runs is going to be equal to 1, the second time 2, third time 3, so on and so forth, right? And really all that's happening, if we go back to the terminal here, right, when I do, let's run the previous command. When I do a command like this, all that's really happening is it's basically the same exact thing as if I did this. Echo 1, echo 2, echo 3, right? And if I did that 100 times. Now, as you know, and you can already see the efficiency of this, right? To echo up to 100 would take me probably like 10 minutes, right? Or maybe a couple minutes. You can imagine how that might scale up, right? If I had to echo up to 1,000,000 for whatever reason, maybe my boss gave me that task, who knows, right? And that's the power of scripting here, right? But the main thing I want us to understand is that the for loop we just wrote and that we're dissecting right now is just trying to do this thing, right? This command 100 times and to completely automate the process of it run, right? Without human intervention, right? Once again, to show it doing that without any human interaction beyond me just programming this line, it is going to print from 1 to 100, right? And here we are. So let's jump back to our explanation. So second section here, this do command, right? Keyword starts the section. In the situation, we are echoing the count variable. Once again, count, that is an arbitrary name. I could have named it incrementer, could have named it pineapple pizza. I could have named it dog, cat, right? And it would do the same thing. The other thing we have to recognize is there's another, in this case, it's a key symbol here, right? So I'm going to put the diamonds around the things that are going to seem weird and counterintuitive to us. In order for us to properly call the count variable, we need to put a $sign in front of it. That is Linux's way of understanding, okay, I'm looking at a variable and not just another keyword, right? What separates this count that I made up from their sanctioned do, right, or their, I guess, specified do keyword is this $sign. It explains the difference, right, to Kali, or excuse me, not Kali, to our Linux machine in this situation. So I'm in the cybersecurity mindset with the Kali VM. So let's go back to it. All right, let me show you all something. All right, I'm going to change count to, I'm going to name it arbitrary. All I have to do is make sure that this matches the variable we set up here. I think I spelt it right. I guess I did not. Let's see, let's clear it. Let's check my spelling. RB, oh, I do arbitrary. So as you can tell, I'm in tech, not because I can spell, but because I can code. So as you see, the same exact thing just occurred, right? Just with different variable names now, right? It went from 1 to 100. It printed it out line by line, right? And was able to do that. Quick little cool tangent, right? If you want to take out the fact that it starts the new number on each line, right? You could actually do echo-n, right? This will take out new lines, right? And as you can see, it prints the numbers 1 through 100 all in one sitting here with no new lines. It's not hitting the enter key essentially, right? Explained that a little bit in a previous video, like the fact that a new line is technically a character. So this is our script. Thank you for tuning in. I will see you all in the next video. Hello and welcome back. So in the last video, we showed you a simple script that is going to go and print out the numbers 1 through 100 using this one-line command. During this video, we're going to show you some more complex tasks that we can do with this for loop. So stay tuned. Now let's use it for something that may be more interesting to us. Let's say I needed to create 10 files and I had to do it quickly. Well, first, before I do any of that, I'm actually going to create some file structure. So I'm not just filling up my root directory here. I'm going to go into my documents. So I'm going to cd or change directory to documents. I'm going to make a directory, so mkdir, and I'm going to name this loop files. I'm then going to ls to make sure that directory is here, and I see it right there. I'm going to change directories into loop files. ls, and we see an empty directory. So now, right, I want you all to try to write a loop that will make 100 files, each called file 1, or excuse me, make 10 files, called file 1, file 2, file 3, all the way up to file 10. Right? I want you to write a for loop similar to how we just did with the echo command, except for file creation, right? So make 10 empty files with the naming convention file 1, file 2, file 3, file 4, all the way up to 10. Feel free to pause the video and give that a shot. Right? Make sure you're doing this in a directory that you're okay with filling up with needless stuff. Right? Once again, you do not want to fill up your root directory. So please make a specific directory for this task. All right. Well, if you took some time to do that, welcome back. The command we're going to do is for. Let's do, I'm going to do index, right? Once again, showing that the names here are arbitrary. I'm going to make my range 1.10 because I want this to occur 10 times. I'm going to do a semicolon because as we said before, and as we showed in Excalibur, semicolons are the delimiters that separate each of these sections. I'm now going to do my do command. I'm going to type in do, and I'm going to talk about what I need to do. So when it comes to making empty files, as we've talked about previously in our Linux introduction, that is going to be the touch command, right? This is the command to make empty files. The trick to this problem, though, is how do we make these files have an incrementing name, right? And the way to do that is actually by putting the word file, $index, right? And we'll see in just a moment what's going to happen. I'm going to make a little bit smaller so we can fit the full line. I'm going to do another semicolon and done to specify that after 10 iterations, my loop will end. Okay. So let's see. Yep. Quick thing. Forgot a little keyword here, right? Just make sure you put the in command, right, or the in keyword in between index and then where you're more aptly your value, your variable, and between your range, right? And now we should be good to go. So now if I ls, right, let's see what happened. I now have from file 1 to file 10, right? And it unfortunately didn't organize it very well. It didn't organize it sequentially, right? It just went file 1, 10, 2, 3, 4, 5, 6, right? The reason for that is it's viewing the 1 in front, right, as sequential, right? It's not looking at the 10 as a whole number. It's looking at 1 as basically alphabetically, 1 technically. The best way to put it is an alphabet, right? 10 is technically before 2 is the best way to put that, right? And it puts it sequentially in that order, right? But as we see here, we have just created 10 files, all of which, if I cat them, are going to be empty, right? Which is pretty cool, right? We just automated a task that would have taken us minutes to do, right? Maybe hours, depending on what you have to put in these. And in addition to that, you can see how the scaling really occurs here, right? All I'd have to do to make this 10,000, right, is to just change it to 10,000. It's going to take a little bit longer, right? It's going to process all of this. My VM's going to hate me for a second because I just gave it a lot of work. But when we ls, you now see 10,000, right? And keep in mind, it's pretty cool actually to see the number system and how they organize this all sequentially, right? 508, 5080, or 5080, 5081, right? Pretty interesting to see how they put it in technically alphabetical order, but it's not numeric order. Right, so pretty cool. We just wrote a script that we can customize, right? And depending on the task that we're given, right, we can make fit the task. Now, I'm going to remove all of these. So I'm going to do rm star. Once again, make sure you are in the right directory when you do this. We're going to talk a little bit more about wildcards, regular expression in a later video. All you need to know for rm star is I'm saying to delete everything in this directory. When I ls, I got rid of all my hard work there. Right? RM star is just saying, hey, I want you to remove, and the star means everything. Remove everything. Let's dissect why this worked. I'm going to change this back to 10. And then we will call it a night with the video and move on to the next section. Right? So what's happening here, right? For index 1 and 10, let's take this into Excalidraw, right? Just so we can print it out. Scroll down a bit, print it. Great. What's happening, right, is on the first iteration, index is equal to 1, right? So it's actually going to be touch file 1. On the second iteration, index is equal to 2, right? So it's going to be touch file 2, right? File 2. Third iteration, 3, and you get the drill, right? The weird part here, right, is that we can take the name, right? We can take a regular name and append a variable at the end of it, and it'll basically just spit it onto the end. Right, it'll take it and just glue it, right? It'll hot glue it to the end of whatever the name of that file was, and we can see it incrementing as we hoped it would. So that is it for this section of the video. This is our first introduction to for loops, to scripting. The next video, we're going to show you all how to put it into an actual file, right? Ideally, you don't want to have to type this out every single time you want to run these commands. So we're going to make a file that every single time you run it will perform these actions for us, and will simplify our lives. So thank you for tuning in for this video, and I will see you in the next. Hello and welcome. So last video, we showed you all how to do these one-liners, right? How to do bash scripting in our terminal. Today, we're going to do something somewhat similar, but instead of using our terminal, right, and writing these one lines of code, what we're going to do is we're going to open up a text file, throw our code in that text file, turn that text file into what we call an executable, right? And then we're going to run our code from there. So to get started, right, to do a quick little recap, we have our code here. It increments between 1 to 10, and each time it increments, it creates a file with the number that we are currently indexed on at the end. Right, and just to show that, I'm not going to run it in here. I'm actually going to make a new directory. Right? Remember, as we go through this course, having a clean file hierarchy or directory system is important, just to make sure that we're keeping everything in one spot. Do mkdir for make directory. I'm going to do scripts. Make a directory called scripts. When I ls, right, note that this directory is blue, right? So we know, hey, this is a directory, not just any text file, right? We actually see that Ubuntu will color code it for us, which is pretty nice. I'm going to cd into my scripts directory, ls, and as we see, it is empty. Now let's get back that line of code we had before, right? And if you're wondering what I'm doing, I'm just hitting the up arrow key, and it's going through my history, right? Just to save me some time on the typing. So here we have for index, right? This is the variable we're setting up, just a little bit of review from last video. In the range we're going to increment, so this loop is going to happen 10 times, right? Our for loop is going to occur 10 times. Do touch, this is our command to create an empty file, and name that file in whatever the index we're currently on. Right? And as you could probably guess, when I hit enter, what's going to happen is in this directory, we're going to have file 1, file 2, file 3, all the way up to file 10 created. So let's see that happen. All right, if I type ls, we see that here. Once again, as I noted before, unfortunately, the way it organizes the files, it's a little weird, right? You would think it'd be file 1 to 10, right, with 10 being the greatest number and therefore all the way to the right here. But it actually does it alphabetically, which means that file 10 alphabetically comes before file 2. All right, so that's enough for review there. I'm going to rm start to clear our directory here. I'm going to do ls, and you see it's empty once again. Let's do something similar, right? But instead, let's use a text file, right? What are the benefits of doing this? Well, if you want to automate these processes, right, and you don't want to have to type in this every single time you want to create 10 files, right? You could just make a script, right? And you could either have an automated process that at a given point in time every day runs that script, or you yourself could run it and it saves us a lot of time. So I'm going to do Control U to clean out that line. I'm going to use one of the text editors that we learned a couple videos back. I'm going to use Nano. Right? Why am I using Nano instead of Vim? It's a little bit easier for beginners to pick up, right? But it's really just personal preference. Both of these will work for the purposes of this lesson. So I'm going to do Nano, and I'm going to name my script. Right? So Nano is our text editing command. This is the name of the text I'm creating. Okay. First and foremost, for us to create a script, right, a bash script using Nano, Vim, gedit, Emacs, right, whatever you choose as your text editor there, we need to actually be able to signal to our system, hey, this isn't just any text file, this is actually a script. And the way we do that is by using what's called an interpreter, right? And I will show you what I mean by that. I'm going to do #, exclamation point. We call this the shebang. /, and then I'm going to give the path to my bash scripting. /bin /bash. Ooh, bash g, bash. Now, I don't want you all to get too caught up in what this means, right? Just know that in order for your text file to be read as a script, you need to include this in every line, right? So we have shebang, bin bash, right? And now when we exit out of our program, right, there's going to be one other thing we'll need to do, but now our computer will know, hey, this isn't just any regular text file. Now let's put some code here. I'm going to do echo hello world. Now, if this was a normal text file, right, this wouldn't matter, right? Hello world would, if I catted this, it would just be spat out the way I put it in here. But instead, I'm going to show you all actually how to run the script and have it treated as an executable. So now that we have typed this in, we're going to do Control X and then Y and hit enter to save and to quit the program. And we now have our script called MyScript. Now, as you probably noticed, it's the same color as text files. And the reason for that is there's actually one more step we have to take before we can run this file. And we have to change the permissions of it, right? And what do I mean by that? If we type in ls space -l, right? Remember, -l stands for long listing. It's basically ls, but more details. We can actually see the executable permissions for our script right here, right? Or excuse me, just the permissions in general for our script. And as you see, we have read-write permissions, read-write, read permissions, right? And keep in mind, later on in the course, we'll break this down. It's called UGO notation. We'll break this down with even more depth. For now, all you need to know, right, is that this script currently does not have permissions to be executed. So what we need to do before we can run the script is we have to do a command called chmod. What chmod does is it will modify the permissions for our script here, right? And I could add the read permissions, the write permissions, but in this case, I'm going to be adding the executable permissions to our script. So I'm going to do chmod plus to signal that I'm adding permissions, X, and then my script. I'm going to hit tab. Oh, I got to make sure I got the caps right. Hit tab to autocomplete there. So this command right here is saying, hey, I want you to change the permissions of my script and add the executable permission at the end. Now when I hit enter and I do ls-l again, we see not only has our permissions changed, right? We have X, right, for executable now as a permission, right, where we didn't have that before. But also the color of our file name has changed, right? It's now green. Now, last step here, to run this script that we have just wrote, I could do ./my, hitting tab once again, script, and hit enter. Dot is saying, hey, run this from the current directory. / is saying, hey, treat this as, basically a script, right? And we see hello world is printed out, right? Which is what our code was meant to do. So that is segment 1 of scripting using a text editor instead of just our command line here. We're going to be jumping into some more complicated scripts in the next video. Hello. For this video, we're going to go into scripting a little bit more. Instead of just taking a static script that's non-interactive with the user, right? What we're actually going to do today is we're going to program a script that will take in what we call arguments from the user, use them in the script, right? And we'll actually change the behavior of our program, right? So let's dive right in. First up, I'm going to do Nano, right? Our text editor. You could use Vim, Emacs, gedit, whatever you like. Nano, and I'm going to do var script. So that opens up our text editor here. First step, always, is to start with our interpreter line, right? To start with the shebang /bin/bash, right? To make sure that our system knows, hey, this isn't just any text file. This is actually a script that we're going to be using. So now, and this is the part that's going to be new. We've seen variables before, right? But I'm going to show you how to assign variables in scripts like these, and then also how to assign them values based off user input. So what I'm going to do is I'm going to put the word name equals, and I'm going to do $1. All this line is saying is I'm going to create a variable called name, and I'm going to set it equal to the first argument that a user gives my script. Next up, I'm going to do, let's do age. I'll do age equals $2, right? As you probably guessed, right, this is going to take the second argument that the user gives our script, and it's going to assign that to age. Now what I'm going to do is I'm going to do echo, right? So this is our command, quotations, right? So echo quotations, and I'm going to do $1, right? So what I'm doing is I'm going to take whatever the user inputs as their name, I'm going to print it out here. I'm going to put is $2 years old. Now before we run this script, right, and we chmod plus exit and then run it, right, I want you all to guess what's going to happen, right? So take a minute to guess, right? Feel free to pause the video. So to quit out of this and to save, I'm going to do Control X. It's going to say save modified buffer, Y for yes, enter to quit out, right? And before I do anything, I'm going to add the executable, mistyped, add the executable permission to var script here. So chmod plus X on var script. Right, so we have ls here. Now let's run this program without any arguments added, right? So I'm going to do dot for this current directory, / and then my script name, var script. I'm going to run it. And as you see here, it prints out blank is blank years old, right? And the reason for that is I didn't give any arguments, right? So let's use the program the way it was intended to be used. I'm going to do my first argument, which is Ryan, and then the second argument, which is the age, and I'm going to hit enter, right? And as you can see here, what happened was my script took this, right, called it $1, assigned it to the name variable, right, and then printed out the age and appended it all here. For this, let's actually see if we could split screen this real quick, right? It's going to be a little bit more interesting to see these side to side. Let's do new window. To split screen, all I'm doing is dragging them to different parts. Let's cd to documents, cd to scripts. I'm going to do nano var script so we could see the code and then see what's actually running. Okay, clear out here, get a little bit smaller, rerun. So on the left, we have me using the script. On the right, we have the script itself. As you can see here, right, the colors have actually changed now that we've added executable permissions, right, now that the interpreter has read this line as a bash script, right? We see that in red are our inputs, right, $1, $2. In blue is the command echo, right, the echo command. And then last but not least, in yellow is the string I'm printing out, right? So the way this script works, right, is $1 is looking for the first argument that I give var script, right? In that case, that is Ryan. It's then putting Ryan here, so it's going to do Ryan is, and then it's going to take the second argument I'm giving the script, right, which in this case is age, right? So it's going to be Ryan is, and then the age, right, which I gave 1,000, and lastly years old. Now what you might be wondering, right, is why am I using $1, $2 again? Why don't I just use the variable names? If you're wondering that, awesome. I just want to show you that it is interchangeable. what we could do here, right, since I'm assigning name, right, or I'm assigning $1 to name, instead of using 1 and 2 again, right, the variable delimiters here, right, or excuse me, the argument delimiters, what I could do is I could do $name instead and $age. Right, you might be wondering, why is it beneficial to use this instead of $123 up to, like, millions and millions maybe. The reason for that is it's a little bit more clear what we're trying to do. Right, if someone else is reading your bash script, it makes more sense to see $name than it does $1. Right, they won't know what you're asking for. Right, so let's quit out of this. I'm going to save it. I'm actually going to kill this terminal. Actually, no, we'll bring it back. I think it's helpful to see the script. I'm going to rerun my script. Right, as you can see, it's functioning identical. Right, it's functioning exactly the same way. Right, so once again, let me CD here. There. Once again, once I set this, what we call variable, equal to this argument, right, the name variable and the actual argument are now interchangeable. Keep in mind, when it comes to variables, the way we specify the fact that we're using a variable instead of just name is with these $signs, right? So if I took $sign out here, I'm going to do Control X to save, Y, quit out, I'll reopen it, and rerun it. You're going to see that I'm actually going to print name literally and not the actual variable here, right? So we're going to see name is 1,000 years old. So you need the $sign in our script for it to be read correctly here. Right? So let's get that $sign there. Okay. So that is variables, right? And using variables with our bash scripts, as well as also using in arguments, right? User arguments that we provide the script. In the next video, we're going to talk about how to do for loops in this sort of structure. It's going to be a little bit different than what we've seen on the single command line, right, when we did those one-liners, but it should still be mostly similar. So I'll see you all in the next video. Hello and welcome back. For this video, we're going to show you how to do our for loop that we had showed previously, but instead of doing it in that one-liner as we had showed it before, we're going to do it in a script this time. So I'm going to do nano, and I'm going to name this one for loop script and hit enter. As always, we start off with shebang bin bash, right? By now we should probably have that memorized, right? As we write more and more scripts, a lot of these things will start to be committed to memory, which is pretty cool. To start off, it's going to look almost identical to what we did before. The only difference is instead of using semicolons to separate the different sections, if you remember, right, the for, the do, and the done section, what we're going to do is we're going to use our indents, right? We're actually going to do a new line to show that. So I'm going to do for I, or let's name it index, right? Remember, this is our variable name, in 1.100. And before I continue forward, I'm noticing that there aren't any colors with my code, right? So it's not really giving me too much feedback. I'm actually going to save out of this file, and you're going to notice something when I reopen this file. The colors are going to be added, right? The reason for that is once Ubuntu has a second to save the file, recognize that this is a bash script, right? It can actually color code this for us, right? So we have our for, right? So this is going to be, and I will comment this, this is going to be specifying how many times our or loop is running. If you're wondering what I just did here with this hashtag, this is actually what we call a comment. This is my ability to put notes in that don't affect the code itself, right? So if somebody else is reading my script, they might have a better understanding of what I'm trying to do, right? So keep in mind anything that's in this light blue here, right, and comes after a single hashtag, that's actually not going to impact our script at all, right? So that's specifying how many times we're doing the thing. I'm then going to type the do command in. I'm going to hit enter one more time, tab. Let's do echo $sign to specify that I want to use a variable, our variable name index, right? And we see in red, right? That is how variables are represented. I'm going to hit enter, and then lastly, done. Right? So do this block is signaling what we are going to do. To comment this, we are echoing the current value of index in the loop, right? And as we know, when I run this, this is going to print from 1 to 100, all of those numbers, right? It's going to print first 1, then 2, then 3, then 4. So let's see that happen. Right, I'm going to purposely make this not run right off the bat. Let's try running it right here. I'm going to get a permission denied error, right? So I'm going to give you all a second to figure out why is this permission denied? What's the one step I'm missing before I can actually run this as a script? So feel free to pause the video and try to figure that out and fix this issue. Well, if you guessed that we did not add the executable permissions, you are correct, right? We need to chmod plus x on our for loop script and hit enter. Now when I run this one more time, you will see that our script is running as usual. Let's jump back into the script and make one more change. I'm actually going to do the echo-n option, right? Options are represented in our script as purple. And what this option will do is instead of printing each number on a new line, it's going to print it all on the same line, right? And we're going to see what that looks like right here. I'm going to do Control X, Y, Enter to save and quit out. And as you can see, it is quite a mess, but from numbers 1 to 100, we have printed them all out on the same line, all the way up to 100. All right, well, thank you for tuning in. The next thing we're going to cover with scripting is exit statuses, right? So different exit status codes ranging from 0 to 255 and what they mean, and then also showing how you can program your scripts to be intelligent with those exit status codes, right? How do we make it so that if we hit an error, right, we are able to intercept that and not have it crash our whole script? So tune in for the next video. I'll see you all in a little bit. Welcome. So for this video, what we're going to talk about is input-output redirection for Linux. So first, what I'm going to do, I'm going to make a new folder with mkdir. I'm going to name this IO test. Looks like IoT test, right? Well, that works for me. All right. Next up, what I'm going to do is I'm going to show you what I mean when I talk about input and output, right? Let's say I do echo and I use the quintessential hello world, right? And I hit enter. What you all might notice is that this doesn't save this output to a file, right? All it does is it spits it out to our console and it doesn't save it, right? So when we do ls, we see that my directory is still empty. But if I hit the up arrow key a couple times to get my command back, what I could do here is I could actually use input-output redirection to save this to a file. So I'm going to use the greater than symbol, or you all may know it as the alligator symbol pointing to the left, right? And the best way to remember it is that the point of the symbol here, right, the point of the triangle, is going to be pointing at the file that information is moving towards, right? I'm going to put this into hello world.txt. What you're going to notice is when I hit enter, right, this echo hello world, right, the output of this, right, which is just hello world, will be saved to this txt file, right? So when I hit enter, you notice a couple things, right? One, it did not print this to our terminal, right? It didn't spit that out. And two, when I do ls, you notice that there's a new text file that wasn't here previously, right? And if I cat this file, you're going to see very quickly that instead of shooting this out to our command line, what has happened is this command, right, this line, has actually taken the echo hello world and moved that output into hello world.txt. Now, if we wanted to overwrite this, I'm going to pull my command back up. All I'd have to do is change this output. This is to overwrite hello world, right? Now when I hit enter, once again, it's not going to print anything out to the terminal here, but instead it's going to take the output from this command and it's going to put it into hello world.txt. Right, so when I hit enter, once again, it's not printing to the terminal, but when I cat hello world, we're going to see the contents are different. So now you might be wondering, if I just wanted to append text to a file, right, I didn't want to overwrite that text file every single time, how would I do that? Well, the way, and I'm going to get my command back, the way to do that would be by using the double caret sign, right, or the double alligator mouth, right, or greater than sign, depending on what your favorite way to represent that symbol is. Right. I'm going to change this to this text is appended to the end of the file. So what's going to happen when I click enter here, or what's going to happen once again, is instead of this overwriting the file this time, right, and replacing it with this new text, because of the fact I did the double greater than sign, it's actually going to take my text and slap it onto the end of that file, right? And I'll show you what I mean in just a second. I'm going to hit enter, and I'm going to cat hello world.txt once again, right? And you can see here are the previous contents of the file, right? They're still in the file, right? But this is the first thing I added. And appended to the end is the text that I have just appended, right? So pretty interesting. So far for input and output, we've learned two different symbols that we can use. This is to overwrite any text file, right, that already exists, or to create a new text file and fill it with the contents of whatever it is that your command is doing. And this right here is to append, right? So as not to overwrite the contents, but rather to append the new contents onto the end. Now this works for a lot of different commands, right? Let's say I do ls, right? I could actually do ls greater than sign. I'm going to name this directory contents.txt. And as you could guess, right, this output is going to be saved into this file, right? And when I cat directory contents.txt, you're going to see that the contents, right? And ironically, directory contents has been added to this, right, to our ls. But the contents of our directory here, right, is actually now in this txt file, right? So pretty cool stuff. If we wanted to append to this, right, let's say I wanted to append, right, ls. I want you to pause the video and to guess what this is going to look like when I cat this file, right, after appending ls's output once again. All right, let's check it out. So I'm going to run that command, right? Keep in mind, this isn't overwriting the contents, this is appending. So let's rerun this. And as you see, instead of overwriting the previous contents, we actually have created a little bit of redundancy and have appended the same context to the end of this text file. Right? However, this is not the only thing we can do with input-output redirection. We can also redirect error messages, right? So let's say I do something like, let's do cd fake directory. I'm going to try to switch directories to a directory that doesn't exist. Right? I can actually get an error message. Now, if I try to take this error message output and save it to a standard file, let's just name this file test.txt, you're going to see we actually get an error. And when I ls, right, and do cat test.txt, right, there's actually nothing saved to it, right? So this output actually was not saved. However, we can overwrite that by using the number 2. Right, so I'm going to pull back my previous command, the one that didn't work, right, the one that wasn't able to print, or excuse me, to put this output into a text file. And all I need to do to make this work, right, to make this become not just standard input output, but actually error output, is to add a 2 to the front here. Now when I hit enter and I do cat test.txt, you will see that the error message is now saved to this test file. Keep in mind, still the same rules apply. If I do double greater than sign, I will append to the file rather than overwrite. So let's run this again in cat test.txt. And as you can see, I have just appended the same error message twice. Right. So that is a brief introduction to input-output redirection. Right, we showed you the regular greater than symbol, the double greater than for append, and we also showed you how to not only do standard output or input-output redirection, but also how to do it for error input-output. So thank you for tuning in, and I will see you all in the next video. Hello and welcome. So for this video, we're actually going to go over the conceptual understanding of searching in Linux. Right, so I like doing these PowerPoints before denser lessons, right? I know the find and the grep command can cause a lot of people some issues, right, when it comes to learning it, right? So I just want to give us a conceptual understanding before we jump straight to the command line, right? So overview for what I'm going to talk about today, right? We're going to talk about using the find command, right? Key difference here between find and grep. The find command will search for files. The grep command will search for specific contents within those files, right? And we're going to drill that difference in as we go further through this lecture and then also through the next couple as well. We're also going to go over basic regex or regular expression, right? How do we search for things that we're not sure how those file names ends, for example, right? How do we search for things using generalities instead of a specific file name, right? Regex is going to help us with all of that. Then last but not least, we're going to use the grep command. As I said before, instead of searching for specific files, this command will be used to search for the content within files. Right? The best way to think of grep, in my opinion, is think of using Google Chrome, the Control F command, right? That is when you are searching on the page for a specific string or body of text, right? Very similar with grep. So the find command, right? The find command is going to be used to search for files, and it's going to use the following parameters, right, as its search type. Right? It's going to either look for name, permissions, size. It could look for the modification date of that file, the creation date, right, and many other parameters are possible there as well. And as we see at the bottom, the general usage for it, and we'll see this more in the command line, is the command name find, where we're looking, are we looking in our current directory, the root directory? The search parameters, right, are we looking for it via name, size, permissions? And lastly, the value, right? What is the actual name? What is the actual size we're looking for? Next up, we have wildcards, right? So these are used to specify generalities. And what do we mean by that, right? Let's say I know I'm looking for something that starts with PASS, right? Anything that starts with pass, right? It could be password, passwords, pass1, pass2, right? What I could do is I could put PASS and put a wildcard at the end, right? That wildcard, right? In this case, the asterisk, can represent anywhere from 0 to infinity characters of any type. Right? I know that 0 kind of looks like an O on the slides. Unfortunately, that is the way the Georgia font represents it, right? But keep in mind that with that little asterisk that you see on the second bullet point, that will represent 0 to infinity characters on whichever side you put that asterisk. Additionally, right, we have the question mark wildcard. Let's say I know I'm looking for pass1, pass2, pass3, pass4, right, files of those names. What I could do is I could put PASS question mark, right, and it will find all those files. The main thing to keep in mind with the question mark is it needs to be exactly one character. Right, if I do PASS question mark, right, a file named PASS, right, or just pass, would actually not pop up. And the reason for that, it needs exactly one character after PASS, right? And this will become more clear as we see it in practice, right, in the next couple videos. Last but not least, right, we can also specify characters from specific ranges, right, using these two brackets. I could either do A through Z, 0 through 9, right, or I could do A through 9, right, as well as a combination of those two. Now, the reason why this is important is, let's say instead of using the question mark and representing any character, right, I wanted to say, hey, I only want to look for files that end in a number, I could use these brackets instead. Right? Last up, grep command. Right? We talked about find, searching for specific files. Now let's talk about grep. Right? This is searching for the contents within files. Right? Once we type grep, there's going to be a pretty simple usage example here. Right? We use the command grep. We put the string we're looking for. Maybe it's like passwords, and then the text files we will search for that string in. Right? And we'll show this in practice later on. Keep in mind the reason I have files right in that parenthesis is because you could specify multiple files, you could specify a single file, or you could even specify entire directories that you want to search through as well. So that was searching in Linux in a nutshell, right? In the next couple videos, we're going to dive into the actual hands-on practical part of this section. So thank you for tuning in. I will see you all in the next video. Hello and welcome. So last time we talked about how we're going to go over the find and the grep command. For the purpose of this video, we're going to go over the find command and also use a little bit of regex. So let's jump right in. Right, when we learn a new command, one of the first things we could do is we could use the man page on it. So I'm going to type in man find, and this will give me the name, a synopsis, a brief description, and also talk me through some popular options here. Right, so pretty good page to read through when we're learning this tool. I'm going to quit out of that by clicking the Q command. And next up, what I'm going to do is I'm going to create some files that I want to find. Right, so I'm going to touch, let's do dog1.txt. Let's do dog2.txt. Let's do 2dog2, 1dog2. Right. Now, what I could do here, actually, let's just make it a general dog.txt. What I could do here with the find command, right, is I could type in find. Right, I'm going to specify the directory I want to look in. Right, for the purposes of our first find command, I'm going to use the dot here. Right, this specifies to look in just our current directory. Right, we're not starting and looking through our entire system. We're just looking in this specific documents directory. I'm going to specify how I'm looking for that thing. Right, so we have find, where we're looking, how we're looking. Right, I'm going to look for it via its name property, and then lastly the value we're looking for. Right, and I'm going to do dog.txt and hit enter. Right, and you'll see it will pop up with the results there. Now the question is, what if you wanted to find all of the dog.txt's or any txt file that has just dog in it? Well, what we could do here is we could start using regular expressions, right? So let's say if I add at the end of our command here, find dot dash name dog, this wildcard, and hit enter, right? You're going to see I actually need to put in parentheses, or excuse me, quotations for this to work. You're going to see that I'm going to get multiple results back, right? As we spoke about before, right, in our demo, right, or as we spoke about before in that PowerPoint that we talked you through. Hello and welcome back. So we're going to be using the find command and learning a little bit of regular expression in this video. Right, so as you see here, I have my documents folder, and I have a couple of files that I added, all these dog files, right, that we're going to be searching through and finding today. Right, so the first command I'm going to show you, or the first usage of find, is I'm going to find just this file, right, dog.txt. In order to do that, I'm going to use the find command, dot to represent this current directory, dash name to represent how I'm looking for that file, and then I'm going to put dog.txt, right, and I'll put this in quotations. So what we see here is we see first up is the command. Second up is where we are searching for this file, right? Keep in mind, I'm not searching through my entire system. I'm just searching this directory. So we have where we're searching, how we're searching. I'm searching via name specifically. And then last but not least, the value that we are searching for. So when I hit enter, right, you all see I return one value back. Let's get that command back and let's try using a wildcard. Let's say I wanted to see all of the files that started with dog but had some text after it. Right? What I could do here is instead of ending in .txt, I could use the wildcard at the end here. Right? And what this wildcard is going to do is it's going to say, hey, for every file that starts with dog, right, I am going to return it regardless of how it ends. Right? If we hit enter, we'll see that. Dog, dog1, dog2.txt, right? Let's just try to get every file now that has dog in it in general, right? Let's just try to get every single one. Right? I want you all to take a guess how we would do that. Where would I put the other wildcard? Thank you for tuning in. I will see you all in the next video. Hello and welcome back. In the last video, I asked you all to pause the video and to say what you think the output of this command is going to be. If you have not gotten a chance to do that, please pause the video now. It's going to be helpful for you all to learn when you make these educated guesses and you see the answers shortly after. So pause the video now and we will show the answer shortly. Well, if you guessed to the left of dog, you'd be correct, right? If I do asterisk, right, that little wildcard, dog asterisk, I'm going to say, hey, I don't care how many characters are to the left. It could be 0 to infinity, or how many characters are to the right of the dog string, right? It could also be 0 to infinity. I just want you to return everything with dog in it. We'll get all of those files. Now, keep in mind, right, we can complicate things a little bit further. I'm going to make a couple more files for this. Let's do dog12.txt. Let's do dog 1, 2, 3, 4. Ooh, touch dog 1, 2, 3, 4. Right. What I could do, right, to make things a little bit complicated, right, is I have all of these different files. I'm going to pull up my previous command. Instead of using asterisks, I could actually use question marks. What the question mark will represent is exactly one character to either the left or the right of, depending on where I put it, right of dog in this case. Right, so if I put a question mark here, I want you all to guess what is going to be returned here. I have question mark, dog, asterisk. Remember, this question mark has to represent at least and at most one character, right? It is exactly one, right? So take a guess at what will be returned. All right, let's hit enter and find out. Right, as we see here, we returned one dog2.txt, two dog2, right? But notice what hasn't been returned. We didn't return dog.txt. And the reason for that is because there is no character to the left of this. Therefore, this question mark is not actually going to be fulfilled. Right? Now, another way to use the question mark, let's say, right, we have dog 1, 2, 3, 4. What I could do here is instead of using the asterisk, I could use 4 question marks. Right? The first question mark is going to represent the 1. Second is going to represent the 2, 3, and 4, right? When I hit enter, right, you're going to notice I actually returned 2 files, which is pretty fascinating, right? This first one, right, because it starts with dog and has exactly 4 characters after it, And then also, right, we see dog.txt is returned as well, right? And the reason for that is because we have dog and then 4 characters after it as well, right? So keep in mind that question mark is also the case. Now let's say I'm going to create a couple more files. I'm going to do dog, dog.a.txt, b.txt, right? And I'm going to pull my command back up once again. What we could do now is instead of using question marks, we're going to use the third tool that we've used before, or the third tool that we went over in the PowerPoint slides, and that's going to be the brackets, right? I could actually do brackets and specify what characters I'm looking for the next, basically the next command, right? I'm going to do A through Z, right? And I'm going to do .txt, right? What this is going to do is it's going to say after dog, we want at least one character, right, to have A through Z, right? In that case, dog A and dog B would fit that bill. What wouldn't fit this bill, right, or what wouldn't match this regex would be dog 2, dog 12, dog 1, anything with a number in it after dog will not work, right? So let's hit enter. And as you see, as I had just spoken about before, right, we return dog A, dog B. I want you all to pause the video and change the A through Z into something that would get all of these text files with exactly one number after dog, right? How would we do that? All right, well, if you guessed by changing A through Z to 0 through 9, you are correct, right? We get dog 1 and dog 2.txt here, right? So that's the find command using names. However, as I said before, this isn't the only way for us to search for things. If I do ls-l, I can actually see, right, a couple of things that are interesting to me. The first is I could see the size of files, right? So I see 0 here. I can see the size of the directories, right? I know it's a directory because it's in this dark blue. I can also see permissions. Now, I'm not going to show you this video how to find files via permissions because we have a section later on in the course where we dive much deeper into permissions, file permissions, user permissions, and all that. But what I will show us is how to search for specific files based off their size. Right, so let me clear my screen and pull up my previous find command. So instead of searching for name, I'm going to do -size, right? And let me actually look at the sizes one more time to see what I want to look for. I'm going to search for only the files with a size of 0, right? So the files that have no contents in them. So I'm going to do, right, if we pull up our find command again, find dot, right, once again looking in just this directory, -size, and I'm going to do 0C, right? And if you're curious what C stands for, it stands for bytes, right? So this is the amount of bytes that would be held. If you put 0, the unit that you put after should not matter, right? We're going to see actually a lot of files pop up, right? So dog 1, dog 12, right? All of the files that are empty and not and have not been added or have not had any text added to them will all pop up, right? We also see there's some hidden files that pop up, right? And this is the power of the find command, right? So we could find files that when I ls do not pop up, right? We notice there's actually a period in front of some of these files, right? When a file starts with a period in front of it, it will actually hide it, right? It'll be a hidden file, right? And we can see that if I do ls, right? I don't see anything in here, right? If I cd into the hidden directory and do ls, I see these regular password files. But if I do ls space -a, right, for find all, you will see there's actually a subset of hidden files that start with a period that we do not see. Now, one thing you may have noticed, right, is that the find command didn't just search into the current directory we're in, it actually just started there, right? So let's cd back out. I'm going to clear and I'm going to rerun the find command again. Right, keep in mind, right, you could actually tell that these files here, right, all of the ones with the hidden directory, they're actually one directory deeper. So by specifying the period here, we're actually just saying the starting point of the find command. It will actually dive into each directory, right? It will dive into this directory, this directory, this directory, search through them and see if any of their files match our bill. Now, let's say we want to check our entire file system for something. Let's say it's we're doing this in a security context, right? And we want to look for anything with, let's say, pass in its name. right? So starts with PAS and has anywhere from 0 to infinity characters after that. What I could do is instead of starting my search in this current directory by doing this single dot, I could do a / and specify that I want to start at the very beginning of my system, right? This is called the root directory. And you're going to find a lot of stuff's about to pop up, right? So we just found every file that starts with PAS, and it's still looking. And a lot of those files we actually do not have permission to jump into, right? But if we look, right, we just found every file, passwords, password.svg, password.png, right? Every file that starts with PASS we have just found on a system. Right now, this is obviously the benefit of it from a security perspective, but if you have no idea where a file is on a system, you just know that that files exist. This could come in, it can come in handy. Let me clear out. Keep in mind when it comes to using wildcards, this isn't just something that's true of the find command, right? Wildcards actually can be used for other commands like rm, right? Like I'm going to rm anything that has dog in it. So I'm going to do star, dog, star, hit enter. And if I do ls, you will now see that all of the files that had dog in it are now gone. All right. So that was the find command. In the next video, we're going to jump into the grep command and also talk a little bit about piping, and we'll dive deeper there. But thank you for joining us, and I will see you all in the next video. Hello and welcome back. So in the last video, I gave you the task of trying to create and delete a file in our documents directory. If you've not had a chance to do that, please pause the video now and attempt that. Right, as a quick reminder, the two commands you're going to need to use are going to be touch and rm, right, to do the creation and deletion process there. So please pause the video, and once you get that done, we will segue into the next part of the video here. All right, so as I mentioned before, now we're going to go over the grep command. So we talked about find last video, now we're going to talk about grep. Right, remember the key difference between the two is while the find command will find specific files, the grep command will actually dive into those files and search for specific contents. Right, so let's see what that looks like. Right, so here is my current setup with files. If I cat my passwords.txt file, you're going to see that there are, it looks like 10,000 lines. Right? And if I just was to scroll through this manually, it might be hard to find anything of value, right? You know, I know this is a passwords.txt file, so there's probably a password in here somewhere. So I'm going to clear this out. I'm going to use grep to do the searching for me, right? I'm going to use the grep command. I'm going to use quotations, and I'm going to say what I'm searching for. I'm going to look for the word password, and then I'm going to feed in the file name that I just opened up before it hit enter. Right? And as you see, I actually just pulled out the password from that file, right? There were 10,000 lines that were just filled with nonsense, but somewhere in that file, I know this line is there. Now to double check this, what we can actually do is we can add an option to grep. I could do grep-n, and this will print out the file line number as well, right? So I see it is on line 127. So if I cat this file again, right, and I scroll up to, let's say, line 127, I'm not going to scroll wheel that. I'm going to use this. 127. Oop, I just passed it. Right, you'll see, hey, there's our password. Right. So you already can see the power of grep, right? When you just have loads of text that may not be interesting to you or just may be straight nonsense like this file, right? You can still grep for things that are important. Keep in mind, what we can also do with grep is we could use regex, right? So let's say I didn't know that it ended in password, but I did PASS asterisk, right? I will still find that file. Right? So that is an interesting piece as well. Another thing to note is I don't have to specify a specific file, right? What I could also do is specify a location. Let's say I did // an asterisk, right? This is basically saying I want you to search this current directory through all of the files for the pass string here, right? Let's see what we get. You're going to find that a couple of these will give errors, right? Because you can't search a directory, right, via this. But what we will find is that there actually is one random file here with passwords as well, right? Or, well, technically no passwords, but with that PASS string, right? And we find that as well. So keep in mind at the end here, right? We don't have to just specify a specific file. We could also specify an entire directory, right? You could also use, if we wanted to recursively search, right? So let's say we wanted to search through these directories, directory, IoT, loop files. I could use grep-r, right, which stands for recursive. Now it didn't find anything in those other directories, but you see it's no longer giving me an error. So let me actually, I'm going to add in the hidden directory. Echo password is hello. I'm going to echo this into random file.txt just to demo this. And I'm going to cd out of this directory. Do Control L to clear screen. So let's use that same grep command. I now have in a deeper directory a file with a password string in it, right? And when we hit enter, you'll actually see that with the -r or the recursive option, we are also searching in all of these directories now, right? So we're not just searching for this current directory, we're now diving into scripts and loop files and hidden and IoT test, right, in order to do that, right? So pretty interesting stuff. So that is how we use grep. Keep in mind, right, the ./, you could also just do /*, right? And as you can see, if you could guess, right, this is searching through my root directory and is finding all of the files that have PASS in them, right, and any amount of characters afterwards, right? So this will obviously take quite a while, so I'm going to Control C out of that, right? So it's important to know what we're searching for, right? Remember, if I put the dot here, I'm going to start my search in my current directory instead of starting it from root and searching through my entire system. So that is the grep command. Thank you for joining us, and I will see you all in the next video. Hello and welcome back. This is going to be the final topic in section 1 of Linux fundamentals here, right? And we're actually going to show how to use what we call a pipe, right? How do we take the output from one command and pipe it or send it over to another command, right? And before we do that, there's just one tool that I want us all to install. It is going to be called the curl command, right? So just type in sudo for super user do, apt, right? This is our installation tool, the install keyword, and then the command we want to install, curl. For you all, it's going to prompt you to put in a password, and also it's going to have a couple more lines below because it's actually going to install it, whereas for my system, I already have curl, so I don't have to go through those steps. But once you install curl, I'm going to talk you through what it does. Right? The best way to think about curl is it's an HTTP client in our command line, right? And what do I mean by that? Right, in the same way that our URL browser here is an HTTP client, and if I type in example.com, right, I get this web page, we could do something very similar in the Linux command line. Keep in mind that instead of seeing a rendered web page in front of us, what we're actually going to see is the source code, right? So everything we see here, this is what's going to be pulled when we use the curl command, right? So let me demonstrate that. When I type in curl example.com and hit enter, right, we now see, and I'll make the screen a little bit smaller, all of the source code, right? And this is going to be identical to what we see here. Why is this interesting to us? Well, a couple reasons, right? If you're writing a web scraper, right, you might want to use curl to pull all of that page source code, right, and to scrape the web that way. However, the purpose of this lesson, right, the reason we're going to use curl is I want to show you how to pipe commands, right? And I'll tell you what I mean here. So when I do a curl example.com, right, we're going to see we get a ton of text, right? This is actually a relatively small website, but you could probably guess that for bigger websites, there's going to be much more text here. What we could do, right, is we could pipe this output, right, the output meaning all of this source code, into another command, right? I'm going to use the grep command to demo this. So I'm going to do shift key, and I'm going to hit the backslash, right? So shift backslash. It's going to make this straight line, right? This is what we call a pipe. And I'm going to do grep, and I'm going to grep for the string example and hit enter. Now what's happening, right, and I know there's some extra noise up here, but I'll show you how to get rid of that in just a second. What has just happened, right, is we curled for example.com, we got all of the page source code as our output, and then from that output, we grepped for the lines that have the word example in them, right? Now keep in mind, we get this extra noise up here, and if we want to get rid of that noise, we could do curl-s. This is silent mode for curl. So I'm going to hit enter there, right? You can see I just get the lines now with the text. All right, why is this helpful? Let's say you're looking through specific articles and you want to look for specific keywords, right? You're going to want to pipe the grep command here, right? So keep in mind that grep is not only a command that works on files, it can also work on the output that comes from other commands as well here. Right, so that was a quick little introduction to the pipe command. Of course, we're going to dive deeper into this as we continue to chain commands and make more and more complex command line queries here. So thank you for tuning in, and I'll see you all in the next video. Hello. So for this video, I'm going to talk you all through different exit status codes, right? Just A couple of the main ones is mostly what we're going to focus on and talk about the real concept behind the exit status. So let me demo what I mean. If I do cat, or let's do ls, right? So I just ran a successful command. What I could do is I could do echo $? And it will give me a number back, right? This number, it's not just a random number, it's actually a status code for the previous command I just ran. So if you run something with 0 issues, you will get the 0 status code back. However, if I run something that has an issue, let's say I do cat, and let me cat a file that doesn't exist, non-existent, and then I do echo $? You're going to see I get this status code of 1, right? So where 0 represents that there are no issues, there are no errors that have popped up, 1 represents it's a general status code for errors. Right now, there are more specific errors that could pop up. Right? I believe 126 is for command not found, 127 is invalid arguments, right? There's a whole list of them. But the main thing that we should understand, right, is that the most popular difference is 0 and 1. 0 means successful, your command ran with no problems. 1 is a general catch-all for all issues. Now, why is this relevant? Well, let's look at a script I actually wrote for this. So let's look at the exit status script I wrote. Right? And I'm going to walk us all through the purpose of the script and how this status check actually can help us out. So right here, right, we have cat file2.txt. What I did here, right, was I put 2 greater than dev null, right? The reason I put this is if this runs and throws an error, I don't want that error to output to my console, right? I don't want to fill up my console with unnecessary errors. Instead, I'm going to throw it into this dev null bin, right, which is basically like my garbage can for all the errors, right? So I'm just redirecting that output, which we've covered previously in a couple videos back. What I've done here, right, and we're going to learn more about scripting later on, right, so do not get too caught up in the weeds here, right, is I've made a conditional saying if the status code equals 0, right, meaning that it's successful, print the script has ran successfully. Else, if the status code does not equal 0, right, in this case it's going to equal 1 when it doesn't print successfully, print the script has failed and exit with that failure status code. Right? So all the script is doing, and I'll comment it, right, is this is conditional saying if status code is equal to 0, then we are printing this out. Else, right, so this would be if status code is not equal to 0. If status code is not equal to 0, then we will print this out instead. Right, so let's run this script, see what we get, and then we'll adjust it a bit. Right, so if I run exit status, it's going to say the script failed. And the reason for that is, right, I'm catting a file that doesn't exist. But let's try catting a file that does exist and see if our output changes. So let me change this to, I believe I have a file called passwords.txt. Passwords.txt. I'm going to escape WQ out of this now that I've changed it. Let me just make sure, yep, so this file exists and should work. Let me run it again. Right, so we see 2 things have actually happened. Right, first, it has catted the file, right? And then secondly, the script has ran successfully, right? So we see it actually has worked. Right, and we could see, let me change it to another script that exists. Let's do echo.txt. Right, you can see this will work. As long as the file exists, right, we will hit that first conditional. So I think it's echo test is what it was called. Let's run it one more time. Oh, actually, it's echo text, right? So I want you all to guess, since the name is wrong, what are we going to get? Is the script going to succeed or fail, right? So feel free to pause the video and to guess there. Well, if you guess that it's going to fail, you are correct, right? Script has failed because this actually needs to be the right name. Keep in mind, I'm using Vim for this, right? But if you all want to type up the script as well, right, you can use Nano, right? Whichever you choose, totally fine. Vim is a little bit tougher for beginners, right? Because you, instead of doing Control X to quit out, you have to do escape :WQ as we had showed previously in other videos. So I just fixed the text here. So now this should work. Let's run it. You can see it printed the contents and has said the script is ran successfully. So that is exit status codes in a nutshell, right? The main ones being 0 for success, 1 for errors, right? Or just general errors. And once again, the main reason why you would do this is if you automate a script, right? You want to understand, did your script run successfully or did it not run, right? So you want to keep track of those different status codes. So thank you for joining us for this video. I will see you all in the next one. All right, well, thank you for joining us for section 1. Just a quick overview and quick wrap up here. We got you all set up in the Linux command line system, got you all familiar with some of the most basic commands such as cd, ls, grep, find, right? Some of the quintessential commands that you need to be proficient here. What we'll be moving on to next, right, is we'll be talking about where data is stored, right? We'll talk about different processes and how to find them in the Linux system and much more. So stay tuned for section 2, and thank you all for joining us for the first section here. Congratulations on making it to section 2. For this section, we're going to talk about where data is stored on our Linux systems. More specifically, we're going to talk about Linux commands such as ps, top, dmessage or display message, du, and df. Right? And part of that is going to be talking about processes. With the commands ps, top, and dmessage, we're going to be looking at active processes running on our system. We're going to understand how much memory they're using, how much CPU they're using, right? And also how to stop those processes if we need to. In addition, we're going to look at system messaging, right? Where does information about our system go? Where is it stored, right? For example, if I want to make a change to my vim command, right? Which configuration file do I change and where do I find that? After that, we'll talk about logging. When I log into my system, for example, where is that event stored? If somebody else logs into my system, where does the system keep track of that information? So, thank you for tuning in, and I'm excited to jump into section 2 with you all. Hello and welcome back to the first video of section 2. So a reminder, this section is going to focus on where data is stored in our system, right? Specifically data pertaining to processes, logs, right? And other pieces of information that are going to be relevant to us. So today, this is going to be the first part of our PS command series, right? And the reason the PS command is so interesting to us is it allows us to see which processes are running on our servers, which processes are taking up CPU usage, for example, right? And just get a general understanding of what's actually going on. So to start off, I'm going to type in man ps, just get a little quick synopsis of what the command does. As you see here, as the name suggests, right, ps reports a snapshot of the current processes. It's important to understand that it's only showing us the current processes. It's not showing me what ran an hour ago. It's not showing me what will run in an hour, right? It's only showing processes that are currently running on our system, or in this case, on our server. Right, and as we scroll down, as always, you can see different options that will be interesting to us, right? Specifically, the options we will use, we're going to use the -A option here, right? So we'll be using some of these as the video goes on, right? But for this first video, we're just going to use plain vanilla ps and talk about it. So let me hit Q to get out of this. I'm going to type in the ps command. So we see 4 columns when we type this command in, right? The first one is PID, right? This is actually a unique identifier associated with each command that's running, right? Or excuse me, with each process, right? So we see, for example, for the bash process, right? The PID associated with it is 1960. Now, this process can only have this PID, right? It is unique to this process specifically. There cannot be overlapped here. Next thing we notice, right, is TTY here, right? This is actually specifying the terminal type, right? And it's going to be telling us, well, which user on our machine is running this. Now, it's pointing us at user 0, which in our case is the root user, right? We'll talk about users permissions later on, right? But just know that whenever you see a 0 in the TTY column, it's saying, hey, this process was ran by the root user specifically here. Next up is time, right? You may think your intuition may lead you to think that this is specifying how long the process has been running for. No, that is not correct. It's actually talking about the amount of time that the CPU is dedicated to this process. And as you see here with bash and ps, right, the time is virtually 0, right? It's not actually 0. There's probably a decimal place somewhere, somehow, right? But effectively it is 0 here, so time we're just going to ignore for now. Last but not least is the actual process we see running. Now, since I have my terminal open, right, we see bash by default is running, right? And in addition to that, I just ran the ps command, right? So ps is a process that has been running. The interesting thing about this command, right, or this process specifically, is that it is no longer running, right? As soon as I hit enter, right, and this pops up, the process also dies. Now, I can't ps without ps showing up, right, because it will be just a self-fulfilling loop of I did another ps command and it pops up again, right? But the key here is to know that we have these 2 things running. Now, you may be wondering, it doesn't seem like a lot is going on. And if you are wondering that, you're correct, right? The reason for that is the PS command with no options is actually just showing me all of the processes running in this specific terminal. Well, that wraps us up for the introduction to the PS command. In the next video, we're going to dive deeper into some more of the options that we could add to this command to make it a little bit more useful to us. So I will see you all in the next video. Hello and welcome back. So in the last video, we showed you the PS command with no options attached to it. Right, this video, we're going to dive a little bit deeper into this command. It becomes a lot more useful to us as we learn different options to tack on at the end here. So to start us off, right, just a quick recap. Right, when I type in PS and hit enter, I'm going to see all of the different processes that are running in this specific terminal. Right, I see bash is running, and I see the PS command, because I just ran it, is also running. Right, as a quick reminder, this is going to be a snapshot of the processes running at the time of running the PS command. However, this output really isn't that useful to me yet, right? But we can make it a little bit more useful by adding what are called options, right? We've seen this with other commands, and PS is no different. So the most popular options to add basically to the end of the PS command are AUX, right? So if I do PS and I do AUX and hit enter, you're going to see we're going to get a lot more information. Right. Keep in mind, before we dive into this information, I could do PS AUX. This is going to be the BSD version. There's also the Unix version, right, which is PS AUX. For this distribution, you're going to get the same output. For different distributions of Linux that you use, you may get different outputs depending on which of the two you use, whether you use it with the TAC or not. Right, the TAC meaning this dash right here. It's also interesting to note that these three letters are actually individual options all put together, right? So we have A, -U, -X, right? If I do this, it's the same as doing -AUX. And when I hit enter, I will get that same output. Now to look at the output itself, right? We get a lot more useful information than we did before, right? Last time, instead of getting the actual name of the user, we got the number of that user's ID. That's less useful to us, right? That previous command is less useful to us because not as many people memorize the numbers associated with accounts as they do the account name, right? So here we can see the root processes involved. We still see PID for process ID, and we still see that all of these numbers are unique, right? But in addition, right, a couple new columns that we get that are very interesting to us. We get the percentage of CPU or central processing unit that is being used on this particular process. Percentage of memory, right? So this is pertaining to how much RAM you're using, right? And just a reminder, I gave my machine, I believe, 4 gigabytes of RAM, right? So this is what percentage of those 4 gigabytes is being used with this current process. We also see stat line, right? This is going to tell us, hey, is our process sleeping? Is it running? Is it a parent command? Is it a child process, right? So we see just a quick little insight on some of these letters. Uppercase S here, right? This is actually saying that this command is sleeping, right? It's in a sleeping state. Lowercase s specifies that it is a parent command, right? And if we scroll down, let's see what else we got. Do we have any R's? R's mean it is currently running, right? And as you can see, the PS AUX command, right, is currently running, and it is associated with the Ryan user, right? Because keep in mind, I'm currently signed in as Ryan when I ran that command. Right, so we see a lot of great information here, right? Why is this relevant to us? A couple reasons, right? First reason is this. If you all have ever opened up Task Manager and killed one task, let's say you deleted this task, and then a bunch of child tasks under it had died as well, right? This will help us understand that relationship, right? I know that this is a parent task because of this lowercase s. There's another command that will run in just a second that's going to make this much more clear to us, right? But for now, it's interesting to see, like, hey, there are these parent processes and all of these sub-child processes, and if I kill the parent, the child processes die as well. The other interesting thing we get from this command, right, is CPU utilization and memory utilization, right? If your machine is running slowly, if your server is not performing the way you expect, it's probable that there's a process running that's using up all your CPU or it's using up all your memory and causing one of those two things to be a bottleneck, right? Additionally, right, we have the start time. This is saying when the process had begun, right? This can be very interesting to us because let's say we have a scheduled task and we notice it's not actually occurring at the time we scheduled it, right? We might want to look into our cron tab or our code and see what's actually going on there, right? But right here we see all of these processes, right? If we scroll down, you can see there's quite a few. I'm actually going to boot up Firefox right now. I'm going to rerun my command. I'm going to see if we could find any Firefox processes. So let me clear this out. Rerun ps aux. Spoiler, you can see Firefox right here, right? But let's actually use a lesson from one of the previous videos that we've seen in how we could find these, right? Let's say this was buried right in the middle of this output, right? How would I find this? Well, the answer to this is, as we learned previously, with piping and with grep. What I could do is I could take all of this output. I'm going to use a pipe, right? So keep in mind, I'm using the same command I just did. I just added a pipe. And I'm going to grep for Firefox and hit enter. Right, and as you can see here, I now have only returned the lines, and I know it's a little bit empty, a little bit ugly, so I'll try to zoom out, make it prettier. I returned only the lines that have Firefox in them, right? So only the processes that have Firefox in them did I return. So now we see that all of these lines have Firefox, right, somewhere in the lines here. One unfortunate thing about grepping for Firefox, right, is we no longer get the column headings, right? So we no longer get to see, okay, well, this is PID, this is command, right? Because it's only pulling the lines at the bottom here, right? So just keep in mind that all the way to the right, this is going to be our command line, right? So I see these are all the commands, right? We see there's a new window command, content proc, right? Parent ID, all that. Now the interesting thing is, right, we see these processes similar to what you, if you use a Windows machine, probably do in Task Manager, we could force kill these processes, right? Let's say Firefox wasn't working, right? It was stalling out on me. What I could do is I could type in kill and then the process ID, right? I'm going to type in, we see up here 2864 and see what happens. 2864 and hit enter. Now I'm going to rerun the previous command and see what's open. Right, and we now see there's only one process that is still open pertaining to Firefox, and I can kill that as well if I wanted to. But we also notice, right, if you see on the left tab here, the actual tab we had open previously is now closed as well. Right, so we just force quit this application using the terminal, right, and just by putting this kill command as well as the 2864 PID. Now the question is, why did it kill all of the Firefox processes? Well, the reason is that the process all the way at the top here, the most recent process, is actually the parent process, right? And when you kill the parent, all of the child nodes under it die as well, right? So by killing 2864, we killed 2909, 2929, 2956, and so on, right? So we just closed the Firefox application out just by typing in kill and then that PID, right? So that's one way to close applications and to interact with our terminal, right? And use it to manage our system better, right? Especially if applications are failing, right? And if an application is getting stuck. So that wraps us up for this section of the PS command. Tune in for the next video, and we're going to dive a little bit deeper into different commands such as top and tree. Welcome. So for this video, we're going to talk about the top command. The main difference between the command we're going to learn about in this video and the command PS that we learned in previous videos is that the top command is dynamic. It will update itself, right? And it's a real-time dynamic view of processes running, right? So the PS command, as we showed previously, it's just a snapshot, right? If I type in PS, this is a static snapshot of when I typed in that command of what was going on with my system. However, if I type in TOP and hit enter, right, for the top command, you're going to notice something very soon, right? It just occurred there. There was a shuffling in the ordering list. And the reason for that is, unlike the PS command, the top command is constantly running and updating itself. Now, to change the increments in which this is updating itself, all we'd have to do is hit the S key, and you could see it's going to change the delay from updating every 3 seconds to, let's make it more frequent. Let's do 1 second and hit enter. Right, now as you notice up here with this clock up top, every second is changing, and there's a reshuffling in which processes are being shown. Right, once again, this is actually showing the system as it is, right, in real time, and because of that, we see these processes are shuffling constantly. Now, a couple things we notice, here's the overlap between PS and top, right? We see PID, this is process ID still. We see user, right? We see some RIND commands, some root commands. PR stands for priority. And then the other interesting pieces here, right, is we see %CPU and %mem once again, right? Once again, showing us how much of our system's resources are being utilized on particular paths or on particular processes. Now to change this back, because this is a little hectic with everything shuffling around, I'm going to hit S again, change my delay from 1 second, I'm going to do 20 seconds and hit enter. All right, so what else do we need to know about top? Right, a couple other things. Right, this up here, this is specifying how long my system's been running for. In this case, my system has been turned on and has been active for 2 hours and 18 minutes. This will show how many users are loaded. Right, from a security perspective, this is very relevant. Let's say you believe that you are the only user on your system, right, but top is showing multiple users. That could be problematic. And outside of that, we see general metrics such as performance, right? And we see how many tasks are currently on, how many are running, how many are sleeping, right? In addition to seeing the total amount of processes, how many are running, how many are sleeping, we can also see information on our memory usage and our swap usage, right? You can see here that in total, I have around 4,000 megabytes or 4 gigabytes worth of memory on my system here, and I'm currently using 1,500 of it while leaving 1,300 free, right? Similar with swap memory, we can see this differential. I'm not using any swap memory right now, right? And all of it is currently free, right? So you see 923 is free of that 923 total. Outside of this, another interesting thing to note is if we hit C, we will get the current processes that are running on our CPU highlighted in red here, right? And we'll have them actually show up as a different color. Additionally to that, if I type in the C command, right, look over at this command field, you will see that the full path of the command will be displayed instead of just the name of the process, right? Outside of that, I'm going to hit Q to quit out of top. What I could also do here, I'm going to clear, I could do top -U, and then I'm going to type in a user. I'm going to put in the Ryan user. And in this case, I will only see processes that are pertaining to this user, right? So I see Ryan here is the only user, and all of these different processes are currently tied to this Ryan user. I could do the same thing for root. I'm going to do top root, top-u root, and we will see that that happens once again now just with the root user. One thing to note, if you're not able to kill a command, which I'll show you how to do in a second, you may actually have to run the sudo command, right? Or once again, the super users do command before you run top. So I'm going to do that just in case before I show you all how to kill commands here. So I'm going to do sudo top and hit enter. It's going to prompt me for my password. This will just be the password to your system, the one that you sign in with. Now what I'm going to do is I'm going to demo how to kill a process using top. We showed you all how to kill a process using PS. Right, so let me start up a process. I'm going to open up the settings window here. This is going to be called gnome control C, and we actually see it at the top here. In order to kill a process using the top command, I'm just going to hit the K key. By default, it's going to ask me if I want to kill the top process or the process that is currently using the most CPU or memory. I don't want to do that. I actually want to kill the gnome control C here instead. So I'm going to take this PUID right here, 5010, and I'm going to type it in. 5010. I'm going to hit enter once. It's then going to ask me confirmation if I want to send this kill signal to the 5010 PID. And I want you all to pay attention to the bottom left corner here. Right, once I hit enter again, this application will close because the process will be stopped. So let me hit enter one more time, right? And as you see, that application has now closed. So the last thing I want to show you all is how to quit out. Right, let's just hit the Q command one more time. Right, and once again, we see our shell all the way at the bottom here, and we are now quit out. Another difference to note between PS and top, when I do PS, right, I can easily grep this output. However, since top is dynamic and is constantly updating, when I do top, and let's grep for, let's say, root, I'm going to grep for root, right, you can see that the output becomes a little weird, a little finicky, right? It's still updating and still shuffling it, but when I do Control C, right, you can see that my my shell now is in the middle of this output here, right? In order to get rid of all this, I'm just going to do clear, right? But just be aware that when you use the grep command, you're going to have adverse effects because with top, the output it's dynamically changing, and grep doesn't cater well to that. So in conclusion, right, why learn top? Top is a great command to show you what is currently going on with your system, what is using up your memory, what is using up your CPUs. It's a great command compared to PS because it is dynamically changing, right? While new processes open and close, it is updating that view based off of, once again, that increment that we set with the S key here, right? And last but not least, top is great because it will allow you to have greater control of your system, a greater understanding of what needs to be running and what you can actually subside with. So thank you for joining me this video, and the next command we're going to cover is the free command. Welcome. So in this video, we're going to go over actually 3 commands: du, df, and free. Just a short overview. Du stands for disk used, df stands for disk free, and free stands for free. And I'm going to show you the differences between the 3 of these commands. So let's start with df, or disk free. If we just hit enter, right, we're going to see a ton of information that might be a little overwhelming at first. Right? But the main thing we're interested here, right, is going to be this file system right here. Why am I most interested in /dev SDA5? The reason for that is this is my root disk. This is where everything is mounted for this particular system. And as you can see here, right, the amount of disk space that is used is about 47%. We see this is how many bytes have been used. These are how many bytes are available. We see other mounted disks here as well, right, but we're not as concerned with them. The main purpose when we use df, is to use this file system. Now, this isn't the most human readable. Luckily for us, if we do, and I'll clear out, df-h, right, it's actually going to put this into terms that we may understand a little bit better. Right, so for example, this root directory here, there is 9.8 gigabytes available on my system. 8.4 of those have already been used, and you could see that the amount of storage that I actually mounted to this root directory previously is about 20 gigabytes. Right, so of these 20 gigabytes, 8.4 is free, 8.4 is used, 9.8 is currently available, with that clocking in at a 47% usage. Now, for all of you, this may differ. I know in the setup phase, I showed you all to allocate around 20 gigs to our machines here, but depending on what you actually had allocated, this will make your answer a little different here. So this is the df command. Next up, du command. Stands for disk usage. So before we were looking at how much of our disk is free, now we're going to see how much individual files actually use our memory here. Right, and before I run this command, I'm actually going to, let me clear out and cd to my root directory. And then I'm going to run du again. So something you're going to notice is from root, there are a lot of files, all of various sizes that you'll see over here. Right, I'm just going to Control C just to quit this out. Right, and some of them are going to be permission denied, right? Because by default, Ryan does not have access, and we'll talk more about permissions later on in the course. But by default, Ryan doesn't have access to all of these particular files. The way to get around this, as we've spoken about previously, is by using sudo du. Right, so once again, whenever we get permission denied or we need root privileges in a command that we're about to run, you could use the sudo command to act as this super user. So I'm going to do sudo du. This time I'm going to add the -h command to make this human readable as well. Right, so once again, the -h option is resurfacing. We used it for df, it works for du, and we'll also use it for our last command as well here. So keep that in mind. I'm prompted with my password because I'm running this as root now. And I'll Control C because this is a lot. Right, once again, we see now that this, because we use that human readable format, is a little bit more interesting to us. Right, we see it's 665 kilobytes, got 1.8 megabytes here. Right, we can see the actual area on my root directory where this is being used. Right, remember this is the du command, or the disk usage command here. Right, so this is much more interesting to us. Right, so that's df before, du now, and last but not least, we're going to show you the free command. Right, if I just type in free and hit enter, it's going to talk about how much memory is total, right? How much I've allocated currently. Looks like 4 gigabytes. How much is used? How much is free? Shared, buff cache, and just overall available here. It also talks about swap memory, and as we saw before when I ran the top command, as well as when I ran the ps command, I'm not actually using any swap memory. So if I use free-h like we did previously, you're going to find that this view is much more friendly to us, right? Instead of seeing, 3,990,000 bytes, I'm seeing 3.8 gigabytes, which is much more intelligible, right? It's much more human readable. Of those 3.8, 1.5 are used, 592 are free, 122 shared, etc. Right? So keep in mind with the free command, right, we're no longer looking at disk usage. This is actually our memory, right? So this is how much of our RAM we are currently using. So just to draw the delineation between the two, storage is what's on your hard drive, right? So we have 20 gigabytes of storage on our machine. Whereas on the other hand, memory is actually how much RAM we have, right? So I allocated 4 gigabytes of RAM to this machine. Now, if you don't know the difference between these two things, the best way to picture it is this. RAM stands for random access memory, or it is memory for volatile tasks, right? So if you have a process that's short-lived, right, let's say it's only going to be on your system for a couple minutes, usually it goes through RAM and it comes off, right? Now storage, on the other hand, the 20 gigabytes that we see when we do du-h, df-h, right? So storage, on the other hand, these 20 gigabytes, right? Whenever you save a file or you have any sort of persistent information on your system, that goes to storage. It doesn't go to RAM. So the difference between the memory and storage here, once again, is memory is your random access memory. It's going to be the things that are temporary, that don't need to be saved on your system. These 20 gigs here, on the other hand, right, is storage, and this is permanent. So this would be, let's say, if you saved a Word file, right, you want that to stay on your system, it would be saved under this 20 gigabytes here. So thank you for tuning in and learning how to use the du, the df, and the free command. In the next video, we're going to talk about the syslog command. Hello. So for this video, we're going to talk you all through the dmessage command in Linux, right? So this is going to be one of the most common commands we use for troubleshooting, right? If you boot up your system and something goes wrong, dmessage is a great command to use. So just to start us off, we're going to do man dmessage to get some background on it. It's spelled D-M-E-S-G and hit enter. Right, as we see here, it's going to allow us to print or control the kernel ring buffer, right? And just a reminder, the kernel is going to be basically what interacts between you and the operating system. It's going to control everything that is happening on our system. It's going to control that operating system, right? So what this is going to do is it's going to display all the messages from the kernel, right? Including error messages that we may be interested in. Right, so this is the man page, and you'll see a couple of options here that we'll actually use in just a second. So I hit Q to get out of that. Right now, I'm just going to do dmessage without any flags, any options at the end. Right away, we see there is a ton of information, right? And part of what we see here, right, is on the left, this green number is actually how many seconds after boot this message was generated, right? So we can actually see everything that happened on startup, right? We see there's the attaching of the CD-ROM, right? We see this USB device has a task that it completes 2.75 seconds after, we've booted our machine up, right? And we can see all of this information here. Now, this is a bit of, overwhelming information. There's quite a few things here. So I'm going to clear this out and I'm going to do dmesg. I'm going to pipe this into the less command. Right? For those who have not seen the less command before, we'll go into it in greater depth later on. I'm just using this so it snaps me to the top and it shows me in a little bit of a simpler view everything that's going on here. Right, we could see right at the top here is the very first thing that happens post-boot. We see kernel supported CPUs, all this information, right, and some of the first couple of tasks that happen. I'm going to hit Q to clear out of this once again. One more thing that we need to be mindful of when it comes to dmesg message is we could actually clear out this log, right? We can clear it out. So I could do dmesg-c, right? It's actually going to throw me an error initially. It's going to say operation not permitted, right? And I want you all to take a guess as I'm typing in clear here. When an operation isn't permitted, what is a command I could do to override those permissions? What do you all think? Right, so feel free to pause the video, think about commands we previously used, right? And feel free to answer. So if you get sudo, right, sudo dmesg, and we're going to do -c, then you were correct. So basically what happened before was I wasn't running dmesg-c for clear with sudo permissions, right, or super user permissions. And because of that, that operation failed, right? It's not just any user that gets to clear this file out. Right, I'm going to hit enter here, put in my password. And now the next time, right, so I'm going to clear this all out. The next time I type in dmesg, right, you see it is now empty. Now you might be worried, right, like, oh no, we just cleared out this log. Where can we get this information if we need it? Well, the answer to that is I could still cat it from we have a log currently stored with all of this information in it. Right, I'm going to cat this path. It's var log, and then it's going to be kern.log. Right, if you're wondering once again how I type this so quickly, I don't. I autocomplete it with tab. Right, but keep in mind, even if you accidentally clear your DMESG log or your dmessage log, right, we can still cat it from this location here, and when we hit enter, we'll still see all that same information. Additionally, when we cat it from this location, what you all may be interested in is the way it's stored in this log is it actually has the date, right? So let's say I'm only interested in from December 21st, right? All of the events there. What I could do now is I'm going to pipe this into a grep that is looking specifically for December 21 and hit enter, right? And as you can see here, I now have only returned the rows that pertain to this date. In addition, let's say I'm looking only for the rows in this dmessage log that pertain to USB, right? I'm only interested in the USB device here. I'm going to type in grep USB and hit enter, right? And we can do that as well. So it's very rare when we use dmessage or display message that we're just going to look at the raw content here, and it is much more frequently the case that I'll use a command like this, grep USB, right, in order to filter down that content. Right, and as we move on with this course, we're going to get more and more familiar with looking at these logs and understanding exactly what they're saying, and then also being able to troubleshoot from them. But for now, the main thing I want you all to understand is there is a command called dmessage, right? It is a place for us to find these different display messages, and even if you delete that, it is still saved on your system in the form of these var logs here, right? Which we will dive into in the next couple videos. Last but not least, right, never go through the logs top to bottom, right? You do not have enough time in the day to read every single log entry, and because of that, use grep. It is your friend. It will help you out, or use the less command at the very least here. So thank you for tuning in. That is dmessage in a nutshell. In the next couple videos, we're going to dive much deeper into these actual log files, what they mean, and what we can do with them. So thank you for tuning in. Hello. So for this video, we're going to be focused a little bit more on the conceptual understanding of what we call the syslog protocol. Really, all this is the idea of sending messages to our system, storing information in different areas, and specifically for the content of this video, we're going to go over these important directories. We're going to go over the etc directory, varlog directory, boot, proc, dev, and sys directories, and talk about what each of these mean to us and what we can find there. After this video, we're going to actually dive into those right in demo time. So /etc, this quite literally is short for etc. It's a bit of a historical meaning with that naming convention. And the main thing you should know here is that this is where the configuration files in Linux are. Right, so for example, if you have SSH open, right, which is port 22 and is a service that your computer can run, or for example, HTTP open, right, the etc directory is where the configuration files for that protocol actually lie. Right, so if you have to change something with how HTTP is configured on your web server, for example, right, you'd go to the etc directory and you would change that configuration file in that location. Next up is var log, right? So this is going to be our system and how it actually logs information about events that are constantly occurring on our system. In short, it's really just record keeping to track important events. One example of a log that's saved in this var log directory is the auth.log, which you could probably understand is pretty important, right? The whole idea behind it is it will track all the authentication related events, right? Track when someone logs on, track failed logons, successful logons. You know the drill there. Right, and the reason why this is so important, the auth.log, is let's say you have a lot of failed logins, right? As a sys administrator, that's something you're probably pretty interested in and you want logged and stored for your viewing later on. Next up is /boot, right? Very simply, this is where we hold our bootloader files, and to put that into explanation, right? What is a bootloader file? Really, all it is a file responsible for allowing your machine to boot. Right? As you've probably seen when we boot up our VMs, there's a ton of lines that just shoot down talking about everything that's happening, right? Everything that's going on in terms of our system booting up, right? And it's really just reading from the files in this /boot directory to get those instructions and to understand how to execute properly, right? So these, once again, in a nutshell, are the files responsible for allowing our machine to even start up. Next up is /proc or process. This contains useful information about processes that are currently running on our system. right? Keep in mind this is going to be a snapshot, and this snapshot is created once our system is booted up, right? So if we ls the proc directory, right, we'll be able to see a whole list of different processes and get some information on them, similar to what we've done before with the ps and top command. /dev, right, contains files that represents devices attached to our systems. There are really two types of devices that this could entail. One called block devices. These are going to be standard, hard drives that you would think of, right? And character drives. The key denoting factor between the two, right, is block drives are denoted with the B, and character drives are denoted with the C as their first character, right? So relatively easy to tell the difference between the two just because of that naming convention. Last but not least, and it's very common to confuse this with dev from the previous slide, this is going to allow us to obtain information about the system, its hardware, and its components. This will track things like vendor name, model, etc. And the best metaphor for delineating between /sys and /dev is that /sys will provide access, right, to the packaging, right, basically access to the packaging itself of a system or hardware, whereas /dev is providing access to the contents, right? So /dev is actually going to be accessing our hardware and its contents. /sys, on the other hand, is just going to be managing it, right? It's going to be basically managing it from a little bit more of a higher level perspective here. Right, so dev dives a little bit deeper into the weeds. /sys, on the other hand, is just dealing with the outer layer of our hard drive here, or our hardware, excuse me. So thank you for joining me for this lecture. Right, now we're going to jump into, in the next video, the actual files that exist in these directories. We'll talk a little bit more about what those files represent, and we'll show you the lay of the land when it comes to these actual directories. So thank you for joining us, and I will see you in the next video. In this video, we're going to show the contents of the directories that we had spoken about in the previous video. Right, so to start us off, we're going to cd into the var log directory, and we're going to ls. Right, you're immediately going to see some files that we're going to be familiar with. Right, for example, the dmesg file here, kern.log file as well. Right, as we said before with the dmesg command, if you clear it out, all of that output is still saved right in this directory right here. In addition to that, we also see syslog file, right, and then also this auth.log file. So let's cat the auth.log file here. So right off the bat, what we're going to notice, right, with auth.log is we have all of these different successful sessions that are both opened and closed for root, right? This is probably coming from when I run my sudo command, right? And we can even see when Ryan is logging in and executing commands as well. Right, so auth.log, as we had spoken about previously, is tracking all of the major events when it comes to the actual authentication process of different users. If we ls again, right, and we look around, we also see this syslog file as well. Right, so I'm going to cat the syslog. When it comes to syslog, this is just keeping track of all of the events that are interesting to us. Right, syslog is a general protocol that is supposed to track important events that happen on the system. Right, for example, this window manager warning, right, we are overwriting existing key bindings, right, that is something that we keep in syslog here. Finding usable connections, something we track as well, and as you can see, all of this is separated and delineated by the date and the time in which it occurred, right? Fingerprints, we look through, what else is interesting to us? We see found usable connection pops up frequently online. Right, so syslog is basically tracking things that happen in our system, putting it into this log in case we need to review it later on. Another directory we talked about was the etc directory. So I'm going to cd to that. I'm going to ls. Right, and as you can see, a lot of these files are going to end in .conf. That stands for configuration. So let's cd in the vim directory here. Cd into vim. I'm going to ls, and I'm going to do cat vimrc. Right, and we're going to see a file that actually has to do with the configuration of Vim. Right, if I wanted to change something about the way Vim is colored, or the way the lines are numbered, or a different setting within Vim, I could change it in this configuration file. I could add some code to this file, and that change will persist. Right, so we can see just a little bit of description here. If you wish to change any of these settings, you should do it in this file right here. Right, so the key thing with etc is to know that this has to do with the configurations of a lot of the different tools that we've been using. In addition, right, let's cd into let's go into the proc directory, and I'm going to cd into a random proc directory we have here. And as you can see, all of these different processes that we have, right? This directory is, remember, created on startup. All of these different processes we have actually have directories associated with them. And within those directories are tons of files, right? Now let's catch session ID and see what we have. Right, and you can see that these files are mostly represented, relatively short values. For example, session ID, we see when we print it, it just has the session ID of this particular process. Right, so this is our proc directory. I'm going to cd all the way back and clear my screen. So those were the main directories I just wanted to show you all via the terminal. I know we spoke about a lot of those other directories before, and that was a good enough understanding, but I think there is value still in seeing these directories in the terminal, understanding where to go to access them and what those changes would entail, for example, with vimrc. So thank you for joining me for this video. In the next video, we're going to wrap up this section, and then we're going to jump right into section 3. Thank you. Welcome to the final video of section 2. In this section, we talked about the Linux commands ps, top, dmessage, du, and df, right? And by the end of this section, you should have a better understanding of how to use these commands to debug your system if, for example, you have too much memory being utilized, right? Or too much of your CPU is being utilized and there's a bottleneck in performance. So we talked about those processes, how to shut them down with those different commands, as well as different hints on how to make it a little bit more human readable for us to understand. We also talked about system messaging, right, showing that vimrc file, and talked about, lastly, logging as well, right, when we looked at the auth.log, the kern.log, right? So we should have a better grasp now of not only how the system functions, right, from those previous commands, but also where the system stores information that is pertinent to us. So thank you for joining me in this section. I'm excited to see you all in section 3. Welcome to section 3. In this segment, we're going to be talking about basic networking in Linux. Right, so more specifically, we're going to be going over these commands: route, ifconfig, IP, netstat, ping, host, and ss. And if that seems like a lot of commands, do not worry. We'll be going through them step by step. And also know that a lot of these different commands will have overlapping functionality, right? So it shouldn't be all that intimidating. But we're going to take these commands and we're going to add them to our Linux repertoire so we're even more powerful and have an even deeper understanding of how to interact with our Linux environments. After that, we're going to talk about some network configuration. Right? We're going to talk about basic network configurations and how we could use the Linux tools that we had learned previously to interact and to change those configurations. Right? Last but not least, we'll talk about DNS, domain name system. We're going to give you all an understanding of what DNS is doing, what its practicality is, and why you should understand it. So, thank you for joining me in the section intro. I will see you all in the next video. In this video, we're going to be talking about IP addresses. Right, so we got two main types we're going to talk about: IPv4 and IPv6 addresses. But first, what is an IP address, right? What even is that? Right, an IP address is a unique address that will identify a device on either the internet or a network, right? Maybe your local network, for example. Right, the best way to think of it is when we go to google.com, right? Our machines don't understand google.com when we put that in the URL. They understand numbers. Right, and basically Google has a bunch of servers, and each of those servers has a unique IP address, right, or a unique identifier. So the best way to think of this is it's similar to a phone number, right? When I call Ryan on my phone, right, if I was calling myself, right, my phone doesn't understand the name Ryan. It doesn't mean anything to it, but it does understand the number 123-222-2222. Obviously, that's a fake phone number. Don't try to call me, right? That's not my real one. But here we can see that we have a name and it has a phone number that will allow us to actually interact with it. And computers are the same way, right? The way computers interact with one another is using those IP addresses, right? And we saw it previously when we learned the ping command as well. In the same way as we were just talking about, google.com actually has an IP address for its servers. Now, once again, this is a pseudo IP. This is not Google's real IP for their servers, right? So just keep in mind that it's very similar to a phone number. So purpose of the IP address here is to be a unique identifier for specific machines. And we'll actually learn later on with DNS that the DNS or domain name system is going to be like our phone book, right? It's going to be what actually translates google.com into the IP address itself when we search for that in our URL. Now, to talk about specific IP address types, right, we have IPv4 addresses. These are the most common that you've probably seen just whether it's randomly or on purpose, right? You've seen some form of IP sometime in your life, right? These are represented in the common 1.2.3.4 format. In each octet or section, right? And what I mean by section is each little piece that is separated by a period can represent any number from 0 to 255, right? So instead of 1.2.3.4, we could have 0.0.0.0. We could have 255.255.255.255, and anything in between those two ranges, right? This leads us to be able to have 4.2, or more likely 4.3 billion different IP addresses or unique identifiers for devices. Now keep in mind, if you have a device that is connecting to the internet, it needs to have one of these IP addresses so that we can identify it and communicate with it. Now 4.3 billion sounds like a lot, right? But as we have connected our phones to the internet, and our Kindles, and our refrigerators, right? And our smart light bulbs, and our smart homes, and our Alexa Amazons, right? Or Amazon Alexas, this number actually has begun to run out, right? So IPv4, it sounds like a lot, 4.3 billion IPs, but we actually have realized it's not enough. Hence, we have created its successor, right? IPv6 addresses. Now, the cool thing about IPv6, right, or also the cool and confusing thing, is it's represented as 8 groups of 4 hexadecimal characters. So it's going to look completely different to what we're used to with IPv4 addresses, right? Each group is represented by 16 bits, right? The groups are separated by colons, and an example is below, right? We see there's actually example by that arrow key, IPv6 address, right? Keep in mind, it is ugly, right? To memorize this on your own would be a nightmare, so don't, right? That is what we actually use the DNS servers for, which we will talk about later on. The cool thing and the real benefit to IPv6 addresses is that there are 340 trillion combinations, right? Juxtapose that to 4.3 billion, right? And you can already see the value here. As our need for unique identifiers has expanded, we need a unique identifier that expands as well. And that is what IPv6 has been meant to do. So that is a glimpse into IP addresses. Thank you for joining me in this video, and I will see you all in the next video. Welcome to the video. This is going to be mostly focused on conceptual understanding, right? And this is something we're going to break down further on as we learn Linux commands and go even deeper into this subject. So the agenda for today is to talk about the internet, just generally. How does it work in a nutshell? Routers and DNS. So to start off the internet, right? It all starts with this interaction, a client and what we call a server, right? So in this case, think of the client as yourself, right? The client is either your laptop or your PC, whatever it is you're using, right? We are the client. What happens is when you type in, let's say www.facebook.com, we are making a request to Facebook servers, right? For each request that is input, we get a response, right? So as a client, we make a request that gets sent over to Facebook, and then Facebook sends that response back to us. Now the question is, how does Facebook know that we're querying it, right? How does Facebook understand that we are calling for it when we type in facebook.com into our URL? And the reality is that Facebook servers doesn't understand words, right? It's not understanding that when you type facebook.com into the URL that you're searching for it and calling out for it. Instead, it understands what we have here, this IP address, right? So you can see here facebook.com, although that's what we're putting into the URL, what's actually sent to the servers to query them, right, is that IP address. Now, once again, this is not the IP address of Facebook, right? This is not their actual IP, right? This is just a placeholder. But I want you all to understand that when we make our request, it's actually sent via IP, right? And when Facebook server sends the response back to us, they use our IP. And as a placeholder to represent our client's IP here, I put 30.89.20.30, right? But keep in mind, these are just fake IPs that we're using for the example, right? So once again, we have a request that is sent out, and each request is met with a response, right? The question is, though, right, we have facebook.com, and then we have an IP associated with it. How does that translation work, right? When I type in facebook.com into the URL bar, how does it know to translate that into this IP address? The answer is with DNS, with domain name systems, right? This is going to act as a phone book for IP addresses, right? We've used the analogy before where an IP address is similar to a phone number, right? You have the name, right, the domain name, which may be facebook.com or google.com, and then you have the phone number, which would be the IP address, right? And the key benefit to this is it's going to allow us to not have to remember every single website's IP, right? Imagine if every single time you went to a website, you had to remember, oh, for Google, is it 10.11.31.24 or .25, right? It'd be horrific. So what DNS does is it resolves that for us, right? It's basically going to act as our phone book, which is incredible, right? It saves us a lot of hassle. Think about the time before we had phone books when you were trying to call somebody, or the time before we had a contact list, right? Imagine having to remember more than just your immediate family's phone numbers, right? It's quite a burden after like 3 numbers, really. The last thing to mention with DNS is it usually exists on port 53. We're not going to play around with that too much yet, right? But just a good thing to note. Last for this section, right? Last thing I want to talk about is routers, right? Just routers in a nutshell. They typically connect 2 or more networks, right? So I have my client here, right? And as we showed before, Facebook has their server somewhere else. Those are actually 2 different networks, and using a router, we can connect those 2, right? And connect them over the internet. Routers will act as our air traffic controller. They're going to take traffic and figure out where to direct it, right? And we're actually going to see when we jump into the Linux commands later on, specifically the route command, how that works, right? And as I just hinted at, routing tables are the guide to direct packets effectively. And I'm going to teach you all later on in about a couple videos here how to change those routing tables manually in Linux. So thank you for watching. I'm excited to see you all in the next video. Hello and welcome to the video. In this segment, we're going to talk about the route command in Linux. Right, so as we spoke about before, in computer networking, a router is the device responsible for routing all your traffic. Right, and the way that your device knows where to put the traffic is through what we call a routing table. Now, with this route command that we're about to use, we will be able to make changes to that table. We're going to be able to add static rules, right? And depending on what we need our network to do, we're going to be able to dynamically change it so that our router understands where to put the traffic. Right, so let's start off with running the route command. So I'm going to click into my terminal and type in route. Now, when you all attempt to do this, you're going to hit an error. It's going to ask you to download it, right? But for me, since I already have the tool downloaded, it runs successfully. So for those of us who do not have it downloaded, which is going to be the majority of us, what I need you all to do is type in sudo, and that's going to be sudo apt install, and then the package is going to be called net-tools, right? So as we talked about before, because this isn't the first tool we've installed, right? Sudo, this is what we use whenever we need to use super user privileges, right? It stands for super user do. Since we're installing a package, this tends to be an action that requires higher privileges. apt, this is our package installer command, right? This is a keyword for that package installer command. It's install, and then last but not least, the package we actually need to install. When I hit enter, for me, it's going to say it tries to upgrade. For you all, it's going to be a lot more lines because it's actually going to download that package for you. But after a couple seconds, what you should be able to do is what I did previously, right? Type in route, hit enter, and see our current kernel IP routing table. Now we have a couple of columns here, right? First, we see the destination, right? This is where the traffic is going. We see the gateway we're using, right? We see flags, metrics, references, uses, interfaces, right? And as you can see here, this interface is going to be one that will pop up later on in this particular section quite a bit, right? So we will talk about that in a little bit, right? But right off the bat, we're basically seeing how the system is currently configured. We can make changes to it, right? We can make those dynamic changes, right? Or make those manual changes. But for now, this is the current default. Now, one thing to note is if we type in route and hit enter, the destination says default here, right? And this isn't very clear to us, right? This isn't a specific IP address. We may not know what this represents. So what we could do here is we could do route-n, right? This stands for numeric. And as you can see, default and link local have now been changed to their actual IP addresses, right? The actual representation here. One thing you may be wondering, right, is with this IP address here, 0.0.0.0, what does that mean? This actually represents the entire range of possible IPv4 addresses, right? So this is effectively saying that an IP address can have any destination and it will be forwarded to this IP address, our gateway, right? So the idea here, right, is if a packet comes through our system and it falls within this destination range, which it does by default because this is the entire range of possible IPs, we will then forward it to our gateway, right? And that's how we figure out how to route that traffic. Now you may be wondering, what do the other columns mean, right? And the two other big ones, right, is first going to be flags, right? For flags here, U just stands for that this rule is up and running, right? This routing table rule is up. And then G stands for gateway, right? So this is currently a gateway rule. The other important thing to note is what interface this relies on, right? And we're going to learn about interfaces a little bit more in the next couple videos when we use netstat and when we use IPA, right? But currently, we see that this interface is ENS33. Right? Outside of that, you might be wondering, GenMask, what does that stand for? GenMask just stands for generalities, right? It's saying, hey, for the destination IP, right, which of these numbers are general, right? Which are static, which are dynamic. If you have 255, that means that this is a static number, right? So every single IP address in this range is going to start with 169.254. And if you see a 0 here, right, it's going to be dynamic, right? So it means that these numbers can change. And as we see with this last rule here, right, we see these three are static because we have 3 255s. And this last bit, this last octet, right, is dynamic. So that's how we understand the route table. Once again, this is currently how our system understands to accept traffic and then to route it. But we can actually change this. So now that we understand the routing table, let's talk about how we can change some of these rules, right? So currently I actually have another machine that is connected to this one that I can speak with. I'll ping it real quick just to show you all. 192.168.80.134 and hit enter. Right, there's actually another machine running on my computer that is connected to this VM, right? And we can see that I am able to communicate with it. What I could do, right, if I wanted to customly change my routing table to disallow this communication, I could do sudo route add, right? So this is the keyword after our command, dash host, right? So this is going to be the IP address. So I'm going to put 192.168.80.134. And then last but not least, I'm going to put what I want to do to this host, right? I want to reject it. So effectively what I'm doing is I'm telling my routing table, right, if you see that the destination IP is this specific host, reject that traffic. I don't want you to route it, right? So if I hit enter, we see it run successfully. If I type in route, we actually see this new rule at the bottom, right? And notice this, right? This is the destination IP that I just specified. The gateway is blank, which means that there's no possible way for it to route, right? And since it's an exact IP, right, we see 255 is covering every octet, which means all of these bits are static. All these octets are static and will not rotate, right? It's a specific IP, right? Now what I'm going to do, let's try to ping the machine again, see if it can still work. So I'm going to ping 192.168.80.134 and hit enter, right? And assuming you have done this correct, you will see no route to host, right? That means that it doesn't mean that it's not online, right? The machine is still up, the machine I was just pinging before, but I've just written a rule that has disallowed me from connecting to it, right? I no longer can route to that specific host. Now you may be wondering, how do I reverse that? Well, if we hit the up arrow key 3 times, right, all we have to do to re-enable us to be able to ping that IP address that we just disallowed is change add over here to delete, right? So instead of sudo route add dash host, I'm going to do sudo route delete. And now you may get confused because we leave the reject at the end, but all this is doing is deleting the reject rule that I had just written. So when I hit enter and I type route again to see the outcome, you now see that this rule has been deleted, right? It's no longer the case. So if I ping that machine one more time, 168.80.134, you should see that those pings now work once again. Right, so this is the power of routing tables, right? Is we're able to either create connections, right, or destroy connections and tell our router where to put specific traffic, right, or to drop it altogether. Another thing to note, right, is we are also able to get the details of our local table and figure out which destination IP addresses are assigned to our local host, right? To do that, we're going to type in IP, right? So this is going to be a different command, right? This is the IP command, which we will dive into deeper in later videos. IP route show, and then just table local, right? So IP command route show table local. When we hit enter, right, you're going to see all of the different destination IPs that our local host currently has assigned to it. if you're only related in the traffic that is pertaining to IPv4, what you could do here is type in IP-4 route and hit enter. Right? And in the same way, as you could probably guess, if you're only interested in the IPv6 IP addresses, right, in the output for IPv6, you could change that 4 to 6, hit enter, right, and we could see this IPv6 address here, or at least part of it. So thank you for joining me in this video. In the next video, we're going to be talking about the ifconfig command as well as the IP command, which we have hinted at a little bit at the end here. So thank you. I will see you all in the next video. Welcome. For this video, we're going to talk you all through the differences between the ifconfig command as well as the IP command. We're going to talk about their uses, right, and show some practical examples. So to start us off, right, as always, open up your terminal. Right, I do that by hitting this terminal icon in my favorites bar. Right, you may have to go to show applications and type in terminal and hit enter. Right, I'm going to do Control-Shift++ to make this a little bit bigger. Right, now that we got our terminal environment set up, right, the first thing we're going to do is we're going to type in if and then config. Right, this stands for interface configuration, and this is the first command we're going to work with today. I'm going to hit enter. Right, and we're going to see two network interfaces that are right now connected to our machine. Right, and what do I mean when I say our machine? Do I mean your Windows or your Mac machine? No, I mean our Ubuntu machine. Right, remember our virtual machine is basically a separate computer, right, and will be treated as such. Right, so these two network cards, right, the ENS33 and the LO, actually are for that machine, our Ubuntu machine. So to talk about these names right off the bat, right, ENS33 is actually a new name for network interface cards. This is traditionally ETH0, ETH0, right? And what ETH0 stands for, right, is it stands for a wired connection. Now you may be confused, right? Because why is this a wired connection? My computer's using wireless, right? I'm using Wi-Fi right now. The reason why this is considered a wired connection is because our virtual machine is basically wired to our main machine, and that's how we get internet. Right, so keep in mind, whereas if you did this on your host machine, right, let's say your Mac machine or your Windows machine, instead of ENS33, you might see a WLAN 0 interface name. For our VM, it's going to be wired, right, and that's why we see this. Right, so remember, for wired devices, it is going to be either ENS33 or ETH0, right, is going to be the interface names. For a wireless device or a wireless network interface, you're going to see WLAN 0. Right, or 1 or 2, depending on how many of these you have. So let me pull our screen back up. A couple of pieces of information we're going to see here are very familiar from what we spoke about before. Right, the main things that you should get out of this is we see this IPv4 address. Right, this is the local address of my machine. Right, I could tell since it is prefaced with 192.168. I see the IP address for the network mask and the broadcast address as well. Right, and notice that these end in 0 and 255, right? So these aren't the IP address of my machine itself, right? But rather those two devices. The other thing to notice too is we also have INET6, and this is actually an IPv6 address for my machine, right? And as you can see, as IPv6 addresses are, right, are usually encoded in, right? This is hexadecimal here. Besides that, the only other thing I want us to note, right, with these two interfaces is when I type in the ifconfig command, this is showing me all of the interfaces that are currently running, right? So let's say I unplugged my wired connection, right? Let's say picture you have an Ethernet cord in your computer and you unplug it. If you were to rerun your ifconfig command, right, you're going to notice that that connection is actually not going to show up, right? It's now just going to be LO as your only network interface, and we will demo that in just a second here. Before we demo that though, right, I want to talk about this LO. Right, so this LO stands for our loopback address, right? And the way the loopback address works, right, this is what the system is going to use to refer to itself. Right, for example, we showed you all previously how to ping machines, right? How do we ping ourselves? Well, I could do ping, and I could do 127.0.0.1 and hit enter. And I'm actually pinging my own machine, right? So this IP address that I found from, let's go back to ifconfig, that I found from here, right, for my loopback interface, right, this is going to be my self-referencing IP address, right? Whenever you see 127.0.0.1, right, just think of it as referring to myself, right? So if I do ping this IP address, right, that's going to be pinging myself. If I do nmap or host or whatever other command on this IP address, right, that is going to be all of it's going to be ran on my machine essentially. So that is our loopback address. But I mentioned previously, right, ifconfig is only showing the current interfaces that are up and running, right? What happens if an interface is not up and running? Well, let's turn one of these interfaces off. I'm going to clear my screen. I'm going to keep this name in mind, right? And this is actually the interface I'm going to turn off. Before I turn it off, one quick thing to note, right, is this interface is actually what is allowing my virtual machine to be able to access the internet, right? It is this interface that connects me to the internet. So if I turn that off, you're actually going to see in this demo real quick that my interface connectivity is off as well. Just to show you all, I'm still connected to the internet right now. If I go to Wikipedia, it works, but this will change in just a moment here. So I cleared out my screen, and what I'm going to run now is I'm going to do ifconfig ens33, and then I'm going to type in the word down. Right, so this is the command from before. This is the network interface I want to interact with. This is what I want to happen. I want to take it down. Now I'm going to hit enter, and I'm going to get an error. It's going to say operation not permitted. As you all know, when something is not permitted, it usually just means you need to use sudo privileges. Instead of retyping that entire command, I'm just going to do sudo space double exclamation point. This is a shortcut that will allow me to rerun my previous command with sudo. Right? When I hit enter, you're going to see it just reran that same command. It just appended sudo to the front of it. It's a really cool way to save some time here. Next up, I'm going to put in my password. You all will do the same. And the interesting thing is, once this command runs successfully, it doesn't give us any feedback. But if we go back to the internet, if I rerun Wikipedia here, let me make sure it's not cached. Let's go to eBay maybe instead. We're going to see we're having trouble finding the site now. And no matter how many times I try, I'm no longer connected to the internet, right? So pretty fascinating, right? I just took down my network interface. In addition to that, as I said previously, if I rerun my ifconfig command and hit enter, I no longer see that interface is existing, right? I just see this loopback address, right? And this will always be up, right? Or always be up unless you purposely take it down, right? Now this could be a problem, right? If I log onto a machine and I'm unfamiliar with it, sometimes I want to see all of the addresses that are out there. I want to see all of the different network interfaces that actually exist on this machine, both up and down, right? So enter a new command, right? This command is going to be called IP. So if I just hit IP, it's going to give me a ton of options to use. The main option I'm going to use for today is IPA. Right, so if I do IP space A, or you could even do -A, well, I guess just IP space A and hit enter. You're going to see, I see my loopback address here, right, 127.0.0.1, but I also see the interface for ENS33, even though its state is currently down. Right, so as I mentioned before, the main difference between these two commands is the fact that ifconfig only shows the interfaces that are currently up, whereas IPA or IP space A will show all of the interfaces regardless of their status. If you want to see this in a different format, right, another common way to use this command is do IP show and then adder, or excuse me, IP adder show. I always mix them up, IP adder show. Hit enter, right? And you'll see that it is the same information. So now that we see that these two commands, right, generate the same information, right? We see IP adder show generates the same thing as IPA, right? I want to reiterate the point that the reason we use this IP command in the first place is to show interfaces we may not be aware of because they're down. Let's turn that interface back on. Right, so we have ifconfig. We see now we just have the loopback address. Let's turn back on the ENS33 network interface here. So take a second, pause the video, try to do that on your own. It's going to be very similar to the command we used to take down that interface, right? But I want you to attempt to put it back up, and then once it is done, to confirm that you got the right answer, try to connect back to the internet, right, and see if you're able to do it. Right? So I'll give you all a second to do this. Well, hopefully you all got it. Right? The way to do it is by doing sudo, right, as always, because we need to do super user do, right? This is a special privilege command that we're running right now. sudo ifconfig, right, the command we were working with previously, ens33, right, the name of our network interface, and then instead of putting the word down, we're going to put up and hit enter. As we said before, right, the difference isn't, it's not going to give you any sort of feedback on what happened, right? The only feedback we have, right, is when we do down and when we do up. The only feedback we will have will be when we go to Firefox, right, and check our work. Right, so as you see here, I just refreshed the page and I was able to reach ebay.com, right? That means it's up, right? That means that we have put this back up, right? To confirm this, if I type in ifconfig and hit enter, right, I now will see that network interface again. All right, last but not least, I just want to show a couple of shortcuts for the IP command, right? Once again, IP is a replacement for ifconfig. Ifconfig is a pretty old command. IP is showing all interfaces, whether or not enabled or disabled, right? So it's a pretty good one to get used to. Let's say you do not like this format. You think it's ugly and all you need to do is find the IP addresses of different network interfaces. What you could use is you could do IP and then do space -br space A and hit enter. And you will see the name of the interface, their status, right? We see loopback is unknown, ENS33 is up. And then last but not least, their IP address, right? So we see 127.0.0.1 for our loopback address, 192.168.80.137 for our ENS33 interface, right? And we also see the IPv6 here. So that is the ifconfig command as well as the IP command. Thank you for tuning in, and I will see you all in the next video. Welcome to the video. We're going to be going through the netstat command for this one. This command is very complex, very lucrative. It's pretty simple to use, but the nice thing about it is you're going to start to question why we learned some other commands, right? We're actually going to be able to do what we did last video with the route command. We're going to be able to do that with netstat as long as we know the proper options. Additionally, in the next video, when we go over ifconfig and IP, right, we're going to find that the netstat command can also do that too. So it's going to be very cool to see that a lot of what we want to do can be done with this one command if we know how to use it properly. So just to start off, right, the purpose of the netstat command, it's going to allow us to see which services are running on our machine. Right? It's going to allow us to see which ports are open, right, which services are running, connections established. Right? For example, I have Firefox open right here. Right? This is going to be a current connection between my computer and somebody else's. Right? So this would appear in netstat when I query that. All right, but as always, let's start off with netstat, right? The command itself, --help. And I spelled netstat wrong, so let me just put that T here. Right off the bat, right, we're going to see some interesting options, some that we will use right away, right? -R for route, right? This is the option that's actually going to completely simplify what we did last video, right? And basically do it with a different command. Right, and we see some other options that we can play around with after this video. We're going to be using quite a few of these, right? And we'll get a pretty good understanding of the tool. But keep in mind the --help option is always there for us if we need it. So first up, we're going to do netstat -R. Right? As we saw in the help window, right? This is for a route. As you see, this is the exact same table that we saw last video when we typed in the route command, right? And it makes you wonder, right? Why do we even use the route command? We see some of the flags, right? The columns here are a little different, right? But for the most part, the key ingredients, the main information is intact. It's all the same here, right? So with the -R option with netstat, right? We're actually able to look at our routing information like we had done last video with a different command. Next up, right? And this is what we're actually going to learn about for the next video. I'm going to clear this out. It's clear. I'm going to do netstat. I'm going to do -IE, right? And hit enter. Ooh, excuse me. Typed it wrong. Netstat. Always forget the T. So this information here, we haven't seen this yet, right? We're going to actually see this a lot next video. This is information about our network interfaces, their IP addresses, right, and their statuses. Right? For example, here we see two network interfaces. We see their IPv4 address, right? And we can also see statuses here as well, right? This is going to mimic the command we will learn next video, right? So if you don't understand this command yet, that is totally fine. We will do a deep dive into it in the next video, right? But this output is going to be very similar to the ifconfig output we see, right? So once again, another example of netstat taking every other command's job here, which is pretty cool. So we got two of our common uses of it out of the way, right? One is for routing, the other is for looking up the IP addresses of network interfaces and checking their statuses. Let's just type in netstat itself and see what we get and hit enter. Right, and we're going to see immediately quite a bit of information, right? We see what protocol it's on, right? This is the Unix protocol, flags, state, right? We see connected for a lot of these, right? And we'll break this down in just a second here. And we also see the path to all of these, as well as what is called an inode, or basically just like its identification number here, right? So netstat in and of itself, it overwhelms us with quite a bit of information, right? We're going to see up here, right, active internet connections. And then down here is all of the active, what we call domain sockets. So let's simplify this a bit. Let's step through that because that was a lot of output, right? The vanilla netstat command can be overwhelming, right? But we can break this down piece by piece here. So next up, we have the netstat-c command, netstat-c. And when I hit enter, it's going to look very similar to what we just saw by doing the vanilla netstat command, right? The main difference here is if you notice at the bottom, I didn't get my shell prompt back, right? And the reason for that is this is actually a dynamic list of all of the active connections. And as things change, right, this list will update, right? In order to quit out of this, right, I can't do Q, I can't type in quit and hit enter. I actually have to do Control C, right, to get my shell prompt back. So next up, we're going to use the netstat-a command. So I'm just going to type in netstat-a. This is going to show me all of my connections regardless of state. So if I scroll all the way up to look, right, we're going to see right off the bat, it's actually relatively simple to follow once we break it down. It gives us the protocol, in this case TCP, right? We also see UDP down here as well. Gives us the local address, right? We can see these connections are on my local host. It gives us the foreign address, right, where those connections are going. And then last but not least, the state. Right, now we see a couple of options with the state. We see a couple of listens. This means that this is not an active connection. It means we are currently listening out, waiting for a connection to be made. Right, so this is almost like sitting by your phone, right, waiting for somebody to call you. Right, you're listening out for your phone. This established state, on the other hand, is when you have an active connection between the two parties. Right, both my Ubuntu machine and this Edge Star Mini HTTPS foreign address, right, are talking to each other, right? And if you're wondering where this is coming from, right, notice HTTPS is for the internet, right? That's probably because of my web browser here that is open, right? That is that established connection, right? So once again, netstat-a is showing us all of the connections, right? And we can see the protocol local address, that's us, foreign address, that's where we are connecting to, and then that state. Now, what if we want to find particular pieces of information here? What if I wanted to find only the connections that pertain to TCP, right? We saw before when I did netstat-a, we got TCP, UDP, all of it, right? What if I only was interested in these TCP ones? What I could do is I could do netstat and then do -at, right? So this is the same command as before. I'm just appending a T at the end here, right? And this will only get me, as we see, all of the TCP connections. Additionally, what if I'm only interested in UDP? Very similarly, right, I could do, instead of AT, AU, right? And we will only get those UDP connections here. Right, why is this helpful? As we saw before, there's a lot of information that is generated if you are not specific. So by putting that extra option flag at the end, right, we can really narrow down our output here and save us some time in the long run. Next up, what if we wanted to find only the items that we're listening? Right, I'm not worried about these established things, right? Let's pull that command back up. I want to find only the particular processes that are currently listening. What I could do here, right, first and foremost, we could actually do this with grep. So I want you all to guess and pause the video. What would I put after grep in order to get only the listen states? Well, if you guessed the word listen, you are correct, right? So if I put listen at the end here, list them, listen, and hit enter, right? That is one way to get it. However, netstat also has an option built in for this, right? Let's say instead of all connections, right, I'm going to go back. I just want the listen connections, the one where the state is in listen mode. what I could do is instead of -A, I'm going to do -L, right? Once again, if I want to get only the TCP connections, I could do T at the end, right? And we'll see all of those listens. Now keep in mind, if you take out the T and do L, right, you'll get all of the options that are in listen regardless of their protocol, right? So just keep that in mind here, right? So by doing LT, we are narrowing it down to only the TCP connections that are currently listening. Last but not least, the last option I want to show for this video is going to be netstat-p. This is going to display all of our current connections, but it's going to do one other thing that's going to be very interesting to us. And if we scroll up, we're going to see that right away. It will actually give us a PID, a process ID here, right? So we could see where these connections have been generated, which processes they are associated with, right? So this is a throwback to previous videos where we used PS and top, right? With PS and top, we can understand, okay, what's going on? What is actually creating this current connection or listening connection on my system? And also we can end these processes if we no longer want to run them, right? So that is our intro to netstat. Of course, there are a lot more options that we can use with netstat. However, the ones I showed are some of the most common, right? So as you move on and use netstat more and more in your careers, you will all add more options to your repertoire and really understand just how lucrative of a tool netstat is. So thank you for joining me in this video. In the next video, we're going to talk about the SS command. Welcome back. So in this video, we're going to go over the SS command. So previously we saw how to use the netstat command. This command is going to be very similar, and even the option flags are going to be mostly similar. So as always, right, we could do SS, right? This is our command for this video, --help, right, and get a pretty good understanding of what is going on. I'm actually going to do the man page, man SS, right, just so we can get a description too. So right off the bat, right, it says it allows showing information similar to netstat, right? You can expect the information to be the same, just in a slightly different format, right? And it can display more TCP and state information than other tools, right? That's the main reason why you might use SS as opposed to some of the other ones in this situation. Right off the bat, we have some option flags. You're going to notice some of them are actually going to be similar, right? We see -A is here, -L is here, right? I'm going to show you all how to use those. And it's going to be very, very, very similar to how we used netstat previously. So I'm going to hit the Q command to quit out. I'm going to type clear to clear my screen. Let's get started. So to start us off, if I just do SS and hit enter, right, let me scroll up so we can see the column names. Immediately we're going to see some columns that are very similar to netstat, right? We see state, we see local address. In this case, they named it pure address instead of foreign address. And also we see some port numbers as well. One thing I want to point out, right, is we have this receive queue and send queue. What this actually stands for is, with receive queue, it is the amount of bytes that were not successfully received or copied by the user program. And for send queue, right, it's actually the amount of bytes that were not properly acknowledged by the pure address or foreign address in this case, right? The amount that were not basically accepted by our remote host here. So those are two columns I just wanted to add here, but the rest of this should look relatively familiar from the last video. Right, so this is the vanilla command. As you all know, the problem with just doing SS or any command without putting options is you're going to get a ton of information. It's going to be nondescript, right? You're going to have to sort through all of this just to find whatever it is you are looking for. Right, keep in mind, this is a brand new Ubuntu machine, so although this looks like a manageable amount of connections to look through, if you have a machine that's been running for a while and has a lot of connections, it quickly becomes overwhelming. Right, so let's use some specific options. So if I do SS-A, right, so the A option, right, this is going to show me both the listening and non-listening ports, right, and those processes, right. So if I scroll, where did it start? Oh, it starts all the way up here. So with SS-A, right, it's going to get us pretty much everything and show us all of the information here, right, in the same format as before, this net ID, state, receive queue, send queue, right? So nothing too new. Just know with -A, you will get both the listening and non-listening ports, right? So you'll see pretty much everything here. So now we're going to run the SS-L command, right? So SS with the -L option at the end. You're going to notice right away, although -L is meant to specify just the listening ports and the listening connections, we also have unconnected as a possible state type. The reason for that is unconnected states and listening states are actually in the same category, right? So by doing SS-L, right, we filter to that. Similar to netstat, if we do SS and then -L like we had previously and add a T to the end, right, in the same exact way that this works in netstat, it will work the same with SS. We are only going to see the listening TCP connections. So when I hit enter, right, we see right away these listening TCP connections. As you probably guessed, if I swap the T out for a U, that is how we see the UDP connections, right? We can see those unconnected states popping up here. We don't have any actual listening states. For this one, it is all unconnected. Last but not least, right, what we're going to show is SS-P. Once again, very similar to netstat. The main reason why we'd use the -P option is so that we can actually see the process ID. Right, and once again, the reason this helps us, by seeing the process ID, we know which processes are actually responsible for which connections. Right, like right here, I actually see Firefox. Right, so Firefox has a connection open on port, looks like 138,000. It is established. Right, so that's pretty interesting to us. So thank you for joining me with this short video on SS. As we have just showed, it is a very similar command to netstat, and a lot of the knowledge we got from the last video carries over and should simplify our learning of this tool. Thank you for watching, and I will see you all in the next video. In this video, we're going to talk about the commonly used ping command. Right, so this command is great for troubleshooting. And then also from a security perspective, a lot of times hackers will use it to find different machines on a network that they are able to communicate with. Right, so to jump right in, I'm just going to look at the man page for the ping command. So I'm going to type in man ping and hit enter. So what we see here is the ping command is sending what we call ICMP, or Internet Control Message Protocol, request to network host. So basically what's happening is, picture it as me giving a call to, let's say, a friend. Right, if I pick up the phone and I call a friend, right, they may pick up, and it means that myself and that friend can now communicate. It's the same concept with machines, right? If my computer is able to ping another computer, that means that those two machines are able to communicate and interact with one another, right? So a ping is basically just a phone call, and if somebody picks that phone call up, right, you're now able to talk. But if they don't pick it up, right, you're not sure if they're away from home, you don't really know why you can't connect, and it leaves a lot of ambiguity and troubleshooting to be done, right? So a lot of times, as I was saying before, in a corporate setting, you will use this command to figure out which machines on a network you can actually reach, which you can talk to, and find out which machines may actually be down and not available. So I'm going to hit Q to quit out of this, and I'm going to ping www.google.com. Right, before I run this command, pinging google.com is essentially the same as me querying it. If I went here and typed in my URL bar, google.com. The fact that I can navigate to google.com means that when I ping it here, right, it should actually work. And this is what a successful ping looks like. I'm going to use Control-C to exit out, right? But if you see 64 bytes back from the server name and the IP address, that is a success. That means that I can talk to www.google.com. Two other fields to note that are interesting to us, right? One is the sequencing, right? We can see the packets came in order, 1, 2, 3, 4. TTL, this stands for time to live. This is how long my machine is waiting for this packet before we declare it to be dead, right? We say, hey, it wasn't able to reach us in time, right? In TTL, it's in milliseconds. So if the real amount of time it took, right? So this is the real amount of time it took for Google to communicate to us. If this was higher than the TTL, right, we would get an unsuccessful ping, right? So let's look at what that looks like. I'm going to ping an IP address I know I cannot reach and hit enter. So this is what an unsuccessful ping looks like. I'm not getting any information back. I just see this one line and it gets stuck here. Now you might notice it's been probably 10 seconds and the line is still stuck. If I was writing a script, this would completely derail my script, right? Because it would get stuck on the first line and it wouldn't be able to check, let's say, the next couple of hosts. So a lot of times what you'll do if you're not sure if a host is online is you're going to use -W to enable a timeout period. So I'm going to do -w1, and what this is going to do is it's going to set a timeout period of 1 second. So when I hit enter, it's going to wait 1 second, and that's going to finish the command and tell me, hey, we have 100% packet loss. Right? So let's show this in a bash script. I want you all actually to take an attempt at this. Pause the video. The task is going to be this. I want you to write a bash script that is pinging IP addresses of 10.10.10.1 all the way up to 10.10.10.254. So once again, write a bash script, write a one-liner here, that will ping every IP address from 10.10.10.1 to 10.10.10.254. All right, so I'll show us now how we do that. So first, for our for loop, I'm going to do for IP in. I'm going to start my range 1.254. As we have said before, this is the acceptable range of IP addresses. Do, and let's do ping. I'm going to do the -w command. I need a timeout, or else we're going to get stuck on the first entry, like I said before. -w1. I'm going to do 10.10.10 $IP, right, to insert my variable. Right, so just to reiterate from previous lessons ago, right, or about 2 sections ago, right, this variable, if we insert it here, will rotate between 1 to 254 every single time we loop. Lastly, done, and now we are good to go. And as you can see, I have now successfully wrote a script that's going to check every single IP address and see if I'm able to connect to it. And as you all know, for all 254 of these, I cannot, unfortunately. One thing to note here, if I do Control-C, technically each command's different, so I actually have to Control-C out of all 254 of these. Oh, looks like I did. Right, eventually it just seems like it overwhelms it, right? But it's pretty tricky to close out of that when you start running it. Okay, so that's the -w. Next up is going to be -c. When I ping www.google.com, what you also notice is I'll get a continuous stream of these lines, right? 64 bytes back from blank. If I'm saving this to an output file, I probably don't want all of this extra information, right? I only want one line, right, saying that it is successful. Right? And the reason for that is this is going to take up a ton of space. If I'm doing this for a lot of IP addresses, right, it adds up quickly. So what I'm going to use is the -c command. I'm going to do ping -c 1. And this will basically return only one entry, right? And when I hit enter, you see it happening right away. I received only one entry, and it's not continuous, right? Which will reduce my output, right? But still give me the same answer here. Next up, let's say, right? Once again, too much information. We don't want the server name. I could actually add the -n in front. This stands for numeric, and now I have only returned my IP address. I'm no longer getting this anymore. Right. Additionally, let's say I'm only interested in the ping statistics, right? The overall statistics at the end. What I could do here is I could do ping, let's do instead of -n, -q, right? And we'll see the statistics at the end here as well. Keep in mind for -q, I need to leave the -c1 in here. If I don't, it's going to take a long time and it will never run out, right? The -c is what actually requires there to be a timeout here, right? A timeout of one packet or one entry. -w would also work here, right? If I did -w and 20, or let's do a 5, right? This will time out after 5 seconds and will get me those statistics at the end as well, right? And we'll basically make sure that I get what I want. All right. Last but not least, the only other thing I want to show is that I can ping www.google.com, but I could also ping the IP address directly, right? It's interchangeable. So if I wanted to, I could do ping 142.251.40.228, right? And as you can see, I'm getting a success there as well. All right, so thank you for joining me on this video. Hopefully you feel like you have a better understanding of the ping command. It is a powerful tool that is used to test the connectivity between us and other hosts. Thank you for watching, and I'll see you all in the next video. Welcome back. In this video, we're going to talk you all through the host command, right? So what does this command do? Well, if we run the man page on it, it is what is called a DNS lookup utility. Right, and what that means in plain terms is if you have a domain name and want to figure out the IP address, host can do that, and vice versa, right? If we have a IP address and want to figure out the domain name of a server, right, host will allow us to do that, right? To show it in action, I'm going to type in host www.google.com and hit enter. Right, and we can see right off the bat, right, this is the IP address of google.com, right? And we're able to get that just by inserting the name up here. We see this is the IPv4 format, right? But we also see down here is the IPv6 format in all its hexadecimal glory there. Now, what else we could do is we could use the -a option. I could do host -a /dub google.com, hit enter, right? And as you're going to see here, we're going to get a lot more information than we did before, right? Instead of just getting my answer, right, like these IP addresses, I get actually more IP addresses, right? I'm seeing the full route here. And in addition to that, I'm also seeing the type of record, right, that these were returned by. Now, in terms of information on records, there's really a lot, right? My favorite place to go is this Wikipedia page for record types whenever I stumble across a new one. Right? The best way to think about it, right, is depending on the record type, right, it's going to specify what exactly you were querying, right? For example, if I query an MX server right here, what I'm really doing is I'm sending that DNS query to their mail exchange record, right, and trying to figure out if I can communicate with that device there. So with the -a option, we are able to see more information, right? Similarly, instead of -a, we could do -v for verbose. And it will give us more information, specifically information on record types that we are interested in here. All right, next up, right, now that we know a little bit about record types, let's actually try to find information pertaining to the mail exchange server for Google. What I could do is I could type host -t for type, and I'm going to type in Google, or excuse me, MX for mail exchange, google.com, and hit enter. Right, and as you see here, I just got the names of all of the mail exchange servers that Google has, right? So it seems like there's this main one right here, but they have an alternative 1, alternative 2, alternative 3, and alternative 4 mail exchange server, right? I just got all that information. Similarly, I could swap this out with NS, right? NS is the record for name server, right? And this is going to give us some names of the authoritative name servers here, right? So I'm going to do host -t for type, NS now, and hit enter, right? As you can see here, these were non-creatively named NS1, NS2, NS3, and NS4, right? But we are still able to query that information. Now keep in mind, host is not the only tool that is able to do this. There are two other tools, NSLOOKUP and dig, that can do it as well, right? It's just that host is pretty lucrative, it's pretty flexible, and it's a great tool to learn, right? But I could also use NSLOOKUP here, www.google.com, right? And I could get my answer this way as well, just in a different format. Similarly, I could use the dig command. Let's do www.google.com, right? And as you see, I still get information, right? It's just going to be in a much larger format for dig specifically here. Right? So keep in mind, right, this information, right, is you're still getting. So keep in mind with these three commands, you're still getting to the same endpoint, right? It's just that they may have different options and syntaxes to get there, right? So for the purpose of this course, we focus primarily on the host command, right? But it's really personal preference. So thank you for tuning in. I will see you all in the next video. Welcome to the video. We're going to be talking about the etc host file as well as the etc resolve.configuration file. So this is going to be a relatively quick video. When I do cat /etc/host, you're going to see an interesting file, right? The way this file works is we have the IP address on the left and the name, right, or the alias that we gave it on the right, right? So what does that mean? Well, it means if I ping 127.0.0.1, right, this first entry here, and hit enter, right, I'm going to be pinging that IP address. But what we can also do, because of the fact that we have this written in our etc host file, we could just ping localhost instead. It is acting as an alias. right? So instead of pinging 127.0.0.1, I'm going to ping the word localhost and hit enter. Right, and as you see, we're getting the same results, right? Both of these commands, this command here and this one right here, is pinging the 127.0.0.1 IP address, right? Just doing that here, right? And these are for performing the same actions, right? So by editing this file, right, let's say I do sudo vim /etc host, right? Reminder, vim is our text editor. If I edit this, let's do sudo nano. Actually, wait. If you get the vim command not found, I actually booted up a new virtual machine. You may have to do sudo apt install vim, right? You won't have to do this if you have installed it in previous videos, right? But keep that in mind. You can either use nano or vim, whichever text editor you prefer. I'll be using vim in this video once it is finished downloading. All right, give it 1 second. Perfect. So what I could do is sudo vim /etc/host. And we have the file as just reading before, and I'm going to edit it. Right? Remember, nano and vim is differently. With nano, I can edit right away. With this vim text editor, I have to hit the I key to go into insert mode first. I'm just going to put a random IP 10.10.10.10. Let's name it Ryan, right? And I'm going to control out of this. So I'm going to do escape shift:/WQ to save and quit, right? Feel free to pause the video, rewind the video on this. I know Vim is a complicated text editor, right? So once again, to quit out of it after you have edited the file, you have to hit the escape key, shift, and then the colon key, and then WQ for right quit down here, and hit enter. Okay, so if I cat that file, we should see the changes now, right? And all I've done, right, is I've just added this entry saying that I want this IP 10.10.10.10 to be the same as the alias Ryan. So if I ping Ryan and hit enter, you will now see that I'm pinging the 10.10.10 IP. Now, of course, this ping isn't working. 10.10.10 isn't a real IP address, right? But it is to show you that with this etc host file, right, we can actually save some time, right? By putting IP addresses that I commonly use in here and giving them a name, right, I'm effectively setting up my own local DNS server, right? My own local DNS system here. I'm going to go back into my file and edit this out, right, and then we'll talk about the last file for today. Once again, escape, shift:/WQ to quit and exit. Keep in mind, if you run vim without sudo, it will not work. This file is protected, right? It's privilege protected, so you need to be the super user to do these commands. So next up, I'm going to clear my screen. Let's cat the etc resolve.configuration file. Now, we're not going to be editing this, right? And the reason is because it says do not edit, right? You're not supposed to change it, but I do want to talk us through it, right? Basically, the purpose of this is to have this internal DNS server, right? And it will list all of these configured search domains. Now, you can see here that my name server currently has an IP address of 127.0.0.53. Now, you might be wondering what the significance of the 53 at the end is here, right? And just to give you all a glimpse into it, 53, the number 53, is actually the port number for the DNS protocol, right? So that's why they've chosen it there. In terms of other things to know about the file, really that's just the main thing that we should understand here is we have the name server. It is on this IP address. All right, well, thank you for joining me in this video. I will see you all in the next one. Congratulations on completing section 3. In summary, these are the sections and the topics that we have covered. Right? We went over these commands: route, ifconfig, IP, netstat, ping, host, and ss. We talked about network configuration, right? We saw with the routing tables, right? And with that route command specifically, how we're able to change our network configurations, actually change which destination IPs are routed, which ones become unreachable. And then last but not least, we showed with host the DNS system. Right? We talked about DNS, and we showed with host how to pull those DNS records. So thank you for joining me in section 3. I will see you all back in section 4. Welcome to section 4. In this section, we're going to be covering security and file permissions within our Linux systems. All right, so the agenda for this particular section is we're going to learn a couple more Linux commands as always, right? We're going to learn the id, last, who, w, chmod, chown, chgroup, sudo su and passwd command. We'll also be talking about permissions in Linux, right? Read, write, execute permissions. What do they do? How are they represented in our system? What is the default permissions that are given to a file when they're created? And then lastly, we're going to talk about security best practices, right? You cannot talk about permissions without talking about security, right? And because of that, we're going to discuss on your Linux system, how do we enforce what's called the concept of least privilege? So thank you for joining me in this video. I will see you all in the next one. Welcome. For this video, we're going to be talking about security and file permissions within Linux. So the agenda is to talk about permissions in Linux, then to jump into temporary files and directories, and then lastly, symbolic links. So to start us off, right, we probably have some basic knowledge about permissions. Whenever we ran executables previously, right, in the earlier videos, we had to always do chmod plus x, right? That was an early example of us changing the permissions of a file in order to allow us to use our script. In this case, we have three main permissions that you all need to know in Linux. The first one is the read ability, right? So the read ability is your user's ability to read the contents of files. Right, so the best way to think of it is when we cat a txt file, right? If you have the read permission, you will actually be able to print those contents to your terminal, right? You'll actually be able to read the file. Now, if you didn't have those permissions, you wouldn't be able to cat the file. It would say that you're not allowed. Next up, we have the write permission, right? Instead of just reading the file, this is the permission that will allow us to actually change the contents of that file. Right? This is basically when we use vim on a file that already exists and we try to change the contents, right? You'll notice if you go to save that file, sometimes it'll give you a permission error, right? Because you may not have the actual permissions to edit that file in any capacity there. Last but not least, we have the execute command, right? The execute permission, right? This is the user's ability to execute a file or, to view the contents of a directory, right? Just keep in mind that for a file and a directory, execute is going to be a little bit different. An example of this is, as we used previously, running a script, right, is an example of the execute command. Now to dive into permissions and how they could be represented in a different way, right, we can see here that there are different numeric representations for each permission, right? For example, to have 0 permissions is represented with a 0. To have only the execute permission is represented with a 1. To have both the write and the execute permission is represented with a 3, because you have to add up the numbers for each permission. And then to have read, write, and execute, right, that actually adds to a total of 7. Right, remember, the execute permission is worth 1 point, right? The write permission is worth 2, and then last but not least, the read permission is 4, right? So in order to figure out what permissions you have, you actually have to add them all together, right? And that's shown a little bit more clearly in this chart here. Right, we have 3 different entities, right, and we'll actually see this when we move over to our Linux systems, how this is represented when we use the ls command. We have 3 different entities here: the owner, the group, and what we call the world. This is called UGO notation. So the owner, as you can see to the left here, has a 7 representing their permissions, right? If we go back to the previous chart, we could see 7 means that the owner has read, write, and execute permissions, right? This is the most permissions that individual can possibly have. The group, on the other hand, has a 5 instead of a 7, right? If we go back here, 5 is just read and execute, right? So we could tell with this chart that the G, right, the group, people within the group that owns this file, only are able to read and execute, right? They're not able to write. They can't change the contents of the file, but they can read it, they could cat it, and then they could execute it. Last but not least, we have the world category, represented with O. It stands for other, right? The world category is everybody else, right? So owner is the person who had created the file, who owns the file. Group are individuals who are in the same group as the file. And lastly, world is any other possible user, right? And they have the number 4 to represent their permissions, right? And we can see here that if you have a 4, you can only read this file. So to talk plainly about what all this means, right? The owner has full permissions. They could read the file, change the file, execute the file. Group can only read and execute the file. They cannot change it. And then last but not least, world can only read the file. They can't change it or execute it. This brings us to the concept of least privilege. Right? What is that? Basically, it is the practice of giving individuals, giving users on your system, the least possible amount of permissions or access they need to perform their job. For example, if you have an intern on your system, you're going to give them very little permissions, just the bare minimum they need to perform their day-to-day functions. Why do you do that? Well, it reduces the risk of internal threats. Right? Remember, internal threats could be both accidental or it could even be a disgruntled employee. And by reducing the amount of privileges that your employees have, they can do less harm, right? Whether it's accidental or intentional. Additionally, interns probably don't take as great of care of their accounts, right? And maybe they lose their password. And if you enforce the concept of least privilege, it's not going to be as significant of a threat to your security posture. Additionally, this can help us stop the spread of malware, right? As I said before, if your intern loses their credentials, right, if the concept of least privilege has been properly followed, a hacker will not be able to use that account to do more than what that intern should be able to, right? They're probably going to be relatively limited in their ability to harm your system any further. And this brings us to the last point, right? It will reduce the risk of privilege escalation. Right? Privilege escalation is the concept of if I get a low-level account like an intern's account with few amount of permissions, am I able to escalate to a higher level account, right? Or an account that is more critical, like an admin account. Right? If we enforce least privilege, that is unlikely. So let me show you a very common example of bad security posture that happens in a lot of workplaces. Right? You may have even seen it in wherever you work. Right? So there's this concept of privilege creep. Right? This is when privilege, the concept of least privilege goes wrong. So we have in the middle here this financial analyst. This financial analyst's name is Bob, right? And Bob has access to financial resources. Let's say Bob has a career switch and switches over to IT audit instead, right? Horizontally pivots, right? Now Bob has access to the IT audit resources as well. Last but not least, right, Bob basically then has another career switch, moves to tax audit, right? This is a bit of a diagonal promotion, right? Moved to a different practice, but moved up a level here, right? And now has access to the tax audit resources as well. Right? The problem here, right, as you all probably have noticed because we talked about it previously, is that as Bob has moved around the company, he has only gotten more and more privilege. Right? There's no reason why Bob should still have access to the financial resources or the IT audit resources when he's no longer in those departments. Right? So it's very commonly an issue in organizations, whereas people move throughout the organization, they never deprovision their access. They're only granted more and more access until one day they have pretty much full reign over the company's system resources. Right? So this is the example of privilege creep, and this is a huge problem that exists in many systems, in many organizations today. All right, moving on, we have temporary files and directories. Right? So we talked about the concept of least privilege before. Now let's talk about what temporary files and directories are. The best way to think of it is on our Linux machine. This is going to be two different directories, the /tmp directory and then the /var tmp directory. Now these two directories are very similar. The concept of them is to store files that are temporary or are supposed to be deleted, right? Not supposed to be permanent and stay there. The difference between the two is the /tmp directory will delete all of the files in it every time the system reboots. With var tmp, it will actually persist on reboots, right? But keep in mind, both of these directories are meant to hold files that are not going to be permanent, not going to be left on our system. The security implications of these files, or these directories rather, are that they are world executable, right? And the issue with this is basically an attacker can use these directories to possibly execute malware on a system, right? So that is a security implication here, is that users within these directories have higher privileges, and because of that, it's a common place for hackers to try to move different sorts of malware on there. Maybe they move something called linps, which is a privilege escalation malware, and they'll execute it within these directories themselves. Right. Last but not least, before we finish up the deck here, we have symbolic links. Right? There's two different types, hard links and soft links. Hard link is basically just an additional name for an existing file, and this allows us to associate two or more files with the same index node. Right? So we're taking two files and we're actually associating them. Soft links, on the other hand, right, instead of adding an additional link to an existing name, right, or existing file rather, we're going to make something that's similar to a Windows shortcut. What's going to happen is it's going to be what we call an indirect pointer to a file or directory, right? So instead of having an additional name for an existing file, right, such as a hard link, we're just going to have a pointer, an indirect pointer, that will usher us to that other file with the soft link here. So that wraps us up for this section. Thank you for joining me, and I will see you all in the next video. All right, for this video, we're going to be covering two commands, the sudo command and the su command. Now for the sudo command, we've seen it quite a bit because we've needed to use it in previous videos, right? And the whole purpose of the sudo command is to run a command as the super user. It actually stands for super user, right? So su and then do, right? Super user do. So for example, whenever we needed to do a highly privileged action, such as let's say editing a configuration file or downloading a package, we had to do that as root privileges, and the Ryan user by default does not have those, right? So to show this, right, if I do apt install random, right, this is not a real package, just a random package, and hit enter, you're going to see that this is actually a permission locked action. It says, are you root, right? I need to run this as a root user. Now, in order to do this, all I have to do is sudo and then type in this command again. Or the shortcut that I love to show is we could do double exclamation points, hit enter, and it will automatically append sudo to the beginning of our previous command. Now, in this case, it fails, right? Because random is not a real package, right? But you could see that it actually ran and tried to install it. So that is the sudo command, right? Whenever it says, are you root, or you need elevated privileges to do this thing, right? Sudo is a good way to go. Just keep in mind, most of the time when you run sudo, right, I wasn't prompted because I have done it recently, you will be asked to put in your password to confirm that you are who you say you are, right? Another thing to note, right, and before I do this, I'm actually going to change the password of my root user. And I suggest you all do the same, change it to something you know. So I'm going to change that password. Oop, do not match. Let's try again. Issue of secure passwords is that even you don't know them sometimes. That's how secure they are. Perfect. So I just used the passwd command to change the root password. We've done this in previous videos, and we'll dive into it a little bit more in later videos to come. What I can do now, right, is I could actually switch users to the root user. So if I type in su and then the name of the user, right, root, if I give the password I have just changed root to, I am now able to switch my users over from Ryan at Ubuntu to root at Ubuntu. And if I run who am I, right, I can see I am now the root user instead of Ryan, right? It's also interesting because the color scheme changes. Our environment variables are different. So the color scheme for the root user is different than Ryan. In order to switch back, all I'd have to do is su Ryan. And since I am the root user, I'm not actually prompted for Ryan's password because root could do whatever they want, right? So if you're logged in as the root user, you don't have to be prompted by passwords, which is a nice thing. Another thing to note is when you are acting as the root user, you don't actually have to use sudo because once again, you have the privileges by default. The only reason we use sudo with Ryan is because Ryan does not have those privileges right off the bat. Another thing, the last thing to note with su is you could actually run individual commands with su. Let's say I wanted to run just one command as root. What I could do is I could do su root -c, and then let's do ls, for example. ls-l, right, the command itself. It's going to prompt me for the root password. I'm going to put that in. And when it goes through, right, it's uneventful. I didn't have too much in my directory, but it prints it out here. Let's do another one just to show. Let's do apt install yum, right? This is a command that we know requires sudo, right? So what I'm doing right now is I'm switching to the root user for just one command, and that command is this. If I hit enter, type in the password. Keep in mind the password will not give you feedback, right? We could see that it will run through. So that is the sudo and su command. With those two commands, right, you should be able to start switching users and being able to run privileged commands without having to switch users every single time. So thank you for joining me in this video. I will see you all in the next one. Hello and welcome to the video. We're going to learn 3 new commands, one of which we've already used, so it will be a little bit of review. And those 3 commands are chown, chgroup, and then last but not least, chmod. So to start us off, right, I switched to my downloads directory just to show you how to get there. I'm going to cd back to my home directory, right? And all you have to do is cd to downloads, right? Once again, cd is change directory. Why am I doing this? Well, we're going to create a couple files, and it's not good practice to fill up your home directory with just random files. So we'll do that in downloads for now. So to start us off, I'm going to create a file, and let's look at the default permissions that this file gets. right? So this file is going to be called permissions underscore file, and I'm going to hit enter. When I do ls, I see the file is now there. However, something that's new is we could do ls and add the -l option, right? This is the option flag for long listing format. And we could actually see on the left is the UGO permission notation that we have talked about in previous videos. So right off the bat, we can see the owner, right? The Ryan owner has read-write privileges. The group, right? Also Ryan, because this user is part of the Ryan group, has read-write privileges. And then last but not least, everybody else only has read privileges, right? This is the default that we get. So by default, the owner cannot execute this script, right? This is what we faced in earlier issues, a problem that we faced in earlier videos, right? If I try to execute this file as if it's a script, we're going to get this permission denied, right? And even if I try to sudo it, right, it's still, let me add a space there. It's still going to give us issues, right? So we have these permissions, we have this file. One thing to note is we could change a couple things. The first thing we're going to change is we're going to change the actual owner of this file. So to change the owner, what I'm going to do is I'm going to do sudo, right? Because I'm going to use super user privileges depending on which user I'm changing this to. I'm going to do chown. I'm going to name the user I want to change this file to. I'm going to do it root, right? So I want this file to belong to the root user instead of Ryan. And then last but not least, I'm going to put the file name, and I will tab complete that and hit enter. Now, if I do ls-l, right, hit enter, right, you're going to see right away that instead of Ryan as the owner, root is now the owner, right? Now, the same thing works for group, right? Remember, first comes owner, then comes group when it comes to this long listing format, right? So in order to change the group, I'm going to do something almost identical to the previous command. Just instead, I'm going to do sudo chgrp, right? This stands for change group. I'm going to change this to the root group, right? And then once again, I'm doing it on the same file, and I'm going to hit enter. And I'm going to check my work with ls space -l. Right now you can see from where we started, where it used to be that Ryan was the owner and Ryan was the group, right? It's now the case that it's root and root. One of the last things I want to show here is that we could actually change these permissions after creating the file, right? These permissions right here aren't set in stone. And we've actually seen in previous videos, right? We've changed a text file into an executable so we could run it as a script, right? So what I could do here is I could use the chmod command. I'm going to do sudo for this. So I'm going to do sudo chmod. And there's a couple different notations we could use. We could either use a numeric notation, which looks like this, right? It uses these numbers. 7 stands for read, write, execute. 6 read and write, right? And basically the way that these numbers are calculated is just by adding up these 3, right? So this is a nice little cheat sheet, right? So I could chmod, and to give full permissions, right, as we see in this chart, it would be 7 in every category, right? So the first way to change permissions, right, to get this all to read, write, execute, would be to do sudo chmod 777. That'll make this segment read, write, execute. It'll make the second segment read, write, execute, right? So second 7, and then the third 7 will make the last and final segment of the UGO notation read, write, execute. All right, so let's run this and check our work. ls-l, right? And we could see that that change is now taking effect. What we could do instead of using the number format is we could also use the UGO notation itself. So instead what I could do, right? So instead of using numbers, I'm going to change 777 and I'm going to do U for owner minus, and let's do read write and hit enter. Right? So keep in mind there's also this format where depending on if you put a plus sign or a minus sign after a U, a G, or an O, it'll either take away or grant new privileges. So if I do ls-l, right, you can now see that the U, right, this is the U portion, these 3 bits, has actually been deleted, right? We deleted their write and read privileges here, right? So it is no longer the case that root, right, the current owner of this file, has permissions to write and read this file anymore, just execute. We could also do this, right? If we create a new file, I'm going to do touch new file, we could also do a lot of these different letters all in one fell swoop, right? I could do sudo chmod, and for example, I could do u equals, let's give the owner full privileges. Let's do group equals just read and write. We don't want them to be able to execute. And then lastly, everybody else, right? O is just other basically. Let's do equals R, right? So they could just read. Let's do this for a new file. Basically what I could do, right, as we saw before, we could add and subtract privileges using the plus and minus sign. We could also just completely overwrite the current permissions by using the equal sign here, right? So if I hit enter, missing, I have to make these no spaces. Yep. Keep in mind the syntax is a little finicky, right? Keep in mind that these spaces actually cannot exist. You need these all to be touching, these three. But now if we do ls-l and hit enter, right, you're going to notice that this new file has exactly the permissions that I have just specified. Now, as we said before, just to practice one more time, you can remove these permissions, right? Let's say I do u minus, let's do minus x, g minus r, let's do o minus r. I want you all to guess what's going to happen when I do ls-l. So pause the video and guess what the permissions for this file will look like after running this command. All right, let's check and see if we got it correct. Right, as you can see now, the owner lost its executable permission, the group lost its read permission, and then the other, right, all other users actually lost their only permission, which was originally read. They had lost that as well, right? So that is how we use chmod, chgroup, chowner, right? The reason we do this is to enforce the concept of least privilege, basically giving people the least amount of privilege to do their day-to-day tasks so that less can go wrong, right? Let's say we have touch, important file, right? Let's say we have an important file and anybody could change that. Ooh, I made two files technically. Let's say we have an important file and anyone could rewrite and execute it, right? That could be a problem. You might not want the Ryan user to be able to vim this file and change its contents, right? So that is why we would lock that down and restrict it. But thank you for joining me in this video, right? Once again, we have gone over the chgroup, chown, and chmod commands. And I'll see you all in the next video. Hello, hello. In this video, we're going to go over two new commands, the user add command, as well as the group add command. All right, so to start off, we're going to type in man user add, just to see what this command is about. Right, and right off the bat, we're going to see that this will allow us, unsurprisingly, to create a new user. Right? Why might this be important? Well, if you are working for a company or if you own a company, you're probably not going to want to give the intern the root account, right? You're going to want to give them a separate account with different permissions, probably permissions that are somewhat restricted, right? And in this case, it makes sense to have to add a new account for that intern, right? Or let's say you are a family person, right? A person of a family, and you have multiple people within your family all using the same machine. You may want different accounts for that as well. Right, so what I'm going to do is show us how to add a user, right? User add, I'm going to name this one intern and hit enter, right? And we're going to see permission denied, right? So we're going to have to use our knowledge from a previous video on how to get past permission denied. So please pause the video and let me know what you all think. How do we get past this issue here? Well, welcome back. If you guessed using sudo, right, I'm going to use sudo and then the shortcut for it, you are correct. So we see it is repeated back to us, but we get no other input specifying that this has ran correctly, right? How do we see that this has ran and that this new user has been created? Well, the way to do that is actually by accessing a file called the etc password file, right? So if I do cat /etc/passwd and hit enter, you're going to see that my intern user has been added to my system. Right, and we see that their ID number, right, their user ID and group ID is actually incremented from the previous account, right? So that's pretty cool. We just added a new user, right? Now what we could do, right, is we could try to sudo su to intern. And if I do who am I, right, I'm now the intern account. Right, now notice my shell looks different, right? It's kind of ugly, right? It doesn't really have that prompt that we see before Ryan at Ubuntu. Just keep in mind that is because this user has different preferences. Their environment is set up differently. Now to quit out, I'm just going to hit exit, right? And that will bring me back to my Ryan account here. So we just created a new account. We checked it out in the etc passwd file, and then we switched to that user. Next up, we can also add new groups, right? So before we add a new group, let's look at the existing one. So unsurprisingly, once again, right, this is going to be in the etc directory, except the name of this file isn't going to be passwd, it's going to be etc/group. And when we hit enter, we see all of the possible groups. One thing to note, right, is when we made this intern, it actually created a group called intern as well, right? So keep that in mind. But let's create a new group without a user in it, right? Let's just do the group add command, and then we're going to do intern group and hit enter. Once again, permission denied, right? So as we saw previously, all we have to do is sudo double exclamation point. This is a shortcut to rerun the last command just with sudo privileges. Hit enter. And finally, what we can do now is we could cat etc group to see if this command has successfully ran, right? And we see this is a new group that we have just created. It has the same pattern of ID here, just incremented by 1. So in the next couple videos, we're going to talk about how to add users to these groups, remove them, give them permissions, give different groups abilities to do different things, right? But for the purposes of this video, that is it, right? We showed you all how to add a user, and we also showed you all how to switch to that user, and lastly, add a group to our system. So thank you for joining me in this video. I will see you all in the next one. Hello and welcome. In this video, we're going to be covering 4 new commands. Now the commands are pretty straightforward, so it shouldn't be too long of a video, but let's dive right in. So the first command is the last command, ironically. And if we type in the last command and hit enter, what you're going to see is this is actually a log of all the users that have logged in and out. Right now, for me, it's relatively short, right? Because I don't log out very often. I actually keep my system running, and I just really boot it on and on, or on and off, quite a bit. But if you have multiple users running on a machine, if you are signing in and signing out quite frequently on this Ubuntu machine, then this log will be relatively long for you. One thing to note is we could actually do last, and then do dash uppercase F and hit enter. And what you can see is we could change the format of the time here. Right, before we see 1725 up here, this will make it more granular. It'll go to the seconds and then also present us with the year this has occurred. Right, so that's the first command we should learn, right? This is good for if you're ever curious, who is logging in and out on your machine, right? This is a great command for that. This is pretty good from a security perspective of being able to ensure that there are no suspicious users that you didn't create on your machine, right? Let's say you see this user called backdoor or like just extra accounts that you've never created, right? That could be a sign to worry. Next up, we have the ID command, right? And all the ID command is doing here, right? It's basically going to print out information about our current user, right? Or print out information about all the users that we currently have, right? So we see for Ryan, we have this UID of 1000, GID of 1000, right? It also lists all the groups here as well. Keep in mind, if we're only interested in specific pieces of information here, what I could do is I could do ID-U, right? This is going to be for the UID, and then Ryan, and I will get the UID of just, or excuse me, the ID of just the UID. If I wanted to just get this, the GID, unfortunately it's the same in this case, but let's say I just wanted to get that information. I could change this to G and hit enter, and I'll get the 1000, right? This is not the same 1000 as before. This is actually being pulled from the GID instead of the UID. And then last but not least, if I'm only interested in understanding the groups of this user, I could do ID-uppercase G, the account name, hit enter, and you'll see these numbers for the groups listed here, right? So this ID command, it's going to allow us to basically show information on the current users, UID and GID, and the groups that they belong to, right? And if we wanted to see information about different users, what we'd have to do is have to put their username after the fact, right? Let's say I did this for root. ID-U root. We're going to see it has the 0 permissions, which, as we spoke about before, is the most privileges that you could have on a specific user here, right, for their UID. Last 2 commands. We have the who command. When we hit who, all it's going to show us is who is currently logged in on our system, right? That's pretty much it. Pretty straightforward. But we have a different variation of this command. It's just W instead of who. So there's the who command, and then this is short for basically the what command, right? The who command is just saying who is logged in. The who command is basically just saying who is logged in. The W command is doing the same thing, just with an added function. It's saying who is logged in, right? We see Ryan, so we see similar information up here. But it's also saying what Ryan is doing, right? And we could see currently that the Ryan user is running this session, right? This session using the GDM X session path, right? So those were the 4 commands for today, right? Once again, it was last, ID, who, and W, right? These should help us understand a little bit more. 1, what users are on our system. 2, which users are currently logged into our system. 3, what are they doing? And 4, with the ID command, what can they do given their privileges and group access? So thank you for joining me in this video. I will see you all in the next one. Hello and welcome. Before we saw an overview about what symbolic links are, let's use them now, right? The command to use symbolic links is the ln command. So I'm going to run the man page on it and just make this bigger and hit enter, right? And you can see right away, ln allows us to make links between files. The way in which we could use this is we could do ln and then -s, right? So this -s is going to create our symbolic link. And if we go to the man page to look at what -s does, scroll down, right, you could see, hey, make symbolic links instead of hard links, right? The purpose of this is we are about to link our file, a file that exists, to another name, right? We're going to add another name to it, and we will be able to reference that file using both names. So let's create a file here. I'm going to do vim linked file. I'm going to put, hey, how are you? I'm going to hit escape, shift : WQ to quit out, right? You can use nano for this as well, right? And you can see that my file is created here. I'm now going to use the ln-s command, right? And we're going to create a symbolic link. I'm going to use this on linked file. Next up, I'm going to put a name that I want to attach, right? I'm going to add an additional name to this file that we can have it referenced by. And I'll do symlink, right? That'll be the name. And hit enter. Now to check to see if this worked, what I can do is ls-l for long listing format, right? And you'll see right away we have symlink. This is our file that we created before. And then we have linked file, right? So right now, this symlink is currently referencing our linked file, right? We see linked files also on its own currently, but we have this reference to it. The best way to think of this, as I said previously in the overview video, is like a Windows shortcut, right? I could refer to this file and it will usher us over to link file, right? And to show you that, I can now cat symlink and we will see the same exact contents as if I catted the linked file itself, right? So what we've just done is using this ln command, we've created an additional link to the same file, right? We now have 2 different names all pointing back to the same file here. What I could do now is I could also unlink this, right? So I could do unlink, and I'm going to unlink the symlink file and do ls-l to check what happens. Right, as you can see with the unlink command, right, I've just deleted that symlink and now I just have the original file. Right? I can no longer cat symlink, it no longer exists, right? No file or directory, right? And that's how we use the ln command. So thank you for joining me. I'll see you all in the next video. Congratulations on completing section 4, security and file permissions. In this section, we learned how to add users, add groups, change permissions, right? Find out how many users on a system, what those users are doing, and even change passwords for particular users. We also learned a little bit about permissions in Linux, and lastly, security best practices. So before we're done with this section, I have a section challenge for you all. First step, create a new user named practice user, right? Create an empty file named challenge file. Change the owner and group of that newly created file to be practice user. Remember, when we create practice user, it actually creates a group as well simultaneously. And now change the permissions, right? For step 4, change permissions so that the owner has read, write, execute permissions, the group has read, write permissions, and then the world has no permissions. And once you're done with all of that, use ls-l to check your work. I will be posting the solution to this in the resources tab. So be on the lookout for that. But try this challenge out. If you're able to get all 5 of these steps done, then you should feel pretty comfortable with Module 4 here. Thank you for joining me, and I hope to see you all in the next module. Congratulations on making it to Section 5. This is the last section for this particular module of our Linux E degree. And the last 2 things we're going to talk about are more advanced one-line sequences, and we're going to dive deeper into editors. So thank you for joining me thus far, and I'll see you all in the next video. All right, for our first video of Section 5, firstly, welcome. We're going to go over base64 in Linux. Right. So first up, I'm actually going to create something using CyberChef, a website used for encoding, decoding, all that great stuff. I'm going to create a base64 encoded string, and we're going to decode it using Linux. So first up here, we have the input. I'm going to put do not read this. It is secret, right? And the way CyberChef works, which is awesome, is you could figure out what you want to do to this text, right? You could encode it with base64, you could put it to hex, right? We could do hexadecimal here. And even in a lot of cases, it can decode this for you just by understanding what type of encoding is being used here, or encryption in some cases, right? So I'm going to clear the recipe out, right? What I'm going to do here is I'm going to encode this string using CyberChef, right? I'm going to pull over this to base64 option here. I'm going to take this base64 encoded string and I'm going to decode it here, right? So this is the plain text string, right? Plain text is the string itself. This is the encoded string. This is what happens basically when we pivot this over to base64. And I'm going to take this, go to our Linux terminal, and I'm going to show you how to decode. Before we can decode, we actually have to echo that string, right? So I'm going to do echo, right? This is going to print the string out. The reason for this is I can now pipe this output to our base64 command. I'm going to use shift pipe, and I'm going to do base64 space -d for decode and hit enter. Right, and now we can see written in plain text is do not read this, it is secret. Another cool thing we can do is you do not just have to decode, you can also encode here. Right, so what I could do is I could do echo, echo do not read this, and I'm going to pipe it to just base64 without the -d option, and this will actually encode it, right? So I'm going to show you the reverse. Before we use CyberChef to encode and then our Linux terminal to decode, right? Now we're using our Linux terminal to encode, and I'm going to go over to CyberChef. I'm going to clear out all of this. I'm going to paste it, right? And I'm going to use CyberChef now to decode it. Now, even if you don't know that this is base64, right, CyberChef's pretty cool. It has this magic tool that will allow us to figure out what it is, right? It doesn't get it all the time, but if there's only one layer of encoding or encryption, usually CyberChef's pretty good with that. So this is our first video, a little bit on the shorter side. In the next video, we're going to talk more about these one-line commands. So that's the end of our first video. I hope to see you all in the next. Hello and welcome. In this video, I'm going to show you how to manipulate output using commands like tr, cut, right? And we'll even do word count on some of these files. All right, so first up, I'm going to cd to var log, right? I want to go and see files that have tons of information in them. So I'm going to cat, let's start with auth.log. That should be pretty interesting. Right, so this is my unmanaged, unedited file, right? This is without any sort of text manipulation. The first thing we could do, if I'm interested in seeing how many lines are in this particular file, I could pipe this to wc-l, right? This is going to be word count, and it's going to count off of lines, right? So there are actually 109 lines in this document. If we take out the -l, right, you're going to see it includes all. It's 109 lines, 1421 words, and then 12,000 characters, right? So this is the word count command. This is one way to understand output. So as you can understand from this particular command, this file is big, right? So to manually edit this would be unmanageable, right? And this is actually what we're going to start to use Linux for. So if I cat auth.log, I'm going to try to pull only information from, let's choose this, let's go with this column right here. Right, I only want information on this column, right? That's how I'm going to actually pull. So what I need to do is I'm going to use a command called cut, right, after I cat this output, and it's going to retroactively only pull information from things that fall in this column. The way that cut works is I have to count how many columns over and how I'm separating them. So I'm going to choose to separate columns based off of these, right? These colons. I think that's going to be a pretty good way to do it, right? So I'm going to have to count how many columns over I'm going. So this would technically be column 1, column 2, column 3, all the way here. This is column 4, and then we see here is column 5, right? So that's what I'm going to end up pulling here is column 5. All right, so let me show you how I would do that in Linux. I'm going to pull up my cat command. I'm going to pipe this to cut -d, that stands for delimiter, what we want to cut on. I'm going to cut on the colon. And then -f is going to specify which column I want. And we counted it before. I want the 5th column. So if I hit enter, right, we can see it looks like I've successfully pulled from that column. Let me see. Let me cat it one more time. Unlock login keyring. Unlock login keyring. It looks like we might want to go one back. Yeah, let's go back one. Let's do the 4th column. I think I miscounted. All right, so we now have the column that we wanted before. And what I can do now, right, is I could actually edit this even further, right? So if I pull my command back up, let's say I don't want any spaces in the output, right? Now, I know this sounds silly, but let's just say for whatever reason, you're putting this text into a dump and, you need to format your file in a specific way. What I could do is I could pipe this into the tr command that stands for translate. And what translate can do is it can actually delete specific characters that you don't want to see, right? So I could do translate -d, and I'm going to put in here a space. When I hit enter, right, you all probably can see all of the spaces I previously had, like right here, are now gone. I'm going to rerun the command, right? It's now gone. I've taken those out. Now, this doesn't just work for punctuation. It also works if I put, let's say, let's do lowercase u in here and hit enter. Right, I just took out all of the U's instead of Unix. It's now just Nix, right? So there is some manipulation. There's some file manipulation. So once again, this is the command. I want to walk us through it one more time because I know this is probably getting a little complicated, right? This is what prints the initial output. This cuts the output based on the colon as its delimiter, chooses the 4th column and prints that. And then last but not least, we are cutting all of the U characters and all of the spaces here, right? And that's what gets us to our final output here. Now, if we do word count at the end, let's do wc-l, right? You can see we can still count how many lines are in this file, right? But it will no longer print that output, right? So this is a little bit more of a complicated command where we have multiple things going on here. And if we really want at the end, right, as we will show in the next video, we could even use commands like md5sum, right? We could take the hash of this file, and we'll dive deeper into this in the next video, what these hashes mean, what the values are. So thank you for joining me. I'll see you all in the next video. All right, for this video, I'm going to show you how to do hashes in Linux, right, and talk about the value of hashing. So from a security perspective, to hash a file is to ensure the integrity of it. Basically, the way it works is, let's say I have, and let's cd to downloads for this, or let's do documents actually. Let's say I have a file, let's say touch new file, right? What I can do is I could create something called a hash. This is a fingerprint for this file and is going to basically verify the integrity of that file. So if I do md5sum, and I'm going to do it on new file and hit enter, right, we can see the hash of my file here. The purpose of a hash is if I change this file in any way, shape, or form, right, then this hash will change entirely as well. So let's say let's use nano. I nano into new file, and I add hey as a word. I'm going to control X, hit Y, and enter to save. What should happen is when I rerun md5sum, this hash that it prints out should be entirely different, right? And as you can see, that is the case here. All right, what is the purpose of this? Well, think of it this way. Let's say somebody is trying to send you a document. Maybe that document is picked up in the middle by an evil attacker, right, a malicious actor, and they change the contents of it before it gets to you. Using an MD5 hash, right, or a SHA-256 hash, which we'll show in a moment, you can verify that these files have not changed on their way to you. So how does this apply to real life and real life cybersecurity? Well, if I download a file online, right, a lot of times what they'll include is they'll say what the hash of that file is. And what I could do is, let's say, let me make a new file, nano downloaded file, this is a downloaded file, right? So picture this is a file that I've just downloaded online, right? What I could do is I could run MD5 sum on the file, and if this hash does not match the one that is on the website that I downloaded the file from, that means the file is either corrupted, or it may be that a malicious actor has actually changed the file in transit, right? So this is a way for us to ensure, hey, nothing malicious has happened to this file, right? That the file I have on my system is exactly what was intended for me. From a security perspective, that falls under the integrity domain of making sure that files are not modified without permission. However, we don't just do this with MD5 sum. This is actually a pretty short hashing algorithm that has been cracked since then. What we can do is we could also do SHA-256 sums on downloaded files and hit enter. One thing you'll notice immediately is this hash is significantly longer than MD5 sum. That's because it's more secure. There's more bits to it, right? And we could do the same as well with SHA-512 if it is downloaded natively, and it is. Right, we can see that this is a very long hash. What's the downside of using longer hashes? Well, the computational time is much slower. That's also the upside of it. Attackers can't brute force these as easily because it takes much longer to compute a hash like this. Right, but just keep in mind when you're checking the hash of files, you need to make sure you're using the same algorithm as somebody else. Right, so that is a key there. The other thing to note, right, is let's echo hello. Then I'm going to pipe it to a hash. When we hash things, right, keep in mind there are hash crackers online that we have to be careful of, right? If you use an insecure hashing algorithm, what can happen is someone could put your hash here, put it into a website like this. They could click on all the buses. Ooh, that was a car. I'm surprised it let me click on that. Hit crack hash, right? And then sometimes it'll find it. A lot of cases it will not. Right? Let's try to use a different example. Let's do one I think will be on there. Let's say Apple. And I'm going to do this to MD5 sum, MD5. Right, so I could take this hash, throw it in here. I think they'll probably have Apple. I don't know why they wouldn't. Ooh, motorcycles. That one was much easier. Motorcycles, skip. It's a lot of fun. Ooh. Wow, they're really questioning my humanity right now. I'm too good at that. Right, and as you can see here, I've just hashed the word Apple, and because this is MD5 sum and this has been cracked, right, some of these words have actually, can be discovered. So when using hashing for your own personal use, right, it's usually better to use some of these more accepted methods like SHA-256, SHA-512, right? But that's hashing in a nutshell. One cool thing about it is it is not reversible, right? So if I go to CyberChef, right, and do from MD5, right, that doesn't exist. The difference here is they actually, right, something like CrackStation pre-compute hashes. So they'll basically create hashes and compare two different lists. But it's technically non-reversible. It's not like a encryption where the same key that locks can also unlock for symmetric encryption, at least. So that's a quick little lesson on hashing there. Right. Main thing I want us to take out of this video is how in Linux we can obtain these hashes. Right. This is going to be the biggest piece that we should keep from this video. So thank you for joining me. I will see you all in the next video. Hello and welcome to the video. In this one, we're going to go over commands such as sort, unique. We're going to do some review on tr, do some review on cut as well. So in order to do this video along with me, there's going to be a file attached to this course called IP logs. This is what you're going to download. This is what we're going to modify, right? So you're going to have to download it specifically in your VM, right? So make sure you download it in your VM here. So I'm going to cat IP logs, and it's going to become immediately clear to me that this is a lot of output, right? Let's say I just wanted to get these source IP addresses, right? What I could do is I'm going to pull up cat IP logs, my previous command again, so we have initial output to work with. I'm going to pipe this to the cut command, and as we know from before, I'm going to do cut-d for delimiter. Now I'm going to look at the output file and see what delimiter makes sense. Right, and just from a brief inspection, it looks like this equal sign is probably a good thing to cut on, right? So I see equal sign, right? And if I cut properly, I could pull this section here, right? And it'll require a little bit more modification, but that should be a pretty good start for us. So what I'm going to do is I'm going to count how many columns there are. So we have one column here, 2 columns, 3 columns, 4 columns, 5 columns, and it looks like potentially 6 columns is where I will grab this. So let's try that out. Let's do cut-d. We're going to cut on the equal sign. I'm going to do -f, right? This is to specify which column we want, and let's try 6 out. Right? It looks like it worked. We were able to grab all of these IP addresses. However, as you probably know, we don't want this DST at the end. It's actually the start of the next column, right? It's just extra output because our delimiter was not perfect. But what I could do to fix that is I'm going to pipe and do TR for translate, -D for delete, and we're going to delete space DST, right? Should get rid of this at the end. And I'll hit enter, right? And we now have only the IP addresses. So that is it for review. Now what we're going to do, right, is we're actually going to get only the unique IP addresses in this list. In order to do that, I'm first going to sort it, right? I want to see this sorted, so I'm just going to use the sort command. Right, and as you can see, we actually have some additional output at the bottom that we'll probably want to trim. But for the most part, we have properly sorted this output here. It looks like via number first, right? What I'm going to do now is I'm going to use the unique command. And we can see that every IP address now should be unique, right? It should be the case that all of these IPs are non-repeating, right? And just from an initial glance, it does look to be the case. If we do unique-n, unique-c, we could actually see how many times this pops up, each of these IP addresses, right? So once again, if you add the -c option at the end, you can actually count how many times each IP pops up, right? For example, this IP pops up 72 times in our file, right? This IP only pops up once, right? And you know the drill. This is the output we see here. Let's say this is still too much output for us, right? What we could do is if we're only interested, let's say in the last couple columns. Let me go all the way down here. Let's say we're only interested in the last couple columns. What I could do, right, is if I'm trying to trim this, I could just do tail, right? And this will get the last 10 by default, the last 10 rows. You could change the number of tail, right? You could do tail 20 or tail-n20, right? And that'll change the amount of columns you're pulling from, right? So keep in mind that -n actually will specify it. From the opposite side of the token, if we want to get the top 20 results, we could use head, right? We got heads and tails, right? If we use head-n 20 rows, the first 20 rows, we'll see the first 20 rows that pop up, right? Keep in mind this output's still sorted. So this is going from 10.10.0.244 all the way down to 11. So that is the tail command, the head command, the unique command, and the sort command, as well as review for TR and cut, all in one relatively short video. Right, so feel free to take your time with this. Feel free to try to cut on different things. See if you could actually get your output maybe to be even cleaner than getting these last couple ones that we don't want here, these last couple rows. Now, obviously, editing this is not the end of the world. It's pretty easy to cut these all out. But feel free to play around and make that a task. How that you can make this even cleaner. Right? So if we go to IP logs, a lot of different things we could cut on. Right? You just have to get creative. But that's about it. Thank you for joining me on this video. I will see you all in the next one. Welcome back. For this video, we're going to use the file that we used in the previous video, and we're going to go even further with some more commands to manipulate the output here. If you do not have your commands from before, do not worry. It should still be in your history. So if you type in history and hit enter, you can pull back the commands that we've been using previously. Right. First up, I'm going to cat IP logs. Right. This is to remind us the file with IP addresses, all of these different logs, and it's a ton of information that we're going to be trying to filter out. Right. If we pull back up our command that we previously had used, right, we can see that we have successfully pulled out these IP addresses, right? In this case, we're only taking the top 20. Let's actually take that section out and let's see the whole file. So I mentioned previously that you can manually pull out these last couple lines, right? But for this video, I'm actually going to show you how to do this in such a way that it's a bit easier, right? It's more automatic. What we can do is if I pull the command up I just ran, I'm going to pipe this NL line. Or NL command, excuse me. I'm just going to pipe this into NL. And if you haven't noticed, what just happened is it actually is just numbered every line. NL actually just stands for numbering the lines, right? So now what I can do, now that I know the line numbers here, I can actually delete this line all the way down to this one, right? Now that I have these line numbers. And I'm going to do that using the sed command. The sed command is going to be what is allowing us to substitute, or in this case, delete specific lines. So if I do sed and I do single quote, I'm going to do, let's start with line 27256, comma, right? So this is the starting line to delete. I'm going to give this ending line. So comma 272270, right? If I do this, what's going to happen is it's going to use these numbered lines, delete the ones at the bottom, and I will now just have a file of only the IP addresses, right? So we will have successfully edited this. I'm going to hit enter. Oh, I forgot one thing at the end. With sed, after giving the line numbers, you have to put D for delete. And now that we hit enter, we see that the output is exactly the same. The only difference here being that we now no longer have those additional lines, right? Just to show you the delta here, this is what we had before. After writing sed at the end here, and that delete line, this is what we have after, right? So if we just successfully taken this very complex file with all of these different columns and all of these different formatting nightmares, and we've successfully edited it to a format that makes sense, that we enjoy, right? Last thing to note here, right? One more thing that I'd like to show, right? I'm gonna actually clear this line out. So we have this IP logs file, right? If you're ever wondering what type of file you're looking at, you can actually use the file command, right? So if I use file IP logs, I can tell that this is a text file. I'm now going to use this on a file that isn't a text file. I'm going to use it on executable.sh and then example-dir. So if I do file on executable-h or -sh, in this case it says empty. Actually, I didn't know it was empty. Let's just check out what's in here. Oh, it is empty. Let me vim this real quick and let's add a file or add a script. Bin bash. Cool. All right, now if I rerun that, we can now see it is an executable script, right? It is born again shell, stands for bash, or this is the full name of bash. Script, it is an ASCII text executable here, right? So much better. Last but not least, let's do file on example-dir, right? And you can tell it is a directory, right? So file is a great way to figure out what you are actually looking at. The reason why this is specifically important in Linux is because the ending of your file, right, the -sh here, doesn't actually have to matter, right? This doesn't mean that's what the file actually is. For example, if I change this, let's say executable.sh to executable.zip and hit enter, right, you can now see it's listed as a zip. If I run file on it, you will see that it's still listed as a bash script. This is one of the big differences between Windows and Linux. In Windows, the extension at the end matters. If it's not a .exe, it will not execute. In Linux, that is not the case. We can name it whatever we want, put whatever extension at the end, and it will not actually change what it is at the end of the day. So that's it for this video. I'll see you all in the next one. Welcome back. So this video is going to require another file, one that either you create or you could use the one that I will attach to the course. It's going to be called a phone book, right? So what we see here is we currently have a phone book. It's just in a weird format, right? So we see the phone numbers at the top. We see the names under that. And then last but not least, we actually see home addresses right now. Obviously, these are not real home addresses, but this is what we got. So first, what we could do is we need to split this file into three. I need to split it up into phone numbers, then names, and then lastly, addresses. And what I could do in order to get that done is I could use the split command. So I'm going to do split. I'm going to do -L, so I'm going to split on the line. 4, so I'm going to split every 4 lines. I'm going to be splitting the phone book file. I'm then going to name these files, let's just call them split, right? So the syntax here, the split command, -L, so we split on the line. We're going to split every 4 lines. We're pulling from the phone book file that I've just catted, and we're going to spit it out to these split files, which you will see how they are looking like after. Right? So I hit enter, and do ls, right? And you can see we now have split AA, split AB, split AC. And if I cat split AA, for example, you can see it's the first 4 lines. All right, so we are a little bit closer to what we want, right? We see split AB, that's the names, and lastly split AC, the addresses. What I really want though is I want to put all 3 of these files together in a way that makes sense, right? Instead of having it all top to bottom in a list format, I want to have it as a grid, right? I want to have phone numbers on the left, names in the middle, and then lastly on the right is going to be the addresses there. For that, I'm going to use the paste command, right? So we have these 3 split files, right? I'm going to use the paste command, and this is going to basically toss all of these files together for us, right, and create what we want here. So I'm going to do split AA first, split AB second, and then split AC third, right? So all I need is the paste command, and then the 3 files I want to basically hodgepodge together. And when I hit enter, you can see this is a much friendlier format. So now that we have the file properly formatted, I'm going to show us another command. It's going to be the OD command, right? What this will do is it's going to take the output from our last run, it's going to put it into octal format. And I'm going to use the -B option to make sure that this format is actually going to be in a fitting format, right? The -B is going to perfectly put it in octal for us here. So what we have just done is we've converted this ASCII file, this ASCII text file, into an octal formatted file, right? Octal encoding is basically just representing the same file as above, just instead of using things like letters and numbers above 8, right? Using only numbers from 0 to 8, right? You can notice here that not a single one of these numbers actually goes above 8. Now, as always, we can decode this. If we bring this to CyberChef, right? And if I put my input here and I do from octal, right? We can see I can get my original file back, which is pretty neat. So that's one more command to throw under our belt, right? If you ever need to put this into an octal format for whatever reason, right? Most of the time people do this, just for ease of information. Sometimes it's actually to obfuscate data to some extent. This is how you can do that as well. Now what we're going to show you for the last command is going to be the less command, right? So I'm going to run less on our IP logs and hit enter. The reason why this boots up so much quicker than if I just catted the file is it's only showing us a portion, right? So if I do the up and down arrows, I could actually go further down. If I do the right and left arrows, I could scroll horizontally, right? And we could even search, right, using the /. I'm going to search for, let's look for December. Maybe December's in here. Oop, December. And hit enter. Oop, looks like that is not in there. Let's do 8. Right, so I did /8, and now I've highlighted all of the 8s here, right, and I can now go through that. To move forward one page, you can hit the space bar, right, and that'll move you an entire page. To move backwards a page, you can hit the letter B, and that'll move you backwards. But the less command is good for whenever you're reading these dense files that otherwise may take seconds to sometimes minutes to preload. And to quit out of less, all you have to do is hit Q. So thank you for joining this video. I will see you all in the next one. For this video, we're going to dive deeper into Vim and go over a little bit more of the specificities behind it. Right, so I'm going to Vim the IP logs file we were using before. Please make sure to do this video after the previous ones. We're going to be altering this file, so just so we don't throw off anything previously, just make sure that you are doing this in order, right? Doing this video after. So first thing I note, right, in order to edit this file, I have to hit I for insert mode. What I could also do though, right now I can type here and delete. If I do escape and double click D, I can actually delete lines, right? So I actually just deleted that line here. So pay attention to this one right here. If I hit DD, that line is no more, right? So that's ways that we can delete lines with DD. In order to delete specific words, I could do DW, and as you can see, Feb just disappeared. If I do DW again, 25 will disappear, 12:23, right? And it's deleting words every time I do that. Whenever we hit the D command, it puts us into delete mode, right? We can see that right here. I'm gonna hit escape to get out of that mode, right? And we are now back to normal. Other than that, a couple other things to note, right? In order to move left and right, you could either use your arrow keys, or, right, you could use J to move down lines, K to move up lines, right? And keep in mind, it is moving. It seems like it's moving too, but that's really because it's only one line. If I made this smaller, that'd be clearer, right? J, K, right? I'm hitting J, K to move. Up and down arrow keys do the same. If you're in the middle line, you can hit the 0 key, and it'll actually snap you back to the start of the line. Right, so I'm gonna hit 0, snaps me back to the beginning. Let's say I delete a bunch of stuff that I didn't want to get rid of, right? Right now I'm just holding down the delete key. I can hit escape and hit the U key to undo it all, right? So that will allow us to not undo it, right? If you want to undo your undo, you can do Control R, right? And you can see it deletes it back, right? So I'm hitting U to replenish this, Control R to delete it again, right? So they go hand in hand. Make sure, but when you do the U, you have to be out of insert mode, right? So if you see at the bottom here, let's go to insert mode. If you see this word, U will not work. By typing in U, you'll actually just type the letter U, right? As we could see here. I just went full screen. Let's quit out. U, nice. Another cool shortcut is in order to quit out and to save very quickly, we could do Shift ZZ. And this will only save if you have made changes to the file. Otherwise, it will just quit out. Let's say I made a change. Let's just put change here. If I do Shift ZZ, let me go hit escape to get out of insert mode, Shift ZZ, it'll save that change, right? We can see it right here. Otherwise, it'll just quit out like before. So that's a quicker way to quit out and save if you all don't like hitting escape, Shift:WQ. Last but not least, let's say we're trying to quit out of a file. So I'm going to do Shift:Q, and it's saying you can't, right? You actually have the option to override it if it is not allowing you to quit out. You could do :Q and then an exclamation point to force quit out of that file. So thank you for joining me in this video. I'll see you all in the next one. So for this video, we're going to go over the export command as well as the env command and a couple other things here. So to start us off, if I type in env and hit enter, right, I can see all of my environment variables. Now we see some interesting ones like color term here. This controls the color of my terminal. Some people change this to fit their personalized wants, right? But we also see things such as my home directory, right? We see this is my current directory where I currently am. We can see my home directory is /home Ryan, my username, right? So these are all the environmental variables of my system, which is pretty cool. What we can also do, right, is we can export variables, right? If I do export and I do -p, I can see all of the different exported variables that I've been using here, right? Which is pretty cool, right? So this views all of the exported variables on our shell. What do we mean by exported variables? This means that these are variables that I can basically use anywhere just by calling them. Like if I do $pwd, right, I can see, hey, you're currently in this directory, and it will execute whatever it is set to, right? So it's basically the same thing as taking this value here, copy and pasting it into my terminal. In addition to that, I could also set other variables to be true in export, right? So let me do y equals 100, right? I'm going to set variable y equal to 100 here. If we echo it, right, echo $y, you can see that that has been correctly set. Next, I'm going to do export. Let's do export y, right? And what I've now done is I've added as part of my exported variables the y variable to my list. And if I do export -p again, right, you will see I have at the bottom of my list y equals 100, right, which is pretty cool. Right, so I can now use that. Let's say I just wanted to echo 100. I could do echo $y, right, and it will know right away what I'm using it for. Next up, what we can do is if you are curious what operating system you're using on a system, let's say you log in for the first time, you can use the uname command. Right, this will give us some information on our OS, right? So if we man this page, there's a couple other things we could do. We could do -a to get more information. We could try to get kernel name, node name, right? By default, it's just going to give us Linux here. So if we try uname -a, you're going to get all of the information about the system that it can find. So Linux operating system on Ubuntu distribution, right? We see what version it is, when it was first established, right? And information such as that. So thank you for joining me in this video. I will see you all in the next one. That wraps us up for section 5. Thank you for joining me. In summary, we talked about how to modify information, right? How to sort unique values, trim it, cut it, right? Find all of the values that we wanted in these advanced one-line sequences. We also learned a little bit about hashing. We learned about MD5 sums, SHA-256 sums, and SHA-512 sums. We went to pasting and splitting within Linux, right? How do we take a text of one column and split it up into a format that we want? And lastly, we gave a little bit of a deeper dive into Vim, right? A common text editor that you all probably find yourselves working with quite a bit. So that wraps us up for Linux Essentials. Right. Thank you all. You still have a quiz at the end, right, to close out this module and then to close out the Linux Essentials portion of this Linux e-degree. Thank you all for joining me on this. I really appreciate it. And I wish you all the best on your Linux learning journeys. Thank you.